tinta lewat puisi hanya karena cinta kita hadir di sini. Ke Semarang beli lumpia, bertemu gadis cantik parasnya. Selamat datang di kampus penuh cinta. Udinus dengan bangga menyambut Anda semua yang luar biasa. And then let's me introduce the agenda of this opening ceremony. The first agenda is opening, and then followed by speeches from the committee. The third agenda is speech by keynote speaker. The last agenda is closing. Honorable ladies and gentlemen, National Anthem Indonesia Raya.
Selamat datang di kampus penuh cinta. Udinus dengan bangga menyambut Anda semua yang luar biasa.
And then let's introduce the agenda of this ceremony. The first agenda is opening, and then followed by speeches from the third agenda is speech by keynote speaker. The last agenda is closing. Honorable ladies and gentlemen, National Anthem Indonesia Raya. Thank you. Honorable ladies and gentlemen, the first agenda is report from the Chair of Technical Program Committee of International Seminar on Application for Technology of Information and Communication, Isemantic 2021, Dr. Sandy Novianto, Eskom, MT. The floor is yours.
Of International Seminar on Application for Technology of Information and Communication, Isemantic 2021, Dr. Sandy Novianto,
Assalamualaikum warahmatullahi wabarakatuh.
Is yours.
Good morning, all authors, participants, and honorable guests. The distinguished Rector of University Dian Nuswantara, Professor Dr. Insinyur Edi Nur Sasongko, MCom. The distinguished representative of IEEE Indonesia Section, Professor Wisnu Jatmiko as Chair IEEE Indonesia Section. The distinguished representative of IEEE Power and Energy Society as a financial sponsor of Isemantic 2021, Professor Insinyur Arif Nur Afandi, Rector of University Chair IEEE Power and Energy Society. Insinyur Edi Nur Sasongko, dearest honorable guests and all representatives from the universities and other institutions, Professor, the distinguished keynote speaker, and dearest authors and participants for today's webinar conference. IEEE Power and Energy Society to welcome you to the webinar on International Conference to discuss the scope of application for technology of information and communication. As Chair, I'm highly honored to take this opportunity on behalf of our committee and organizers to welcome all of you today to this 6th International Seminar on Application for Technology of Information and Communication, Isemantic 2021. welcome you to the webinar. The Isemantic 2021 International Conference will face big challenges because it is still in a pandemic period. And this does not create an
honored
obstacle for
to
science
take
to
this
continue to grow.
opportunity on behalf of all
Another
committee
challenge
and
is the
organizer
quality of research.
to welcome
The
all of you
standard of
today
research in
to this 6th
2021
International Seminar
Isemantic
on
is the
Application
best
for
research.
Technology of
All
Information
thanks
and
to
Communication,
supporting from
Isemantic
IEEE Indonesia section and
2021.
IEEE Power and Energy
The
Society as
Isemantic
a financial
2021
sponsor
International
and the hard work
Conference
of the
will face big
2021
challenges
Isemantic
because it is still
Committee
in a
to make this
pandemic
happen.
period. And this
Last
does not
years,
create
we
an
have
obstacle for
111
science to
papers
continue to
accepted
grow.
out of
Another
157
challenge is the
submit
quality of
papers
research.
from
The
5
standard of
different
research
countries,
in
including
2021 is
China,
semantic is the
Japan,
best research.
Malaysia, Bangladesh,
All
and
thanks
Indonesia.
to supporting from
All the
IEEE Indonesia
111
section
papers
and
presented last
IEEE
year
Power and
have
Energy
been
Society
successfully
as a
published in
financial
IEEE
sponsor
Explore
and the hard
and
work
indexed
of the
by Scopus.
2021 is Isemantic
And now,
Committee
with the
to
new
make this
topic,
happen.
IT,
Last
opportunity,
years,
and
we have
creativity for
111
digital
papers
innovation
accepted
and
out
communication
of
within global pandemic.
157 submit
There are
papers from 5 different
77
countries,
papers accepted out
including
of
China,
148
Japan,
submit
Malaysia,
papers from
Bangladesh,
7
and
different
Indonesia.
countries,
All the
including
111
United
papers
Arab
presented
Emirates,
last year
Taiwan,
have been successfully
USA,
published
Iraq,
in IEEE
Ireland,
Explore and
Malaysia,
indexed
and
by
Indonesia.
Scopus.
And they are
And
ready
now,
to be
with the new
presented by the
topic,
authors in
IT,
the conference
opportunity,
today.
and creativity
It is
for
also my
digital
honor today
innovation and
to have four
communication
great persons
within
who
global
have agreed
pandemic.
to be
There are
keynote speaker for this
77
webinar.
paper accept out of
The distinguished 4
148
persons
submit
are as follow:
paper from 7 different
Professor
countries,
Saifur Rahman, the
including
candidate for IEEE
United
President
Arab
election,
Emirates,
Joseph Loring
Taiwan,
Professor,
USA,
and Director
Iraq,
Virginia Tech
Ireland,
Advanced
Malaysia,
Research
and
Institute,
Indonesia.
Arlington,
And they are ready to be
Virginia,
presented
USA.
by the authors in
Dr.
the
Muhammad
conference
Sajad
today.
Nazir from
It
Associate
is also
Professor
my
at
honor today to have
Huayin
4 great
Institute
persons
of
who have agreed
Technology,
to be a
China.
keynote speaker
Professor
for this
Insinyur
webinar.
Gamantyo Hendrantoro,
The distinguished 4
Magister
persons
Engineering,
are as
PhD,
follow:
Professor in
Professor
Wireless
Saifur
Communication
Rahman,
and
the
Radio Wave
candidate for
Propagation
IEEE
at
President
Institute
election,
Technology,
Joseph Loring
10
Professor,
November,
and Director
Surabaya,
Virginia
Indonesia.
Tech Advanced
And Heru
Research
Agus
Institute,
Santoso, PhD, from
Arlington,
our
Virginia,
beloved University
USA.
of Dayan Nusantara.
Dr. Muhammad Sajad Nazir, from
Therefore,
Associate
I
Professor
would like to
at
thank all
Huayin
the
Institute of
organizers, supporters,
Technology,
and
China.
organizing committee members
Professor
of
Insinyur Gamantyo
Isemantic
Hendrantoro,
2021 who have
Magister
made this
Engineering,
conference
PhD,
happen.
Professor
I
in
believe
Wireless Communication
that
and
without their
Radio Wave
support and hard
Propagation
work,
at
Isemantic
Institute Technology,
2021 in
10 November,
COVID-19 pandemic
Surabaya,
will not
Indonesia.
have come true.
And Heru Agus
I
Santoso,
believe that by
PhD, from
participating
our
in this
beloved
webinar,
University of
together,
Dayan
let
Nusantara.
us accelerate the exchange of ideas
Therefore,
and
I
scaling
would
up
like
of
to
good
thank
practice.
all the organizers,
We do
supporters,
hope that
and
in
organizing
this
committee
webinar,
members of
Isemantic
Isemantic
is also going to be great
2021
success
who have
like the
made this
one last
conference
year's.
happen. I
And we
believe
have requests
that without
for
their
your
support and
support to
hard
make
work,
this event a
Isemantic
memorable and
2021 in
successfully one.
COVID-19 pandemic will not
Thank
have
you for
come true.
participation and enjoy
I
the
believe
series
that
of
by
webinar
participating in this
Isemantic event.
webinar, together, let us
Wassalamualaikum
accelerate the
warahmatullahi
exchange of ideas
wabarakatuh.
and scaling up of good practice. We do hope that in this webinar, Isemantic is also going to be great success like the one last year.
And we have requests for your support to make this event a memorable and successfully one.
Thank you for participation
Thank you,
and enjoy
Dr.
the
Sandy
series of
Novianto,
webinar
SMMT.
Isemantic
Honorable
event.
ladies and
Wassalamualaikum
gentlemen, the next
warahmatullahi
agenda is
wabarakatuh.
IEEE Epsilon from IEEE Indonesia section from Dr. Ing Wahyudi Hasbi, SSC MCOM. The floor is yours.
Distinguished guests, colleagues, researcher, professional, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning, press and
Thank
warm
you,
greetings.
Dr. Sandy
First of all,
Novianto,
please allow me to
SMMT.
greet the
Honorable
Honorable
ladies
Professor
and gentlemen, the
Dr.
next
Eji
agenda
Nur
is
Sasongko, Rector of
IEEE
Dian
Epsilon
Nuswantoro
from IEEE
University,
Indonesia section
Chair of IEEE
from
Power and
Dr.
Energy
Ing
Society
Wahyudi
Indonesia, Professor
Hasbi,
Afandi, and also
SSC MCOM.
IEEE
The floor
Industrial Electronic
is
Society
yours.
Indonesia sections, General Chair of International Seminar on Application for Technology of Information and Communication, Dr. Sandi, and also our distinguished keynote speakers, Professor Saifur Rahman, Virginia Polytechnic Institute and State University, and also our IEEE President Candidate for 2022. Then Professor Gamanti Hendranto, PhD from Institut Teknologi 10 November Surabaya, as also Vice Chair of IEEE Indonesia Section. Dr. Sasat Nasir from Hawaiian Institute of Technology, China. Heru Agus Santoso, PhD from Dian Nuswantoro University. Distinguished speakers, committee, all participants, ladies and gentlemen. It's such an honor and a pleasure for me to be able to greet you all and give a few words to represent the IEEE Indonesia section at the opening of this conference. On behalf of IEEE Indonesia section, I would like to express my sincere gratitude and welcome you to the 6th International Seminar on Application for Technology of Information and Communication, organized by Dian Nuswantoro University. Distinguished guests, colleagues, researcher, professional, ladies and gentlemen, the 6th International Seminars means that the organizer has established and consistently maintained a high-quality seminar over the years as one of the key performance of a conference supported by IEEE and become a platform to exchange views and disseminate new trends and advances in the respective ICT field. As we all aware, the impact of COVID-19 is felt in every aspect, and there has been a shift in the standard of living. It has strengthened the drive and encouraged intensified collaboration between governments, companies, and non-profit organizations. And it also highlighted the requirement for communities to drag together and handle the risk. In just few months' time, the COVID-19 crisis has brought about years of change in the way companies in all sectors and regions to do business. According to the new McKinsey Global Survey of Executives, their companies have accelerated the digitization of their customers and supply chain interactions and of their internal operation by 3 to 4 years. And the share of digital or digitally enabled products in their portfolio has accelerated by a shocking 7 years. The notion of tipping point for the technology adoption or digital disruption is new, but the survey's data suggests that COVID-19 crisis is a tipping point of a historic proportion and that more changes will be required as the economic and human situation evolve. In such so, I believe that the theme of this conference, IT opportunities and creativities for digital innovation and communication within the global pandemic is very relevant to these rapid changes and is very important in highlighting the innovation to accelerate the shift to digital and fundamentally shake up the living landscape. Distinguished guests, keynote speakers, ladies and gentlemen, IEEE Indonesia as a regional organizational unit of IEEE was founded in 1988. And over the past 33 years, IEEE Indonesia has contributed significantly to various activities to encourage science and technology for humanity in Indonesia. Together with volunteers, members, and all stakeholders, IEEE has produced various activities by supporting more than 20,000 IEEE content publications and more than 260 IEEE journal publications by Indonesian authors since 1988. However, we need to encourage the increase in the number of publications accompanied by inclusivity by conducting research, collaboration, and internationalization higher education activities. IEEE Indonesia has also sponsored and supported more than 60 high-quality conferences every year, including this conference. And compared with the previous year, in 2021, the conference supported by IEEE increased by 49%. The high-qualified conference papers within the scope of IEEE are published in the IEEE Explore Digital Library indexed by Scopus, Web of Science, and any major databases, with more than 5 million and more than with more than 5 million publications and more than 12 million downloads every month. As we all know, IEEE is always maintain high-quality publication as part of our intellectual culture. IEEE Indonesia also holds more than 40 professional, technical, non-technical, and administrative activities for all its members. Currently, we have more than 2,400 members and 60 senior members consisting of professional, industry, academia, and government researchers. IEEE Indonesia also supported 26 technical society chapters and 30 university student branches, including Dian Nuswantoro University Student Branch and 9 IEEE Student Branches chapters. This chapter has become forum for members for various technical and social activities and provide student members a great experience. On July 27, 2021, IEEE Indonesia has established cooperation agreement with Directorate General of Higher Education, Research and Technology to synchronize and support IEEE activities in the Indonesian Ministry of Education, Culture, Research and Technology program, including taking part in the Campus Merdeka and Merdeka Belajar or Independent Campus Freedom to Learn. This historical collaboration shall strengthen the development of Indonesian higher education, especially the 8 leading indicators of higher education in Indonesia. IEEE Indonesia also is exploring cooperation with Indonesian industries in various activities and actively involved in providing input in preparing related government regulations. Ladies and gentlemen, on this occasion, I would like to express my gratitude to all of the Committee of Isemantic 2021 who have worked very hard in preparing for this high-qualified IEEE seminars. I am very aware that putting together an international content of this size is not an easy task. Therefore, I sincerely hope for your cooperation, active participation in all of this conference program. I hope all of you will have an enjoyable and valuable experience during this conference event. So please stay active and stay healthy. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
All of the Committee of Isemantic 2021 who have worked very hard in preparing for this high qualified.
Okay, thank you, Dr. Ing Wahyudi Hasbi, SSE, MCOM. Honorable ladies and gentlemen, the next agenda is IEEE Echelon from IEEE Power and Energy Society from Professor Insinyur Arif Nur Afandi, PhD. The floor is yours.
Thank you, the MC. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Rector of Udinus and all committee of the Isemantic 2021, also all participants in this conference. Firstly, I want to deliver my gratitude to all the keynote speakers for bringing the success this conference in 2020, Professor Saifur Rahman, Professor Kamancho, also Professor Heru Agus, and Professor Sassad Nashil. I believe this conference will be bring the future opportunities to the competition of the industry and more opening our knowledge for preparing our future technology and how to apply in industry also in our human living. In this forum, I want to encourage everyone to join the PES chapter in Indonesia. This chapter was started in January 2015. Now become one of the youth chapter in IEEE Indonesia. So please join and being our community and our team to bring our activity in technology, also knowledge sharing based on the energy and power all related field to develop our activity. Finally, I wish this conference will be one of the flagship conference in our country, also around the world. So please stay tuned in this until the conference of the Isemantic 2020 become finished for all the presenter on parallel session. Thank you. Wassalamualaikum warahmatullahi
wabarakatuh. Thank you, Professor Insinyur Arif Nur Afandi, PhD. Honorable guests, ladies and gentlemen, the next speech is a welcome remark from Rector Dian Swantara University, Professor Dr. Insinyur Edi Nur Sasongko, MCOM.
The conference of the Isemantic 2020 become finished for all the presenter
Bismillahirrahmanirrahim.
session. Thank you.
Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Insinyur Arif Nur Afandi, PhD. Honorable guests, ladies and gentlemen, the next speech is a welcome remark from Rector Dian Swantara University, Professor Dr. Insinyur Edi Nur Sasongko,
and the Almighty for all the blessing and good thing in our life so far, so that we can meet in this 2021 Isemantic at Universitas Dian Swantara, Semarang, Indonesia. First of all, I would like to wish you all a very good morning. In this very important occasion, the first thing to say, we would like to mention our high outstanding keynote speakers today. Our God, the Professor and the Almighty from Virginia Polytechnic Institute and State University in our life, Virginia Technology, so that we can meet today Dr. Muhammad 2021 Isemantic, an associate professor from Huayin, Semarang, Institute of Technology, China. Dear all respected Professor Engineer in this very important occasion, Magister Engineer PhD, mention a professor of wireless communication and radio wave Professor Saiful Technologies from Virginia Polytechnic Institute and State University, Virginia Technology. A senior lecturer Muhammad from Nasir University, an associate professor from Huayin Institute of Technology, China. Honorable researcher, Professor Engineer Kamayanto Hindrantoro, we thank you very much for coming to PhD and being here Professor of Wireless Communication and Radio Wave. We grateful and proudly welcome you all on this international seminar on application of technology of information and communication of the 2021 Isemantic Universitas Dianuswantoro Semarang, Indonesia. I would also like to wish all of researchers, all your family, and all your colleagues the great health and safety during this unlucky pandemic circumstances with us today. May God bless you. Be grateful and proudly welcome you all on this international seminar on application for technology of information and all medical professionals who have given 2021 Isemantic in the front lines of this long pandemic crisis. Indonesia. I would also like to wish all of you, Amin, all your family, Alhamdulillah, and all your colleagues the great health and safety during this unlucky pandemic circumstances. Blessing and great health and the safety granted to us all. I would also like in this pandemic situation, all the we still encourage ourselves and all medical professionals to maintain the patient who have given conducting their best health service in the front line in the line of this long pandemic crisis. May God also bless you all. IT opportunity and creativities, Alhamdulillah, innovation and communication within the global pandemic. God the Almighty, for the present as well as the development of technology for information and the communication are the main key pandemic situation. For all researchers, we still encourage all the challenges in the future to maintain the patient. We also encourage researchers, all of you to join in the line with the topic of today's active participation. IT opportunity all creativities and digital innovation. We hope that this conference can be a good platform for academic exchange as well of information and knowledge of technology, on the development for information and communication technology are the main and also good platform for new collaboration all the challenges and academicians, scientists. We also encourage practitioners, all of you, to join the seminar. We appreciate all the steering committee of the seminar, and we also thank the conference management and expectation. Our appreciation. We hope that this to all the reviewers can be good platform as well as exchange of information and knowledge on the development and innovation of information technology, and also good platform for new collaboration. We also mention academicians, scientists, and other IEEE of Indonesia section. IEEE all the steering committee of the seminar, and IEEE the conference Power and Energy Society. Our appreciation also thank you all the reviewers and other collaborative as well as for their participation for their conferencing process contribution for this great 2021. The last to say, we all great learners. We also want to give our cooperation research finding to work IEEE of this 2021 Isemantic. IEEE of Universitas Dianuswantoro Press and IEEE of Power and Energy Society will lead to positive change. We thank you our life as well as the life collaborative support. Therefore, your participation should enhance process the innovation and their function to applicable the last to daily life all of our society. We all want to give finally a research plan of concept and experience to result in high quality. The innovation contribution is important unique finding. A research can become a good practice with a great benefit for all society. Our life as well as the life also gradual transfer. Therefore, research goodness with its good effect, the innovation impact to people function in the general applicable in the daily life. Thank you very much again. Our society. Wassalamualaikum warahmatullahi wabarakatuh. A plan of Universitas and experience to result in high quality innovation and its unique finding. A research can become a good practice.
Thank you,
with
Professor
a great
Dr. Engineer Edi Sasongko, MCom, for a warm welcome and hospitality toward our committee and participants. Honorable ladies and gentlemen, now let's enjoy video presentation of Isemantic journey through the year.
Wassalamualaikum warahmatullahi wabarakatuh.
Information technology, or IT, plays an important role in supporting human life and civilization. It does not only make our life easier, but also preserve our culture. The Nuswantara University Semarang initiate Isemantic as a place to develop information technology and opens the discourse of critical thinking scope among the academics and the Indonesian societies. Information Technology, or International Seminar on Application for Technology of Information and Communication, or widely known as Isemantic, is an international seminar held annually and covering multi-field studies, including engineering, economy and economics, health and culture. Even more, researchers, lecturers, students, and industrial societies are welcome to join this seminar. International Seminar on Isemantic through the years has been accepted by the academic world enthusiastically. Many keynote speakers from Indonesia's top universities and international top universities have come and cooperated in this event. Hundreds of papers have been published, along with interestingly different and challenging themes each year. Societies are welcome in 2016, highlighting the importance of science and technology in assisting society towards a better life and future. Isemantic presented Science and Technology for a Better Future as the theme. The keynote speakers from Kementerian Riset Teknologi dan Pendidikan Tinggi, or Ministry of Research and Technology, California Polytechnic State University, School of Electrical Engineering and Informatics of ITB, and Nanjing Jichen Medical Technology of Nanjing, China, towards a better life and future. The Isemantic presented Science and Technology for a Better Future. In order to achieve a better human life, our society needed empowerment to bring out the best of Ministry of Research and Technology. The team Empowering Technology for a Better Human Life was chosen Electrical Engineering and Informatics of ITB. The keynote speakers from Kementerian Kelautan dan Perikanan Republik Indonesia, China, or Ministry of Marine Affairs and Fisheries Republic of Indonesia, in 2017, University of Technology, in order to achieve a better human life on how our society needed empowerment to bring out the best of human and how technology has changed the theme Empowering Technology for a Better Human Life was chosen in 2018 seminar. Creative Technology for Human Life was from Kementerian Kelautan dan Perikanan Republik Indonesia, health, literacy acceleration in our society, and fisheries. The keynote speakers from University of Technology, and Tokyo University of Technology, or Indonesian Institutes of Sciences, on how technology and Taipei Medical University talk about the importance of life quality improvement, has changed the face and future sustainability and national culture preservation. In 2018, In 2019, for human life, was the 4.0 industrial era, along with the needs of our society considered the economics, technology, and
The keynote
communication.
speakers from University of
The keynote
Technology
speakers
Sydney,
from Kementerian
LIPI,
Riset
or
Teknologi
Indonesian
dan Pendidikan
Institutes of
Tinggi Republik
Sciences,
Indonesia,
and Taipei
or
Medical
Ministry of
University
Research and
talk
Technology,
about the
Republic
importance
of
of
Indonesia,
life quality
Curtin
improvement,
University of Australia,
environmental sustainability,
Kumamoto University
and national
Japan,
culture
and
preservation.
Mitsubishi Electric Corporation
In
Japan.
2019, the birth of
Renewable
4.0
energy
industrial
resources
era
and
had
digitalization
changed
of
the way our
conventional
society
industry
considered
were
the
two main
economics,
discussion in the
technology,
seminar.
and communication. The keynote speakers from Kementerian Riset Teknologi dan Pendidikan Tinggi Republik Indonesia, or Ministry of Research and Technology, Republic of Indonesia, Curtin University of Australia, Kumamoto University Japan, and Mitsubishi Electric Corporation Japan.
tourism sites.
Renewable energy resources and digitalization of conventional industry were two main discussion
The
in the
night before
seminar.
they departed, a warm dinner was held to close the whole event of Isemantic as a remembrance of the friendship among participants of Semarang tourism to the world.
Assalamualaikum.
Amidst the global pandemic of COVID-19, the Nuswantara University made a great virtual step on the execution of the 2020 Isemantic. The 2020 Isemantic, with the theme IT Challenges for Sustainability, Scalability, and Security in the Age of Digital Disruption, was held through online conference platform. The keynote speakers from the Nuswantara University, University of Auckland,
Amidst the
and
global
Tokyo
pandemic of
University of
COVID-19,
Technology,
the
Japan,
Nuswantara
shared
University
the
made a
importance
great
to
virtual
stay
step
adaptive
on the
through the digital
execution of the
disruption era.
2020 Isemantic.
Finally,
The
today,
2020 Isemantic,
information technology
with the theme IT
opportunities
Challenges
and
for
creativities
Sustainability,
for digital
Scalability,
innovation
and Security in the Age of
within
Digital
global
Disruption
is
was
the
held
theme
through
of the
online conference
2021
platform.
Isemantic.
The keynote speakers from the
With the
Nuswantara
IEEE
University,
publication and
University
Scopus
of Auckland,
indexation,
and Tokyo University of
hundreds of
Technology, Japan,
manuscripts are
shared
ready
the
to be
importance
presented
to
and
stay
reviewed
adaptive
through
the
the
digital
online conference
disruption
platform
era.
of the 2021
Finally, today,
Isemantic.
information technology
The keynote
opportunities
speakers
and
from Virginia
creativities for
Polytechnic
digital
Institute and
innovation
State
and
University,
communication within global
Institut
pandemic
Teknologi 10
is the
November,
theme of the
Dia Nuswantara
2021
University,
Isemantic.
and Hua-Yin Institute
With the
of Technology of
IEEE
China
publication
will
and Scopus
present
indexation,
interesting, challenging, and
hundreds of
mind-sparking
manuscripts
discussion
are
to
ready
us.
to be presented and reviewed through the online conference platform
Honorable
of
ladies
the
and
2021
gentlemen, the next session follow is a photo
The
session.
keynote
We have
speakers
certain
from
conduct to
Virginia
follow, which are
Polytechnic Institute and
first
State
photo
University,
session. We would like to
Institut
invite all
Teknologi
keynote
10
speakers
November,
on Zoom
Dia
camera.
Nuswantara University, and Hua-Yin Institute of Technology of China will present interesting, challenging, and
Don't forget to
mind-sparking
give
discussion
the
to
best
us.
smile, please. Honorable ladies and gentlemen, the next session follow is the a committee will
photo
be take the
session.
picture.
We
We have certain conduct to follow, which are first photo session. We would like to invite all I keynote
think it's
speakers
enough.
on Zoom camera. And then the next photo session, we would like to invite all keynote speakers and Mr. Sandy as the chair of the technical program committee on Zoom camera. The best smile, please. Also give the best smile. Take the picture. Thank you very much. Thank you for the photo session, and let us prepare ourselves for the next session. And then the next photo session, we would like to invite all keynote speakers and Mr. Sandy as the chair of the technical program committee on Zoom camera. Also give the best smile. Thank you very much. Thank you for the photo
Ladies
session.
and gentlemen, the next agenda is seminar and discussion with our today's keynote speakers.
This session will be guided by Professor Dr. Jumanto from Dianuswantara University and Titin Soehartini, Eskom Master of Engineering from Dianuswantara University. But before we start, let me read a brief biography of the moderators. Jumanto, or Jumanto, completed his doctorate degree, a PhD in linguistics from Universitas Indonesia in 2006. He is now a professor of linguistics, especially of this session will be guided by and Professor English Language Teaching from Dianuswantara University postgraduate studies since 1992, head of English Department, Faculty of Humanities. Before we start, his most recent office is a member of CUA, Center of Excellence, Universitas Dianuswantara Semarang, Indonesia. His doctorate degree, and then PhD in linguistics from Universitas Indonesia Master of Engineering, lecturer is now a professor of linguistics Department Dianuswantara University. Pragmatic. She achieved her bachelor degree in information system and master degree in electrical engineering and information head of English Department, Faculty of Humanities. To today's moderators, his most recent office is a member of CUA, Center of Excellence, Universitas Dianuswantara Semarang, Indonesia.
Thank you very much, Mr. MC.
Titin S. Sukamto, Eskom Master of Engineering, lecturer at Information System Department, Dianuswantara University. She achieved her bachelor degree in Information System and master degree in Electrical Engineering and Information Technology.
Ladies and gentlemen,
to today's moderators, the floor is yours.
Very good morning. And also very good evening on the other side of the world. All the clinicians, all the researchers at Dianuswantara University,
distinguished Heri Pamungkas,
all the researchers all over the world, particularly
Assalamualaikum warahmatullahi wabarakatuh.
And very attentive
May
to
God
this
bless us all.
2021 Isemantic
Ladies and gentlemen,
seminar on application for
dearest,
technology
most distinguished ladies and gentlemen,
and
first of all, we are wishing you good morning, very good morning, and also a very good evening on the other side of the world. All the Dianusians, all the researchers at Dianuswantara
to this webinar
University,
2021 Isemantic. This is the sixth Isemantic and the second webinar Isemantic.
And very attentive to this 2021 Isemantic in the seminar on application for technology of information
this
and
2021
communication
Isemantic,
of this very
we
year,
are raising the topics
2021,
about
or we call
opportunity
it the
and
2021
creativity
Isemantic.
of course, information technology.
Welcome.
The theme
Welcome.
of the 2021
webinar,
Isemantic today,
2021
as you have
Isemantic.
noted, is
the
IT
sixth
opportunities
Isemantic
and
the second
creativities
webinar
for
Isemantic.
digital innovation and communication
Well,
within the
distinguished
global
audience, we
pandemic.
all probably live by
Well, ladies and
information
gentlemen,
technology
opportunity
today.
refers to a situation
Within this
or
2021
circumstances that
Isemantic,
something
we
can
are
be
raising
done.
the topics
This
about
something is of
opportunity
information
and
technology,
creativity
having to do with probably
of course,
break,
information technology.
chance,
The theme of the
occasion,
2021
opening,
Isemantic today,
room,
as you have
and
noted,
shot.
is IT
Meanwhile,
opportunities
creativity
and
refers to the
creativities
ability
for
to
digital
create,
innovation
having
and
to do with
communication
probably
within the
cleverness,
global pandemic.
creativeness,
Well, ladies and
imagination,
gentlemen, opportunity refers to a
imaginativeness,
situation or
ingeniousness,
circumstances
ingenuity,
that something can be done.
innovativeness,
This
invention,
something is of information
inventiveness,
technology, having to
originality.
do with probably break,
Well, ladies and
chance,
gentlemen, to
occasion,
elaborate the opportunity
opening,
and creativity
room,
of IT
and
today,
shot.
in this very great
Meanwhile,
occasion,
creativity
we would like to
refers
present
to
to
the
you
ability
the
to
outstanding
create,
of keynote
having
speakers.
to do with probably
Professor Saifur
cleverness,
Rahman from Virginia
creativeness,
Polytechnic Institute and State
imagination,
University, Virginia Tech,
imaginativeness,
Dr.
ingeniousness,
Muhammad Sazat Nazir
ingenuity,
from Huayin Institute of
innovativeness,
Technology,
invention,
China, Professor
inventiveness,
Gamantio Hendrantoro
originality,
from
Mesti Tin.
Institut Teknologi
Well,
10 November
ladies and
Surabaya,
gentlemen,
Indonesia,
to elaborate
and
the
Dr.
opportunity
Heru
and
Agus
creativity
Santoso
of
from
IT
our beloved
today, in this
Universitas
very great
Dianuswantara.
occasion,
Prof. Joy,
we would like to
Well,
present
ladies
to
and
you the
gentlemen,
outstanding
the
of keynote
presenters today
speakers.
will speak to you
Professor
one
Saifur
after
Rahman
the other,
from Virginia
so
Polytechnic
you all
Institute
will
and
feel
State
convenient
University,
to
Virginia
focus
Tech,
on their respective
Dr.
topics
Muhammad
and
Sazat
discuss
Nazir
with them
from
one
Huayin
by
Institute
one
of
to the
Technology,
best of your
China,
interest as
Professor
well as
Gamantio
of
Agusantoro from Institut Teknologi 10 November Surabaya, let's start with presenter 1, shall we? Dr. Heru Agusantoso from our beloved Universitas Dianuswantoro of Joy.
Ladies and gentlemen, the presenters today will speak to you one after the other, so you all will feel convenient to focus on the respective topics and discuss with them one by one to the best of your interest as well as of your comprehension.
To your being here, Professor.
Okay. Let's start with presenter 1, shall we? Professor?
Performances throughout the world.
Well. Now we are coming to the show. Okay. We're coming for the first show. We are
Professor
coming
Saifur
to
Rahman, an
Professor
expert in
Saifur
alternate
Rahman.
energy
We'd like to
from
greet the
Virginia
gentleman.
Polytechnic Institute
Professor
and State
Saifur Rahman, are you
University,
here?
Virginia
Are you with
Tech.
us today?
Professor Rahman today will be talking about
Waalaikumsalam
Internet of
warahmatullahi
Things.
wabarakatuh. Well, this expert is, we've been looking
sensor
forward
integration
to
for
your being
digital
here,
control
Professor.
of the building
Well, we have
environment
noted
in a
your
smart grid ecosystem.
performances
Well, this
throughout
is
the
very
world.
great
Well,
topic.
thank you very much for being
But
here.
before
We'd
that,
like to
hold on a minute.
say something before your presentation.
Let's listen to
Professor
some
Saifur Rahman,
introduction
an expert
by
in alternate
Mr. Tin to our
energy
Professor
from
Saifur Rahman
Virginia
here. Mr. Tin,
Polytechnic
please.
Institute
Excuse
and
me, sir.
State
I would like
University,
to
Virginia
read
Tech.
your brief
Professor
bio.
Rahman today
Professor Saifur
will be
Rahman,
talking
PhD,
about
from Virginia Polytechnic
Internet
Institute
of
and
Things,
State University, Virginia Tech.
IoT, sensor
Currently, the
integration for
candidate
digital
for
control
IEEE
of the
President-elect
building environment
Joseph
in a
Loring,
smart
Professor
grid
and Director,
ecosystem.
Virginia
Well, this is
Tech
very great
Advanced
topic.
Research Institute,
But before
Virginia.
that, hold on a
Received
minute.
his
Let's
bachelor degree in
listen to
Electrical
some
Engineering,
introduction
Bangladesh University
by
of
Mr.
Engineering
Tin
and
to our
Technology,
Professor Saifur Rahman
Master
here. Mr.
of
Tin, please.
Electrical Engineering
Excuse me, sir. I would
from
like
State
to
University
read
of New
your
York,
brief
and
bio.
PhD degree from
Professor Saifur
Electrical
Rahman,
Engineering,
PhD
Virginia
from
Tech.
Virginia Polytechnic Institute
In
and State
2000,
University,
he had
Virginia
awarded
Tech.
the IEEE Millennium
Currently, the
Medal for
candidate
outstanding
for IEEE
achievements and
President-elect
contributions to IEEE.
Joseph Loring, Professor and
In
Director, Virginia
2011,
Tech
he received
Advanced
the
Research
IEEE
Institute,
USA
Virginia.
Professional Achievement Award.
Received his
In
bachelor degree in
2012,
Electrical
received the
Engineering,
Meritorious
Bangladesh
Service
University
Award,
of Engineering
the
and
highest
Technology,
award bestowed
Master
by Power
of Electrical
Energy Society.
Engineering from State University
2013,
of New York,
awarded
and
Outstanding Power
PhD degree
Engineering
from Electrical
Educator
Engineering,
from PASS.
Virginia Tech.
2014,
In 2000,
honorary
he
of
had
the
awarded
IEEE
the
Technical
IEEE
Activities
Millennium
Board
Medal
Heart of
for
Honor.
outstanding achievements
He has
and
helped
contributions
IEEE
to
Indonesian
IEEE.
section a lot.
In 2011,
And
he received the
he,
IEEE USA Professional
Research
Achievement
interests
Award.
are
In
alternate energy,
2012,
critical
received the
infrastructure
Meritorious Service
assessment and
Award,
modeling,
the highest
uncertainty
award
evaluation,
bestowed by
environmental
Power
impact.
Energy Society.
Wow, such a great
2013,
biography, sir.
awarded Outstanding Power Engineering Educator from
what
PASS.
an achievement, Professor Rahman.
2014,
Well, and we are
honorary
happy to have
of the
you here.
IEEE Technical
This is
Activities
the
Board,
world
Hall
expert
of Honor.
coming to
He has helped
virtual
IEEE Indonesian
University
section
of
a lot.
Dianuswantoro. Well, we
And
are very proud as
he,
well as
research
very
interests
happy
are
for your being
alternate
here
energy,
among us.
critical
Okay,
infrastructure
without much further
assessment and
ado, we're
modeling,
coming to the presentation,
uncertainty
the first
evaluation,
presentation of
environmental
Isemantic
impact.
2021
Such a great
with Professor
biography, sir.
Rahman. Professor Rahman, you can start now.
What
with,
an achievement,
please make it
Professor Rahman.
convenient
Well, and we are
in
happy to have you
40
here.
minutes.
This is the world
Okay,
expert
it will start from now.
coming to
Thank you very
virtual
much.
University of Dianuswantoro.
1 second.
Well, we are very proud as well as very happy
Selamat
for
pagi.
your being
Assalamualaikum
here
warahmatullahi
among us.
wabarakatuh.
Okay, without much further ado, we're coming to the presentation, the
You know,
first
you have
presentation
given
of
a long
Isemantic
introduction for me.
2021 with Professor Rahman.
Not very long.
Professor Rahman, you can start now.
What is missed
please make it convenient.
is
in
I've been to Indonesia
40
many times.
minutes. Okay, it will start from now.
Bicara bahasa Indonesia
Thank you very much.
sedikit-sedikit.
Oh, wow.
I have given lectures at Trisakti University in Jakarta, UI in Jakarta, ITB in Bandung. I spent 3 months in Palembang lecturing
Not
at
very long.
Unsri. I have been to Semarang. Pak Anggoro took me there 3 years ago. I have not been to Universitas Dianuswantoro yet. Inshallah, I'll be there soon. So
Sorry, Professor Saiful, you were already in University I think 4 or 5 years ago.
That's right. That's one lecture. You're right.
Yeah,
exactly. So I come from Bangladesh originally.
So I
lecturing at
like
Unsri.
Indonesian food.
I have been to
I like
Semarang,
Indonesian people.
where
I like
Goro took me
Indonesian
there
culture.
3 years
The
ago.
good thing is,
I have not been
Bahasa
to
Indonesia,
Universitas
easy
di
language to
Nuswantara
learn. I
yet.
learned in 2 months.
Inshallah,
I
I'll
could
be
speak
there
fluently,
soon.
not in English.
Sorry, Professor Saiful, you were already in
So
Udinus.
I am a
think
familiar
4 or 5
person
years ago.
in Indonesia. I wish
That's right.
this
That's
meeting
right.
was
That's
face to
one
face.
lecture. You're right.
But
One
anyway,
lecture.
inshallah, we'll do
So
this.
I come from
So
Bangladesh originally.
back
So
to
I like
the
Indonesian
topic.
food. I like
Speech
Indonesian
today,
people.
we focus
I like
on
Indonesian culture.
smart
The good
buildings,
thing is,
smart
Bahasa
grid,
Indonesia
and
is
IoT
easy language to
sensors.
learn. I
So
learned
let's
in
move
2
on
months. I
with
could
that
speak fluently, not in
knowledge
English.
going forward. We have
So I
developed
am
what
a
is called
familiar person
open
in Indonesia. I
architecture
wish this meeting
platform
was face to
for
face.
building
But
energy
anyway,
efficiency.
inshallah.
That's our research. If you want to know more, there is a website, the yellow box on the right-hand side, www.demoss.org. If you go there, you'll find my algorithm, technical papers, test bed, all that is there, if you want to know more.
Forward.
So what we have done,
We have
we have developed
what is
a
called
building
open
energy
architecture
management, open
platform
architecture
for
software
building
solution
energy
that
efficiency.
can
That's our research. If you want to
can
know
be
more,
used
there is a
to
website,
sense
the
and
yellow box
control
on the right-hand side,
any IoT device, for commercial building.
demoss.org. If you go
Our
there,
application
you'll
has been
find
so
my
far in the area of
algorithm,
heating,
technical papers,
ventilation, air
test bed, all
conditioning,
that is there. If you want to
lighting
know.
load, plug loads.
So what
And
we
result
have
has been
done,
we give you
we have
better
developed a
air
building
quality in the building
energy management
and provides
open
energy savings.
architecture software solution
Why is
that
air quality important in a building, especially with
can be
COVID-19? You have
to
to know
sense and
if the
control
building ventilation system
any
ventilation
IoT device,
has
or
virus.
commercial
We
buildings.
can do that fairly easily
Our
with this
application has been so
platform.
far
We'll talk
in the
about
area
that more
of
later on.
heating,
This is my lab
ventilation,
to show you, as many of your
lighting
professors,
load, plug
you
loads.
teach labs,
And
how
result
we
has been
built it.
we give you better
This is a floor
air quality in the building.
in my building on the
provides
left-hand
energy
side.
savings.
We put
Why
in the
is
lab
air
different
quality
kinds of
important in a building,
thermostats on the
especially
left-hand
with
side.
COVID-19?
There are 1
You have
to
to
5
know
thermostats
if the
here,
building ventilation
controlling
system
the
ventilation
volume of air,
has
DAV controller,
virus. We
rooftop
can do
unit,
that fairly easily
smart
with this
light bulb,
platform.
light
talk
switch,
about that more later.
lighting load
This is
controller,
my lab to show you,
dim
as
ballast,
many of your
smart
professors,
plug,
you teach
different
labs,
kinds,
how we
Wi-Fi
built it.
smart plug, Zigbee smart
This is a
plug,
floor
backnet controller,
in my
occupancy
building on the
sensor,
left-hand side.
light sensor,
We
and power
put in
meter,
the
all of that in the
lab
lab.
different kinds
The
of
point I'm trying to
thermostats on
make
the
is
left-hand
we
side.
have built a
There are
platform
1 to 5
which can talk
thermostats
to any of
here,
these devices and controlling the
controlling
light
the volume
intensity,
of air,
control
DAV
your
controller,
temperature,
rooftop
control
unit,
ventilation, all of that.
smart light
In the
bulb,
beginning, we
light
used something
switch,
called Raspberry
lighting
Pi,
load
very small
controller,
microcomputer. The Raspberry Pi
dim
is sitting
ballast,
inside
smart
this gray
plug,
color plastic
different
box.
kinds,
It is
Wi-Fi
collecting
smart plug,
information,
Zigbee
Wi-Fi,
smart plug,
all these
backnet
devices,
controller,
some
occupancy
devices
sensor,
on the upper
light
right-hand
sensor,
side
power
are
meter,
not
all of that in the
Wi-Fi. These
lab.
are analog,
The point I'm
backnet
trying to make
models.
is
We have put
built a
an IP
platform
converter.
which can
It
talk to any of these
receives analog
devices and
signal
control your light
and provides
intensity,
Wi-Fi signal
control your
output. That's how we do
temperature,
this. All that
control
is done.
ventilation, all
This
of
is
that.
one
In
building.
the beginning, we used
The
something
point
called
is,
Raspberry Pi. Very
we
small
have to
microcomputer.
be very
The Raspberry
careful
Pi
in
is
terms
sitting
of
inside this gray color
technology.
plastic
What
box.
does it
It
mean?
is collecting
As you, some
information,
of you know who
Wi-Fi,
teach
all
communications,
these
there are many,
devices,
many
some devices
technologies for
on the
communication,
upper right-hand
Ethernet,
side are
serial
not
interface,
Wi-Fi. These
Zigbee
are
Wi-Fi,
analog,
many
backnet
different kinds,
models.
right?
We have put
Also
an
have data
IP
exchange
converter. It
protocol,
receives analog
backnet,
signal
Modbus,
and
Web,
provides
Zigbee,
Wi-Fi signal.
Smart Energy, Open
That's how
ADI.
we do this.
Our
All that is
challenge
done.
was,
This is
we are a
one
university, we
building.
don't make hardware. We buy
The
hardware
point is,
from the market.
we have to be very
A vendor
careful
for a
in
hardware
terms of
thermostat, smart
technology.
plug,
What
smart
does
switch,
it mean?
use the
As you some of you
protocol
know who
they
teach
feel secure.
communications, the
We
many
developed some
technologies for
translation
communication,
where
Ethernet,
we could
serial
take
interface,
any
Zigbee
signal
Wi-Fi,
on
many
the list
different
of
kinds, right?
10 on the left-hand
Also have
side,
data exchange
convert that to
protocols,
IP or
backnet,
Wi-Fi and
Modbus,
run it.
Web,
That was our contribution.
Zigbee,
It works
Smart Energy, Open ADI.
well so far.
Our challenge was,
So this was
we are a
one
university,
building,
we
not
don't
a
make
campus, like
we
two
buy hardware
purpose or your Unidian
a vendor
Nuswantara
for
campus,
hardware
whereby
thermostat,
you have many
smart
buildings.
plug, smart switch.
We have done this
Use
idea
the
now,
protocol they
rather
feel
than
secure.
putting
We
a
developed
small
some
microcomputer
where
in a
we
building.
could take any
Most buildings
signal
today have
on the
internet.
list of
So we have
on the left-hand
cloud
side,
account now.
convert
In the
that to
cloud
IP
account,
or
we
Wi-Fi,
will
and run.
host
That was
our
our
algorithm.
contribution to what.
That's BMOS algorithm, hosted there.
So
Each
this was
building has
one building,
an
not a
account in the
campus,
cloud,
like UI
because
campus
internet
or your
send signals,
Unidian
receive signals,
Nuswantara
and work on.
campus,
This is
whereby
how we
you have
can
many
guarantee
buildings. We have
occupant
done
comfort,
this idea
demand
now,
management,
rather
energy
than putting
savings,
a
security
small
surveillance, alarm
microcomputer
notifications.
in a
All that is
building.
going on today.
Most buildings
Also,
today have internet.
our
So we
cloud
have
has
cloud
connection
account
to
now. In the
power
cloud
company like
account,
PLN,
we will
power
host
company.
our
They
algorithm.
send signals for load
That's
control, we
BMOS
receive it
algorithm hosted
and take
there.
action. That's
Each building has
happening
an account
in
in the
our
cloud
situation
because
today.
internet
Now,
sends signals, receives
in
signals.
addition to
This is
controlling
how we can
temperature,
guarantee occupant comfort,
ventilation,
demand
light
management,
intensity,
energy
we did two other
savings,
things.
security
Look at
surveillance,
this issue here.
alarm
We
notification.
have some numbers.
All
These
that
are
is going
data
on
from our
today.
experiment.
Also,
We see typical
our
building
cloud
cooling and
has
heating
connection
situation.
to
By controlling
power
some
company like
temperature
PLN,
set point, we
power
can
company.
save about
They send
20%
signals
energy
for
on
load
an annual
control. We
basis.
receive it and take
Lighting
action. That's
control, by
happening
dimming some
in our
lights,
situation
scheduling light
today.
on and off, we save about 25%.
In addition
That's
to
fine.
controlling
But
temperature,
important discovery was the
ventilation,
second two bullets.
light
Improved
intensity,
operations
we did two
and
other
maintenance.
things. Look at
We
this issue
developed a
here.
product called
We
WISE
have some
building,
numbers. These are
WISE
data from our experiment. We
that
see typical
enables
building cooling and heating
operators
situation. By
to
controlling some temperature set point, we
monitor
can save about 20%
the
energy
power
on an annual
consumption
basis.
on any device.
Lighting
Example,
control,
you
by
have an
dimming
air
some
conditioner
lights,
on the building
scheduling
roof.
light
We
on and
monitor
off,
the
we save
air
about
conditioner
25%.
motor
That's
power
fine.
draw current
But
voltage in real
important
time. Every
discovery
minute we
was
measure
the
it.
second two
If
bullets.
the air
Improve
conditioner
operations and
compressor
maintenance.
is running
Develop a
tight
product
because of
called
a
WISE
dirt
building,
or some
WISE
bearing problem, it draw
that
more current.
enables
As soon as it begins to draw
operators
more than normal current, we send a signal to the
monitor
building engineer, come look at it. And they can
power
fix things before it
consumption
breaks down.
on any
That's
device.
operation
Example,
maintenance.
you have
Other
an
thing
air
is
conditioner on the
occupant
building roof.
satisfaction.
We
We
monitor
monitor
the air
in
conditioner
the
motor
building
power draw current voltage
many
in real
things.
time.
One is
Every
carbon
minute we're
dioxide.
measuring.
We can also
If
monitor
the
PM
air
2.5,
conditioner compressor
SARS-CoV-2
is running
virus
tight because
concentration.
of a dirt
Based on
or
that,
some
we send
bearing
action to
problem,
keep the building
draw more
more
current. As
healthy.
soon as it
Now,
begins to draw
some
more
examples.
than normal current, we send
We
a
have
signal to
deployed our
the
solution
building
in many
engineer
buildings
come
in
look at it,
Virginia,
and they can fix
Maryland,
things
and the
before it breaks
US.
down.
Just pick
That's
one
operation
building from our
maintenance.
list. This is
Other thing
an
is
old building.
occupant
Some
satisfaction.
people tell
We
me
monitor
that to
in
make
the
a
building
smart building, you must build
many
it
things.
smart
One
in
is
the
carbon
beginning.
dioxide.
That's
We
not
can also
possible.
monitor PM
In the
2.5,
US, 90% of
SARS-CoV-2
buildings are more than
virus
15 years
concentration.
old.
And
They're not
based on
smart.
that, we send
What to do with
action
them?
to keep the
Well,
building
we have a
more
solution. We'll
healthy.
provide
Now, some examples.
equipment,
We have
sensors,
deployed our solution in many
controllers
buildings in
in
Virginia,
the building,
Maryland,
which
and
can
the
be
US.
wired.
Just pick
You
one
can-
building.
This building in
This
front of
is
us
an
is
old
74
building.
years old. Old building.
Some people
74
tell
years old.
me
This
to
building
make
was
a
not built
smart
smart.
building,
We
you
have
must
put
build it smart from
hardware,
the beginning.
we put
That's not
sensors,
possible.
and show an example in a
In the
second.
US,
So building is smart.
90%
Example.
of
Look
buildings
at this
are more
building,
than 15 years
one
old. They're not
classroom.
smart.
That
What do you
building.
do with them? Well,
This
we have a
classroom has
solution.
no windows.
We'll
People
provide
come into class to sit and listen to the
equipment,
lecture. What we did
sensors,
to
controllers
monitor the health
in the
of
building,
air
which can
quality
be
in that
wireless.
classroom, we put
So,
a
this
sensor
building in
which
front of us
measures
is
carbon
74 years
dioxide,
old. Old building.
noise,
74 years old.
temperature,
This building
and
was not
relative
built
humidity.
smart.
One
We
device,
put
Wi-Fi.
hardware, we put
That's in the room, in the
sensors,
ceiling.
and
Put it
show an
there.
example in a second.
We also
So
have
building
this
is
box
smart.
called
Example,
BMOS
look at
core.
this building,
That's a Raspberry
one
Pi in that classroom,
that building.
monitoring
This
all
classroom has
this
no windows.
information, carbon
People
dioxide, noise, temperature, and heat. Below that BMOS score box, I have a smart plug. Why is it important? Before we put the smart plug, the classroom we can see has a computer, it has an LCD projector, it has a printer. Those are turned on, left on, nobody turns them off.
We also have this
Smart
box
plug,
of BMOS score.
you hook
That's
your
a Raspberry
printer to
Pi
the smart
in
plug,
the classroom,
go home at
monitoring
9, 10
all
p.m.,
this
10 p.m.
information,
It
carbon
automatically
dioxide,
turned off because
noise,
you program it to turn off at
temperature,
10 p.m. every day. That's
Below
saving
that,
energy.
we must for box.
Go
I have
across
a
the room on
smart
the
plug.
left-hand side, motion
Why is it
sensor.
important?
If the
Before
classroom
we
has
put the
nobody
smart
in there,
plug,
why
the
cool it so
classroom we
much?
can
Why
see
keep the
has a
light on
computer.
100%?
It has
We
an
don't. Because
LCD
of the
projector.
knowledge
It
we
has a
have that
printer.
we
Do they
can
turn on, left
detect
on, nobody turns
people in the
on.
room or not.
Smart plug.
Above that
You hook
is a
your
smart
printer to the
Wi-Fi
smart plug.
thermostat.
Go home at
Why
night, 9,
Wi-Fi
10 p.m.,
thermostat?
10
We can
p.m.
monitor its
It
operation
automatically
remote.
turned off because you
And on the
program it to
left-hand
turn off
side,
at
the
10 p.m.
top,
every day.
we're also
That's saving
monitoring
energy.
the air conditioning
Go across
unit
the room
on
on
the
the
roof,
left-hand
which
side,
is serving
motion
this floor.
sensor.
So we have to know
If the classroom
by
has nobody in there,
doing
why
lighting
cool it so
control,
much? Why keep the
air
light on
conditioning
100%?
control,
We don't, because of the
occupancy-based lighting
knowledge we have that we can
availability,
detect
are you saving
people
energy?
in the
We
room.
measure that in real time. Good.
Above that
Now,
is
this
a
is some
smart
data.
Wi-Fi thermostat.
This is a
Why Wi-Fi
screenshot
thermostat? We
of
can monitor its
iPad is
operation
running
remote.
this system.
And on the
We have
left-hand side,
indoor
the top,
temperature,
we're
humidity,
also
many
monitoring
things in the
the
back
air
covered up,
conditioning unit
noise,
on the roof, which is serving this floor.
CO2,
So
all
we have
that.
to know by
Look at the blue
doing
box
lighting
on the
control,
lower right-hand side.
air conditioning
That
control,
shows the
occupancy-based
CO2
lighting
concentration in this
availability.
classroom over
Are you
24
saving
hours.
energy? We measure that in
Early
real
in the day, 9 o'clock, is about
Now, this is some
500,
data.
close to
This is a
ambient average.
screenshot.
Slowly goes up to about 600
iPad is running this
by 3
system.
o'clock, 4
We
o'clock.
have indoor
Class starts at
temperature,
6:30.
humidity, many things
By
in
7
the
o'clock
back
begins
covered
to
up,
rise.
noise,
700,
CO2, all
800, 900, 1000,
Look at the blue
1100
box on the
CO2
lower
concentration in
right-hand
the
side.
building. This is not very
That shows the
Data shows
CO2
inside
concentration
an
in
enclosed
this classroom
space.
over 24
If
hours.
your
Early in the
CO2
day, 9 o'clock,
concentration
it's about
goes
500,
over
close to
700 parts per million,
ambient
it is not very
average.
healthy.
Slowly goes up to
What
about
do we do?
600 by
When we measure this
3 o'clock,
data,
4 o'clock.
we looked at the
Class
classroom.
starts at
When
6:30.
the CO2
By 7 o'clock,
concentration
begins to rise.
in this classroom goes
700,
over
800,
700,
900,
we throw
1000,
more fresh air.
1100. CO2
Dilute the
concentration in the
CO2.
building. This is
Similarly,
healthy.
if I could measure
Data shows
the
inside
SARS-CoV-2
enclosed
virus
space,
concentration
if your
using a sensor is not
CO2
there yet,
concentration
I could
goes
throw more
over
fresh air.
700
If
parts
it
per
is
million, it is not very
dangerous,
healthy.
I'll give a warning that leave this room.
When we
This
measure
room is
this
not safe
data,
to work.
we looked at a classroom.
That's the benefit
CO2
of digitization
concentration
we talk about
in this
theme of the
classroom
conference.
goes
You have
over
signals which can
700,
help
we throw
you
more fresh air.
to maintain a
Dilute the
healthy
CO2.
building operation.
Similarly,
Good.
if I could
That was the
measure
CO2 part.
the
Now, how is it done?
SARS-CoV-2 virus
The
concentration
typical examples of
using a sensor is not there
outdoor
yet.
air intake.
I could throw
Many
more
of you know
fresh
this
air.
probably.
If it is
Every
dangerous,
building,
I'll give a warning
enclosed
and leave
commercial
this room.
building,
This room is not
has
safe
to have some fresh air all the time. Otherwise, building
That's the
builds up too
benefit
much CO2 and
of
other
digitization we talk about
gases.
theme of the conference.
So outdoor
You
air
have
intake is
signals
fine.
which can
What
help
we can
you
do,
to
we can
maintain
put
a
IoT
healthy building
sensors
Good.
in the
That
indoor
was the
air
CO2
supply.
part. Now, how
See these
is it done?
ducts, these are indoor air supply.
The typical
You
examples
put
of
sensors inside these
outdoor
ducts,
air
you
intake.
know
Many of
the
you know
concentration of
this.
CO2,
Every building
PM2.5,
enclosed commercial building
SARS-CoV-2, and
has
based
to
on
have
that
some fresh air all
information,
the time.
we
Otherwise,
can take
building builds
some
up too much
action to
CO2
make the
and
building
other
more
gases.
healthy. We can do that
So
from this
outdoor
protocol
air
that we
intake
developed.
is fine.
That was
What we
CO2.
can do, we can put
So going
IoT
back,
sensors
this is the
in the
information
indoor
on
air
energy
supply.
and power use.
See these ducts,
Same
these
building,
are
the
indoor air supply.
74-year-old
Sensors
building that you see on the
inside these
top.
ducts, you
We are
know
measuring
the
in that one
concentration of
floor
CO2,
the temperature,
PM
which is the
2.5,
green line. The red line is the
SARS-CoV-2.
set
Based
point,
on
which is
that
about
information,
23
we can take
degrees
some action
centigrade.
to make the building.
And the blue line, the operation of
We
the
can do that from
air
this protocol that
conditioner.
we developed.
For
That
the
was
purpose
CO2.
of energy savings, we said
So
we will
going
not
back,
turn the
this
AC
is the
on
information
between
on
1
energy
p.m. and
power
5
use.
p.m. See what
Same
happens.
building, the 40,
This is the right-hand picture
74-year-old
with the
building that you see on the
yellow
top. We're measuring
numbers on the
in that
top
one
and bottom.
floor the
We said we'll
temperature,
allow
which is the
the
green
temperature
line.
to go from
Red line
74,
is a
which is
set point, which is about
22 or 23,
23
to
degrees
77,
centigrade,
25 degrees
and
centigrade.
the
25
blue line,
upper
the
limit.
operation of the
I will turn the AC off. See
For
what
the
happens. You
purpose
can
of
see the green
energy
lines
savings, we
are
said
slowly
we will
going
not
up.
turn
It
the
started
AC
about
on between
19
1
degrees,
p.m. and 5 p.m.
go up to
See what
25
happens.
by 5 p.m.
This is the
The
right-hand
AC didn't turn
picture
on.
with
It was
the
fine. You can
yellow.
see the results. The gray box on the left, energy usage for 4 hours, 1 to 5 p.m., 2.72 kilowatt hours. Peak load was for that floor 4 kilowatts, 3.9. That's without our control. We put the control, AC was not turning on, fan was on.
Slowly going up.
Energy usage was half. It was 2.7, became 1.4.
Go up to 25
Peak load was 3.98, became 0.5.
You can see
that's a good example of
the gray
energy
box on the
savings,
left, energy
load
usage
savings,
for 4
and of
hours,
course,
1 to
CO2
5 p.m., 2.72 kilowatt hours.
Let's look at a
Peak
different
load
building,
was for that
or real
floor,
buildings in
4
our
kilowatts,
neighborhood.
3.9.
The
That's
building,
without
they
our
have garage for
When you put the
working on school
control,
buses.
AC
Upstairs,
was
their
not
office.
turning on, fan was on.
This office,
Energy
I
usage
went
was
there
half.
about
It was
lunchtime.
2.7,
Nobody
became
around.
1.4.
We have this port
Peak
area in the
load was
middle.
3.98,
The skylight, get sunlight coming in.
That's a good
Ceiling
example
lights all
of
on, full
energy
capacity. Nobody's
savings,
around.
peak load
On the
savings,
upper right
and
hand
of course,
side, we
CO2
have
management.
staff area.
Let's
They went
look
to
at a
lunch.
different
Nobody
building.
there. Still light on,
Real
full
buildings
capacity.
in our neighborhood.
Below that is a conference room.
Building,
No
they have
conference is
garage
happening.
for
Still lights are on.
working
That's
on
normal.
school buses.
We said,
Upstairs,
can you
office.
turn lights off? They
This
said, no, if you turn lights
office,
off,
I
you will
went
get
there about
uncomfortable.
lunchtime.
Can you
Nobody
dim
around.
it? They could not.
We have
We
this
put a
work
technology,
area in the
dim the
middle.
lights.
It
But
has
dimming the
skylight,
lights,
there's sunlight coming in.
by meaning make them
Ceiling
less
lights all on, full
concentrated.
capacity, nobody's around.
Two things.
On
Lunch
the
hour.
upper right hand side,
Also,
we have
when the sunlight comes in,
staff area.
we have
They
a
went to
light
lunch.
sensor
Nobody's there.
on the
Still
wall right
light
here.
on, full
That
capacity.
is measuring
Below
the
that
total
is a
light, the
conference
sunlight
room.
plus
No
the ceiling
conference is
light.
happening. Still
If
lights.
sunlight
That's
is
normal.
strong, you'll dim the
We
ceiling light
said,
automatically.
can you turn lights
Automatically.
off? They said, no, if you
If
turn lights
sunlight
off,
goes
you
away,
will get
it goes
uncomfortable.
back to full
Can
capacity.
you dim it?
By
They
doing
could
this
not.
control,
We put a
see the
technology
numbers
to dim the
on
lights.
the
By
bottom
dimming
of
the
the screen
lights,
here, you're
by
saving
meaning
about
make them
33,
less
34% month
concentrated.
to month just
Two
by
things, lunch
dimming
hour.
and scheduling. That
Also,
can be done.
when the
So
sunlight comes in,
now
we have
we
a
have talked
light
about
sensor
smart
on the wall right here.
building. What
It is
makes a building
measuring the
smart?
total light,
You
the
have to
sunlight
have
plus the ceiling light.
monitoring and control of
If sunlight
heating,
is strong,
air
it'll dim
conditioning,
the ceiling light
ventilation,
automatically.
lighting, water supply,
The
sensor
sunlight goes
network,
away,
security
goes back
camera,
to full
fire
capacity.
emergency. All
By
of this
doing
is
this
there.
control,
Typically what
see the
happens in any
numbers
big building
on
in
the
Jakarta,
bottom of
they
the
have
screen
this,
here,
but they
we're
have
saving about
8
33,
different
34%
platforms, one for
month to month.
emergency fire, one
Just
for
by
camera, one
dimming
for
and scheduling.
sensor,
That
one
can
for
be
water
done.
supply, one for HVAC.
So now
We have
we
developed
have
this
talked about smart
wise building platform
building.
can
What
take
makes
care
a
of
building
all of
smart?
them in one
You have to have
location.
monitoring and control of
That
the
was
heating,
smart building.
air conditioning,
We are going into
ventilation,
smart grid
lighting,
slowly.
water supply,
This is
sensor network,
a
security camera,
microgrid.
fire
What is a
emergency. All of
microgrid?
this is there.
It is a
Typically, what
collection of
happens in any
buildings,
big building in
including
Jakarta,
some
they have
supply.
this,
In
but they have
Chicago,
8
Bronzeville
different platforms.
microgrid,
One for
there are
emergency
many
fire,
buildings,
one for camera, one for
homes,
sensor,
Math
one for water
Academy,
supply, one for
police
HVAC.
headquarters,
We have developed this
there are
wise
medical
building platform
institute,
can take
college
care
of
of all of them in
optometry,
one
nursing and
location.
living center,
That
military
was
academy.
smart
In
building.
part of Chicago,
We are
the
going
real
into smart
building, right?
grid
Real
slowly.
situation. You have the
This
rooftop
is
solar,
a
battery
microgrid.
storage,
What is a
and
microgrid?
2
It is
substations
a collection of buildings
serving the network
including
and
some supply.
connected to another microgrid
Chicago,
in the city of Chicago
Bronzeville
as well.
microgrid.
That's a typical
There are many buildings,
microgrid. My point
homes,
is, you
Math
can
Academy,
control part of
police
Jakarta and all of it
headquarters,
together. It's difficult. Big city.
there are
Take a
medical
piece
institute,
around
college
let's
of
say,
optometry,
Trisakti University
nursing,
or
living
UI.
center, military academy.
Do that
In part of
and see
Chicago,
what can be
the
done.
real
As an
building,
example.
real situation. It has a rooftop solar,
This is going
battery
from
storage,
smart building
and 2
to
substations
microgrid to the big
serving
smart
the
grid now.
network and
How
connected
is
to
the
another
grid
microgrid
changing over
in the
time?
city of Chicago
The
as
top
well.
half of
That's
my
a typical
screen is a
microgrid. My point
system
is, you
before
can
smart
control
grid.
part of Jakarta and
Power
all of it
station,
together. It's difficult, big city.
step-up
Take a
transformer,
piece around,
long
let's
distance
say,
transmission line,
Trisakti University
step-down
or
transformer,
UI.
local
Do that
distribution
and see
line,
what can
and
be
you
done.
build.
As an example.
It's normal. What is new is the lower half of my
This is
screen.
going
I have
from
roof, I have
smart
solar
building
panels,
to
battery
microgrid
storage,
to the
I
big
have
smart
wind
grid.
turbines, electric vehicles, the green one, all that is there. In addition, I have to have big power stations and factories. My point is Indonesia is big in coal today, coal-fired generation, a lot of coal. We cannot turn the coal plants off next 25 years. Maybe 2050, we can get rid of them. That means next 30 years, we will live with the large thermal
I
power
have
plants,
solar
but
panels,
slowly we
battery
add
storage,
more and
I
more
have wind
renewable
turbines,
generation
electric
and battery.
vehicles, the green one,
What you see in
all
this
that is
picture
there.
also,
In addition,
the
I have
dotted
to
blue
have a big
line,
power station
that
and
is not
factories.
power line,
My
these are
point is
communication
Indonesia is big
lines.
and cold today.
You must have
Our generation,
real-time
lot of coal.
communication
We
between the
cannot
rooftop
turn the
solar,
coal plants off
storage
next
battery,
25 years.
electric
Maybe
vehicle, and
2050,
building
we
load
can get
make
rid of it.
sure
That means
every
next 30
second
years,
the
we
load
live with
and the
the
supply
large
are
thermal power
matched.
plants,
That's a challenge for any
but
engineer.
slowly we
So how to do this?
add more
We
and
have to
more
merge
renewable generation.
power flow with
and battery.
information flow now.
What you see in
We
this
call it
picture
integrated
also,
communications.
the dotted blue lines,
Look at this picture.
that is not
This is
power
my
line. These are communication
traditional
lines.
electric
You must
power
have
infrastructure.
real-time
We know this, right?
communication between the rooftop solar,
Power
storage
station,
battery,
step of
electric
transformer,
vehicle,
long
building
distance
load. Make
transmission line.
sure
Then
every
you go.
second
Sorry, I'm
the
too
load
fast.
and the supply are matched. That's a challenge for any engineer.
Then you
So,
go
how
to
do
this picture here,
merge
where I have
power flow
added
with
what I call
information flow.
information
We call it
infrastructure,
integrated
right?
communications. Integrated
Where I'm
communication.
adding
Look
a
at this picture.
telecom network
This is
to
my
connect all the buildings
traditional electric
and
power
all
infrastructure.
the
You know this,
substations
right?
together, so that
Power
you'll know in
station,
real time
step up
how much
transformer,
power is being
long distance
consumed
transmission
at
line.
every location,
Then you go.
what's the voltage,
I went too fast,
current,
one second.
frequency, power factor. That's our complete
Then you go
smart
to
grid
this
going
picture
forward.
here.
So this
where
is
I have
my
added what I call
vision for the future.
information
Talk about
infrastructure,
smart grid.
right?
This is not
Where
going to
I'm
happen
adding a
overnight. Take
telecom
many
network
years. What will
to
happen
connect
step by
all the
step?
buildings
I'll have what is called
and
intelligent,
all the substations together,
interconnected
so that
microgrids.
you'll know in real
What's a
time
microgrid? You saw
how much
Chicago,
power
Bronzeville,
is being consumed
power
at
of the
every
city, right?
location.
Many
What's the
buildings,
voltage,
there
current,
are two substations,
frequency, power factor.
solar
That's our
rooftop,
complete
battery
smart
storage,
grid
all of
going
that.
forward.
Here,
So this
I'm
is my
showing one,
vision
two,
for the
three,
future.
4 microgrids.
Talk about
One
smart
in the
grid.
middle and the top
This is not going to
has
happen
multiple
overnight.
homes,
Take many years.
rooftop
What
solar,
happens step by
has
step.
the
I'll have what is
electric
called
vehicle, and
intelligent,
this box
interconnected
is the controlling
microgrids.
the
What's the
devices in
microgrid?
the
You saw
microgrid.
Chicago,
The
Bronzeville,
one on the right hand side,
part of
another
the city,
microgrid
right?
has a storage
Many
battery in it.
buildings,
Why is it
two
important? A
substations,
microgrid
solar
can
rooftop,
survive if it
battery
loses the
storage, all
network
of it.
power. If I
Here,
cut these two
I'm
lines, network
showing
power,
1,
on the
2,
both
3,
sides,
4
I can
microgrids.
survive.
One
But
in the
I have
middle
to
at the
manage my
top
load more
has multiple
carefully
homes.
because I
Rooftop
don't have
solar
100%
has
backup.
the
So battery
electric
will help.
vehicle, and
The
this
microgrid in the
box
middle is a bigger
is
microgrid.
the
That is
controlling
involving,
devices
for
in the
example,
microgrid. The
buildings
one on the
on
right
Jalan
hand
Sudirman
side,
in Jakarta, for
another
example.
microgrid has a
These
storage
big buildings
battery.
are there.
What is
These
important?
are
A
connected
microgrid
to a
can survive if it
windmill
loses
with
the network
transformers,
power. If I cut these two
power
lines,
network on the
network
lower
power
right hand
on
side,
the both sides,
transformers,
I can
and
survive.
large
But
factories.
I have to manage
That's
my
possible.
load more
What
carefully
I'm saying,
because
it is
I don't
possible
have
for the bigger
100% backup.
microgrid
So
to
battery
supply
will help.
power to the smaller
A microgrid
microgrids
in the middle
because
is a
it
bigger
has
microgrid
connectivity to the
that
main
is
power station.
involving, for
At the
example,
bottom, another
buildings
microgrid,
on Jalan
it has more
Sudirman
battery
in
storage.
Jakarta, for example. These
One,
big
one
buildings are
solar,
there.
not many solar.
These
Look at the
are
top one. My
connected
point
to
is,
a
you'll have many
windmill
microgrids.
with
One
transformers,
could be DC microgrid.
power network
One
on the
could be
lower right hand
microgrid
side,
focusing on solar
transformers,
power
and
only.
large
One
factories.
microgrid can focus
That's
on
possible.
battery storage.
What
All
I'm
that is
saying,
learning.
it is possible for the
PLN
bigger
engineers from
microgrid
PLN
to
can look at
supply
this
power to the
option
smaller
and
microgrids
decide
because it
how
has
to design the
connectivity to the
system
main power
going
station.
forward. So this
At
is
the
my
bottom,
summary.
another microgrid,
I call
it
it
is more battery
smart
storage.
grid
One
ecosystem.
solar,
Starts
mini
with a
solar
smart
at the
building,
top one.
the
My point
yellow
is,
circle
you
in the
have
middle,
many
then goes
microgrids.
to
One
microgrid.
could be
We
DC
show
microgrid.
in Chicago
One could be
example for
microgrid
you.
focusing
Then
on solar
distribution
power
system,
only.
many
One microgrid can
microgrids
focus on battery
interconnected.
All that
This is a
is
distribution
learning.
system.
PLN
Then
engineers,
many
PLN
such
can look at this
systems will
option
form the
and
smart grid.
decide how
So
to
you have
design
a
the system
Jakarta Jakarta distribution system,
So this is my summary.
Palembang distribution
I call it
system,
smart
Bandung
grid
distribution
ecosystem.
system, they all
Starts
connected
with
by
smart
PLN
building,
in a smart grid
yellow
environment.
circle in the
So for a
middle,
smart
then
building,
goes to
it must have
microgrid. We show
intelligent
in Chicago
building
example
automation
for you.
systems,
Then
smart
distributed system,
devices,
many
productive
microgrids
users, and grid
interconnected.
integration.
Give you
Grid
distributed
is
system,
kind of
then
stressed out,
many
supply limited,
systems
building
will
can dim
form
their lights a
the
little bit.
smart grid.
they can change the air conditioning section
Jakarta
to
distribution
save energy.
system,
That's how I think
Balikpapan distribution
distance will
system,
grow in the future. That's
Bandung
it.
distribution
I'm
system,
done. I've given
both
you
connected
my
by PLN
email
in a
address.
smart grid
If you have any
environment.
questions, I can
So for a
answer
smart
now.
building,
Please write to me.
it must have
I'll answer.
intelligent
Also, my website
building
has many
automation
of my papers. If
systems,
you're interested to
smart
follow up,
devices,
I'm in Facebook,
productive users, and grid
on LinkedIn,
integration. The grid
Twitter,
is kind of
and YouTube.
stressed
You
out,
find me there as
supply
well.
limited.
Again, somebody mentioned before,
They can
we have
change
now
the air conditioning
the
set
election going
to
on
save
for
energy.
IEEE.
That's
It's
how I
ongoing
think
right now. You can
systems
vote
will
till
grow in the future.
October
That's
1st.
it. I'm done.
Indonesia has a very
I've given you
strong,
my
active
email
IEEE
address.
section.
If you have any
Many members are
questions,
there,
I
maybe
can answer
1,000
now.
members in
Please write to me.
Indonesia.
I'll answer.
So
Also,
go
my
to the
website has
website
many of my papers if you're interested to follow up.
www.iEEE.org/elections.
On
You see the
LinkedIn,
4 candidates,
Twitter,
and you can
and
read their
YouTube. Find me there
bios
as well.
and decide whom to
Again,
vote for.
somebody mentioned before,
Please vote. This is
we have
important.
now
We have a role
the
play
election going on for
in
IEEE. It's
choosing
ongoing right
the
now. You
next
can vote till
IEEE president.
October
With
1st.
that, let me stop here,
Indonesia has a
and
very
I'll take
strong,
questions
active
and comments.
IEEE section. Many
Terima
members
kasih.
are there, maybe 1,000 members in Indonesia. So
Well,
go to the
it was a
website,
very great presentation, Professor Rahman. Well, so many things come to our mind,
You see the
our
4
thoughts
candidates,
and our,
and you can
was it,
read their
agreement.
bios
Yeah,
and
this is
decide who to
something.
vote for.
Yeah. I hope that
Please
the
vote.
audience
This is
is very
important. They have
attentive
a role
wherever
play
you are.
in
So we are now
choosing
coming to
the next
the
IEEE president.
Q&A
With that, let me
session,
stop here,
but I'm
and
so
I'll
sorry,
take
we are so
questions and
sorry, we
comments.
only opening
Terima
chat.
kasih.
So please write down your questions in the
Well,
chat. We will
it was a very
select.
great
We will select
presentation, Professor
the
Rahman.
most
Well,
appropriate
so many
questions for
things
Professor
come to
Rahman
our
to answer.
mind, our
Okay,
thoughts, and
we
our
have,
was it
because
intriguing
Professor
minds.
Rahman
This
is
is
very
something.
generous. We
I
have
hope that the
additional 10
audience is
minutes
very attentive wherever
from
you
the
are.
20 minutes
So
planned
we are
by the
now
committee.
coming
So
to
we have
the
30 minutes for the
Q&A
QA
sessions,
session.
but I'm
Okay,
so
please,
sorry.
now
We are so
open
sorry.
from
We
now.
only
Please,
opening
type your
chat. So
question.
please write down your questions in the chat. We will select. We will select the most
Just to
appropriate
let people
questions for
start
Professor
thinking here
Rahman to
about this
answer.
whole idea.
Okay, we
This,
have,
the last slide that I
because
showed, or
Professor
last second to the
Rahman
last
is
one.
very generous, we
People talk
have
about smart
additional
grid.
10
Smart
minutes
grid is not easy to
from
do.
the
It's
20
very
minutes planned
expensive.
by in the
It
committee.
is very
So we have
complex. It will not
30
happen
minutes
overnight.
for the
If
QA
you want to
session.
build
Okay,
up to a
please
smart
now
grid, you have to
open
step by
from
step.
now. Please
And my
type your
theory
questions.
is you have to build a smaller section PLN part of Jakarta, for example, and see how benefit you get, how much money it takes. Is it helping the building to be more efficient? All those things have been discussed.
People talk
So
about
I
smart
hope there are
grid.
many professors
Smart
here,
grid is
many
not
universities. You will take this
It is very complex.
carefully,
It will not happen overnight.
and I can
If you want to
send
build
you
up to a
a
smart
copy of
grid,
my
you do
slides
step by
here.
step. And
And you can use it
theory
any way you like
you have to
to
build
bring
smaller section
students'
PLN
interest
part of
in
Jakarta,
asking
for
these
example,
questions.
and see how it works.
I'll give you a very simple
Benefit you
example.
get. How
Smart
much
grid
money
is very
it takes.
expensive, not cheap, very expensive.
Is it helping
Start
the
with smart
building to be
meter.
more efficient?
In
All those
Virginia,
things have been discussed.
to deploy
So I hope
a
there are many
smart meter
professors
costs
here,
about
many
$200
universities
US. One
who will
smart
take
meter.
this
The meter itself costs about
carefully,
$40, $30,
and
$40.
I can
Remaining
send you
$150
a copy
for
of my slides here.
telecom network.
And you
You
can
need
use it any way
to
you like
collect
to
real-time
bring
data. So
students'
what can you
interest.
do in
Asking these
Indonesia,
questions.
in
I give you a very
Semarang,
simple
in
example.
Jakarta, to
Smart grid
reduce
is
the
very expensive,
telecom
not cheap,
expense,
very
and
expensive.
the cost goes down. That's the
Start with
research
smart
challenge.
meter.
Nobody has solved that yet.
Virginia,
It's a lot of
to deploy a
and
smart meter costs
technical
about
know-how.
$200
So
US.
a
One
lot of
smart meter.
opportunity are
The meter
are
itself
here
costs about $40,
for you to get
$40.
involved
Remaining
in many levels of
$150
smart grid,
for
smart
telecom
distribution
network.
systems. You keep that thought in mind. as you
Collect
go.
real-time data.
Okay, so let's see some
what can
questions
you do
now.
in Indonesia, in
Okay, thank you
Semarang,
very much, Professor.
in
We
Jakarta,
still have
to
20 minutes
reduce the
then.
telecom expense?
Okay, ladies and gentlemen,
Cost
please,
goes.
this is
That's
very
the research
interesting
challenge.
topic.
Nobody has solved it yet. Takes a lot
There
of
are
time
so many things
and
I think very
technical
new to
know-how.
us. So this is
lot
the
of
expert is ready
opportunity
for
are here
responding
for
to
you
your
to get
questions.
involved
Please.
in many levels of smart grid. smart.
Okay, while waiting for the question from the audience, Professor, I'd like to say something that
So let's see some questions
IoT and smart buildings. You said in the presentation
Okay,
all
thank you very much,
buildings
Professor. We
in
still
the
have 20 minutes
Arlington, for
then.
example,
Okay,
also,
ladies and
but
gentlemen,
they
please,
are
this is very
modified into
interesting
smart
topic.
buildings. Are there
There are
any
so many things.
obstacles
I think it's very new to
dealing
us. So this is the
applying
expert
the
is ready for
smart building facilities
responding
to
to your
the old
questions,
buildings in
please.
your experience?
Yes,
Okay,
there
while
are
waiting for
obstacles
the
because of
questions from
lack
the
of
audience,
knowledge.
Professor, I'd
For
like
example,
to
when
say
we
something that
chose
the
to deploy smart
IoT and smart
thermostats in
buildings, you
that
said in the
building,
presentation, all
they're
buildings
asking me, well, it's
in
working
the
fine, why
Arlington,
change
for
the thermostat?
example, also,
It's
but
working
they
fine
are modified into
when
smart
it
buildings.
works.
Are there
Example,
any
the classroom I showed you
obstacles
is
dealing
evening class. The come to class
applying
about
the
6:30 p.m.,
smart building
leave at
facilities
9:30
to the
p.m.
old buildings
Hot
in your
summer day.
experience?
When they come in, they want to cool the room.
Yes,
They
there
brought
are
the temperature to
obstacles
maybe
because of
15 or
lack of
16 degrees
knowledge. For
centigrade.
example, when
The
we
thing,
chose
make it
to
low, it cool
deploy
faster.
smart
Don't work that
thermostats
way.
in that
Anyway,
building,
they're in the classroom,
they're
everything is
asking me,
fine,
well, it's
they
working
leave.
fine, why change the
Nobody
thermostat?
remembers to
It's
turn it
working
back on to
fine
21. Still 16,
when it
Friday night.
works.
All
Example,
weekend is 16.
the classroom
All
I
weekend.
showed you,
It's very cold.
it's
Monday
evening
morning,
class. They come to class about
staff comes
6:30
to work, they
p.m.,
wear a sweater.
leave at
It's so
9:30 p.m.
cold in the building.
Hot summer
Summertime.
day. When they come
All
in,
weekend,
they want
you
to cool
wasted
the
so
room,
much energy,
brought the temperature to
nobody
maybe
cares.
15 or
If
16
I have a
degrees
smart
centigrade.
thermostat now,
The thing,
can be
make it low,
programmed. In
it cool
fact, the
faster.
director of the
Work that.
building can
Anyway,
see
they're in the
from home
classroom,
on
everything
Friday
is
night
fine,
on her
they leave.
smartphone what is
Nobody
the
remembers to
temperature
turn it
reading
back on
of
to
the thermostat.
21. Still
60,
16, Friday
16,
night.
you can change it to
All
21,
weekend
22,
it's
22.
16. All weekend. It's
That's
very
a
cold.
cultural thing. That's
Monday
a barrier.
morning,
You have to let
staff
people
comes to work,
know
they wear a
you
sweater.
invest
It's so
money,
cold
it
in the
does
building.
good
Summertime.
things for you. It took us a few
All
months to
weekend, you
convince
wasted
them,
so
but
much
finally we could.
energy,
That's
nobody cared.
all of day.
If I have a
Done.
smart thermostat
Okay,
now,
thank you very
can
much,
be
Professor.
programmed. In
Well, we
fact,
have
the
somebody
director
here
of the
ready
building
to
can
ask questions,
see
Mr.
from home on
Anggoro.
Friday night
Mr.
on her
Anggoro.
smartphone
Okay,
what is
are you
the
ready, sir, Mr.
temperature
Anggoro, to
reading
ask
Thank you.
the question?
Yes, I'm ready.
she sees
Thank
16,
you,
she can
Mr.
change it
and
21,
Mrs.
20,
Moderator.
21.
Good morning.
That's a
Sorry,
cultural
good
thing.
evening, Professor
That's the
Saifur.
barrier. You have
I
to
would
let
like
people know.
to. I have
Invest
two
money,
questions
it
for you.
does good things for you. It took us a few
Since
months
Indonesia
to
is a
convince
country
them,
of
but finally
I
we
think
could.
thousands
That's
of islands,
holiday.
I'm thinking that maybe microgrid is more
Okay,
suitable
thank you
for
very much,
us, and rather
Professor.
than we
Well,
are
we have
trying to
somebody
build
here
a super
ready to
grid
ask
connecting
questions,
all the
Mr.
island in
Anggoro.
Indonesia.
Yeah, Mr. Anggoro. Okay,
Or maybe
are you ready, sir, Mr.
microgrid
Anggoro,
is more
to ask
suitable because
question?
then
Yes,
Okay.
each
I'm ready.
microgrid will consist
Thank
of
you, Mr.
its
and
energy
Mrs.
sources,
Moderator.
which are
Good morning.
suitable for
Good
its
evening, Professor
location.
Saifur. I would like to.
What do you think about this
I have
idea,
two
and
questions for
what do
you.
you suggest to make
Since Indonesia is a country of
this kind of
thousands
reality
of
for us?
islands, I'm thinking that
The
maybe
second question
microgrid is more suitable for us.
as the
Rather than we are
moderator
trying to build a
stated that
super
you
grid
are running
connecting all
for
the island
IEEE
in
president,
Indonesia.
can you elaborate
Microgrid is more suitable because then
what is your
each
plan
microgrid
for
will consist of
IEEE
its
if
energy
you are
sources
elected
which
as a president?
suitable
Thank you.
for its location.
Okay, Pangaro, thank you
What
for
do you
those
think
two
about
questions.
this idea, and
Yes, I
what do you
fully agree
suggest
with you
make
that
to make this
microgrid,
kind of reality for
as
us?
much local supply as
The second
possible,
question
is a
is,
better solution for
as the
Indonesia
moderator
for two reasons.
stated that
If you
you
want
are
to do
running
super
for
grid,
IEEE
whole
president,
country is a lot of money to be spent,
do
a lot
you
of
can
money to be spent.
use elaborate
Number one. Number two,
what is your plan
it's
for
difficult to
IEEE
maintain for a long time,
if
but
you are elected
storm, you got
as a president? Thank you.
cyclones. So I would
Okay,
not
Pangaro,
recommend that.
thank you for those two
The reason
questions.
they do super
Yes,
grid, they
I
have one
fully agree
big
with you
or many big power
that
stations pumping power
microgrid
to the whole country.
as much local
That
supply as
is not
possible
going to work
is a
very
better
well because of
solution
the
for
safety and
Indonesia
security issues.
for two reasons.
But
If you
if you
want to do
have
super grid,
many
whole country
islands,
is a
small
lot of
ones,
money
with
to be spent, a
microgrid
lot of money
needs
to
a
be
local
spent.
generation,
Number one.
how
Number
would you
two,
manage that?
it's
You
difficult
have
to
a lot of
maintain
wind
long time, but
opportunities, solar
storm,
opportunities, of course, we will back up some. So we have to have a very
I
smart
would not
thinking,
recommend that.
combination
The
of different
reason they do
possibilities.
super grid, they
That's
want
cheaper in the
big
long run.
on
So
many
I would
big power
recommend,
stations,
look at this very
pumping
seriously.
power to the
Multiple
country.
options for Indonesia.
That is
In the
not
islands
going
and
to work
nearby,
very well
you can
because of
connect them.
safety
It's
and
okay under
security
CGIP.
issues.
But do not
But if you
plan to
have
connect whole country,
many islands, smaller ones,
2,000 kilometers
microgrid
out
irrigation,
in
local
all the
generation,
power stations. It's
how
not
would you manage
safe. to do that.
You have a lot of wind opportunities.
Number two, if I
solar
become
opportunities,
IEEE president,
of course,
what
digital
I'll do
backup.
differently?
We have to have a very smart
I'm a
thinking,
person who believes
combination
in
of different
ground up.
possibilities.
I've met
That's cheaper in the long run.
all over the
I
world
would
thousands of
recommend
engineers,
look at this
thousands
very
of people.
seriously.
And I see
I've
one
given
thing they ask me
options
all
for
the
Indonesia.
time.
If the islands are
Make
nearby,
IEEE
you
more
can connect
useful
them.
to
It's
me,
okay, under
not
the
just
cape.
reading
But do not
technical paper.
plan to
As
connect
an
the whole
engineer, what do I
country
do? So I have
2,000
built for
kilometers out
our
in all
society
the power
PS.
stations. It's not
I'm the
safe
founder
to do that.
of PS University. We
Number
provide
two,
training
if I
materials
become
for
IEEE
engineers
president,
from
what
the
I'll
university
do
website.
differently?
So answer your
I'm
question,
a person
Pangoro,
who
is I want
believes
to
in
make
ground up.
local
I've met
sections like Jakarta, people
all
like
over the
you,
world, thousands of
local
engineers, thousands
chapters
of people.
have some
And I
say
see one thing they
in
ask me
how
all the
you want
time.
IEEE
Make IEEE
provide
more useful to me,
services
not
in
just
your case.
reading
That'll be
technical
my,
papers. As an
my
engineer, what do
operating
I do?
principle.
So I have built for
Thank you very much,
our
Professor
society
Saiful. Good luck to
PS.
you.
I'm
Thank you.
founder
Thank you very
of
much,
PS
Mr.
University.
Hanggara.
We provide
Well,
training
while waiting on
materials
the
for
other
engineers
questions
from the university
audience,
website.
well,
So answer your question, Pangoro,
Dian Nuswantara
is I want to
University is
make
very proud of you,
local
Mr.
sections like Jakarta,
Professor
people
Rahman.
like
So
you,
we wish
local
you good luck
chapters have some say
for the presidency
in how you
for the
want
next year.
IEEE
Well,
provide
yeah, hopefully
services
you are very
in your
competent
case.
for
That'll be
being in that position.
my operating
Okay,
principle.
somebody please.
Thank you very much, Professor Saiful. Good luck to you.
We still have.
Thank you.
Thank you very much, Mr.
About 15
Hanggara.
minutes.
Well, while waiting for the other
If
questions
you are ready
from
to
the
ask
audience,
questions, please type
well,
something on the chat, and then we
Dian
will call
Nuswantara
you
University is very proud of you,
to be
Mr.
with the
Professor
screen
Rahman.
with
So we
Professor
wish
Rahman.
you good luck for the
Okay, while waiting for questions
presidency,
from the,
yeah, for the next year.
audience, I'd
So
also
well,
like to
yeah, hopefully you
also
are
like
very
to say
competent
something,
for
Professor
being
Rahman.
in that position.
We
Okay,
are talking
somebody
about
please.
smart building. Do you think?
We
What do you
still
think
have
of the people if they are counting on
about
the smart
15 minutes.
building? Are they
If you are ready to
becoming
ask
less
question,
smart or
please type
something?
something on the chat, and then we will
Is
call
this
you
fear also happening
to
to our
be
mind at
in the
first?
screen
If
with
we are creating
Professor
smart
Rahman.
building, and then the people
Okay,
will
while
be
waiting
less
for
smart. What do
questions
you
from
think? Because we are
the
counting
audience,
on
I'd
very much
also
on the
like to
possibilities.
we also like to say something,
You know,
Professor Rahman.
typical office
We are
worker
talking about smart
spends
buildings.
half
Do
of
you
their
think?
waking
What do you
hours
think of the people
inside the
if they
building,
are
half of
counting on
40,
the
50
smart
hours a
building?
week, working hours, half
Are
of it.
they becoming
What we are
less smart or
saying,
something?
we want to
Is
make
this fear also
the
happening to
building
our
more
mind
healthy,
experts? If we are
better
creating smart
air
buildings
quality,
and then the people
so that
will be less
in the
smart. What do you
smart
think? Because we are
building
counting on
environment,
very much on
you
the
like to
facilities.
stay in the building as much as possible because you
You
feel
know,
a
typical
comfortable
office
working
worker
environment. That's
spends
my objective.
half of
The
their
controlling temperature,
waking hours inside the
ventilation,
building, half of 40
airflow,
hours a week, 40 hours,
humidity,
half of it.
and sometimes
What
lighting
we are
control.
saying,
So
we want to
what it
make
does, it makes
the
you
building
the person
more
working in the
healthy,
building more
better air
productive,
quality,
and
so that
you want
the
to spend more
smart
time there,
building environment,
so that you are
you like
not
to
just
stay in the
spending 8
building
hours
as
a
much as
day,
possible because
you're
you feel a
functioning much
comfortable
better,
working environment.
producing better
That's my
output.
objective.
So
Controlling
you go
temperature,
home more relaxed.
ventilation,
If you are in a building
airflow,
with a high level of
humidity,
CO2
and sometimes
concentration,
lighting
you
control.
go home tired,
So
lack of
what it
energy, don't
does,
feel like doing
it
anything
makes
after
you
they
the
come back
person
to office.
working in the
That
building
will change
more
if
productive,
we can maintain
and
the
you
high
want
air
to spend more
quality
time there.
in
So
the
that
building.
you
Now,
are
especially
not
with
just spending 8
COVID-19,
hours
it's
a
very
day,
important to
you're
have
functioning much
data
better,
about the
producing
building
better
air
output. So
quality in
you
terms
go
of
home more
virus
relaxed.
concentration.
If you
That
are
is
in a
one
building
way
with
this
a high
technology
level
can
of
help.
CO2 concentration,
I hope
you
that
go home
makes
tired,
sense to you.
lack of
Thank
energy,
you
you
very
don't feel
much.
like doing
That is
anything
something. Yeah.
after you come back from
And
office. That will change
so
if we can
by
maintain
smart building
the high
application
air
our
quality
facilities, it seems that we
in the
are
building.
spending
Now,
less
especially with
energy
COVID-19,
and
it's very
using our
important to
more
have
energy for something else, more
data
beneficial for humanity.
about
Something
the
like that,
building
Professor?
air
Yes.
quality in
You
terms
know,
of virus
different
concentration.
topic,
That
global
is
warming,
one way this
decarbonization.
technology can help.
That means we'll be using less fuel,
Thank you
using
very
less
much.
electricity,
That is something.
and you produce less CO2. It's objective globally.
So
countries,
by smart
US,
buildings application in
Europe,
our
said by
facilities, it
2040,
seems that
45,
we are
they will
spending
be
less
making
energy
no
and using
carbon-based
our more
output,
energy for
nothing, no
something else, more
CO2
beneficial
from
for
power
humanity.
generation,
Something
zero.
like that, Professor?
The problem with that,
Yes.
is
Different
you
topic.
cannot
Global warming,
keep on using more energy
decarbonization.
and make everything
That
from solar. It's not
means we'll
possible.
be using
So
less
I
fuel,
think to get a better
using less
solution,
electricity,
the
and you
system we're
produce less
working
CO2.
today
That's
to
objective
use
globally.
less energy.
Many
Like the
countries,
example I
like
gave you,
US,
20%, 30%
Europe,
less
said
energy
by
used to
2040,
run the building
45,
for
they'll
lighting and air
be
conditioning.
making no
What does it mean?
carbon-based,
If you use
nothing, no
20%
CO2
less
from
energy,
power generation. Zero.
that means you burn
Problem-
20% less fuel.
Problem is,
You burn 20% less
you
fuel,
cannot
you produce
keep on
25%
using
less
more
and 20% less CO2.
and
Very
make
simple.
everything from solar. It's not possible.
So this
I think
decarbonization
to get a better
can be
solution,
achieved not
the system we're
by
working
not
today,
only
we use less energy. Like the
moving
example I
from
gave you, 20%,
coal
20%
fuel
less
to
energy used to run
nuclear
the building
or
for lighting and air
solar
conditioning.
by using less energy
What
to
does it
begin
mean?
with, less energy.
If you
I
use
was in a
20% less
panel
energy,
meeting like this 3-4
that
months
means you
ago with
burn
the
20% less
energy
fuel.
minister from UAE.
Burn 20%
And
less
UAE
fuel,
has a
you
target
produce 25%
by
less, 20% less CO2.
2040
Very simple.
they will become
So this
carbon neutral. Use
decarbonization
all oil today, all oil,
can be
all
achieved
fossil fuel.
not
2040
by
carbon
not
neutral.
only
How they want to do
moving
this?
from
They will
coal
use
fuel to
40% less energy,
nuclear
40% less than
or
today
solar by using
by
less
using
energy to
building
begin with,
energy
less
efficiency.
energy. I was in
40%
a
less energy.
panel meeting like
Using
this
40%
4
less
months ago
energy
with
means
the
40%
energy
less
minister
fuel,
from
40%
UAE.
less CO2.
And
It's much
UAE has a
easier for them
target
to reach the
by
zero carbon
2040
goal because they're using
they
less
will
energy.
become
So I would
carbon
strongly
neutral.
suggest
Use all oil
in
today,
Indonesia,
all fossil
look
fuel.
seriously not only
2040
supply
carbon
side,
neutral.
which is coal
How
replaced,
they
coal
want to
will be
do
replaced
this?
by
They will
solar or
use
wind. Supply side,
40%
okay.
less
Look
energy,
at the
40%
demand
less
side
than
of that.
today
Example, Pangoro
by
S,
using building
remote
energy
islands.
efficiency.
I see. I see.
Do not
40%
let them
less
run
energy.
their system like Jakarta
Using
does.
40%
Lot of
less
lights for
energy
nothing.
means 40% less
So
fuel,
let them work at
40%
their
less
local
CO2. It's much
situation,
easier for
look at the
them
local
to reach
situation,
the
and
zero carbon
see
goal because they're
how
using
can they
less energy.
provide
So I would
same
strongly
quality service,
suggest in
cooling,
Indonesia,
lighting,
look seriously not only
ventilation,
supply side, which is
using
coal
better
replacing, coal will be
technology,
replaced by
and therefore
solar or
less
wind. Supply side, okay.
electricity to run.
Look at the
That will
demand
be my
side.
advice
Example,
going
Pangoro
forward.
S, remote islands. Do not let them run their system like Jakarta does.
This
A
is
lot of
really
lights for
new to
nothing.
us.
So
We are
let them
listening
work at their local
to
situation,
your
look at the local
explanations on
situation,
the smart
and
grids and
see
on the application
how
to
can
the
they
smart
provide
buildings,
same quality
even though the
service,
buildings are not very
cooling,
new, but
lighting,
still
ventilation, using
some
better
technicalities
technology,
of
and
the
therefore
smart grid. I
less
think that it will work very
electricity
well.
to run.
This is
That
really
would be my
something, Professor.
advice going.
Well, ladies and gentlemen, the audience, we still have
Okay, thank you very
about
much. Well, this is
5
really
minutes,
new to
about
us.
10 minutes.
So we
Please
are listening
type your questions in the chat,
to your
not raise
explanations on
hand.
the smart
So
grids and on the
we
application to
can
the smart
read your
buildings,
questions
even
for
though the
Professor Rahman.
buildings are not very
Please.
new, but still
Please type
with
your question in
some
Q&A section so we can read
technicalities
them.
of the smart grid, I think
And
that it will work very well. This is really something, Professor. Well, ladies and gentlemen, the audience, we still have about
So many,
5
so
to
many
10 minutes,
things
about 10
are
minutes.
new.
Please
Probably the
type your
audience
questions in the chat,
still thinking
not raise
about the
hand.
well.
So
This is
we
something.
can
This is
read
something
your questions
applicable. This is
for
something from the
Professor Rahman.
future, but now it is offered
Please.
in front of us, and we are still what is it? Having some contemplation on how this is gonna work in the near future. Maybe
So many,
something
so
like that,
many
Professor. Well,
things are
as there
new.
is no
Probably the
chat
audience
in the QA,
still
I'd
thinking
like to
about the
also,
well.
on
This is
behalf of the
something.
audience,
This is something
in
applicable. This is
your
something from
area
the
there
future,
in the
but now
United
it is
States,
offered
especially
in
the
front of us.
Arlington
and we are still
what is the
what is
percentage
it,
of the
having
application of this
what is it,
IoT and the
some
smart buildings in
contemplation
the area?
on
It's already
how
100%
this is
or
gonna
not?
work in the
Not that
the near
100%.
future.
And
Maybe
no.
We
something
have
like that,
very
Professor. Well,
good question.
as there
Very
is no
few
chat in
smart buildings, very
the
few
QA,
where I
I'd
live.
like to
I
also,
gave you maybe 4 or 5
on behalf
examples.
of the
Maybe there are
audience,
10 more out of
in
maybe
your
less than
area
1%,
there in
less
the
than
United
1%
States,
in the US.
especially in the Arlington,
Takes time. Takes time.
what is the
Why
percentage
are
of the
they
application
doubtful
of
in
this
applying this? It is
IoT or the
because of
smart
the
buildings in the
financing,
area, Professor?
what
It's
is it,
already
condition, or
100%,
because of the
or not? Not that
Issue
100%.
is
And
awareness.
no.
Awareness.
We have very
I see.
good
People have
question.
to
Very
understand
few smart buildings. Very
investing
few
some
where I live.
money,
I gave
benefit
you
you
4 or 5
get. People
examples.
used
Maybe there
to
are
normal
10 more.
life. They don't want change.
Maybe less than 1%.
Just
Less than
anything.
1% in the
Oh,
US.
really? Uh-huh.
But you have to
Time.
tell them the benefit,
Why
the
are
value, then
they
they
doubtful
slowly
in applying this? It is
change their mind.
because of
And
the
the question in the
financing,
chat box,
what
read the
is it,
question,
condition, or
is the
because of
cost
the...
of implementing building smart
Issue is
technology
awareness.
worth the power savings? Yes, it
Awareness.
is.
I
The
see.
example I gave you for that
People have to
70 plus
understand
year old building,
investing
we put the
some
system there,
money,
the savings
benefit
they
you
got,
get. People
they got
used
their
to
money back in 3
normal
years.
life. They
As
don't
an
want
example.
change.
It is
Oh, I
worth the
see.
savings.
I see.
In Jakarta area,
But you have
Indonesia,
to
because
tell
so
them
much
the benefit, the
high
value, then
usage
they
of air
slowly
conditioning in commercial
change their mind.
buildings,
And
you're
question
going to
in the
get
chat
money
box,
back
read
faster
the question.
because it's
Is the
saving so
cost
much
of
energy
implementing
by reducing
building smart
consumption
technology
from air
worth power
conditioning.
savings? Yes, it is. The example I gave you for that 70 plus year old building, we put the system
Your
there,
presentation, it seems that smart
savings they
building can
got, they
also
got their money back in 3
effect
years.
in our, what is
It
it,
is worth the
security
savings.
system, right?
In Jakarta
As
area,
this is also
Indonesia, because
effective
so
in the
much
security
high
system in the midst
usage
of
of air
the, for
conditioning in
example,
commercial
also so
buildings,
many
we're going
criminals
to get money
threat
back
here to
faster
people,
because
not only
it's
the health but
saving
also
so
the
much energy
physical
by
well-being of
reducing
the people.
consumption
Is this
from air
not something
conditioners.
seen by the people there?
Itu gimana?
In your presentation, it seems that smart building can also
What I'm
effect in our
saying
what is it
is
security system,
we
right?
have given you a
If
platform,
this is also
open
effective in the
architecture.
security system,
It
in
is
the midst
bringing
of the,
different
for example, for
applications.
so many
In
criminals
addition to
threat
heating
here
and
to
cooling
people,
in your
not
case,
only the
like
health but also the
security
physical
camera,
well-being of the
fire
people. Is
alarm,
this not
a rooftop
something
solar,
seen by the people
storage
there?
battery. All those things are good components to make the building
Professor,
What I'm
not just healthy,
saying
secure.
is
So
we
that
have
is
given you
my
a
message.
platform,
Make the building
open
secure
architecture,
by
I see.
keeping track of
different
everything going on.
applications.
That's what
In addition
we
to
like to
heating
see.
and cooling in your case, and lighting,
Okay, thank
security
you very
camera,
much, Professor. Well,
fire
are you living
alarm,
in one building,
rooftop
this smart
solar,
building there in
storage
Arlington?
battery, all those
Yes.
things
There are
are
multiple smart
good
buildings, but maybe 1-2% right
components
now.
to
I
make
see.
building not just
Okay.
healthy,
Well, during those,
secure.
actually during this
That
pandemic
is
era,
my
I
message.
think
Make the
this
building
smart building
secure
application should
by
be
keeping
very
track
suitable,
of everything
appropriate
going on.
for this our
That's what
this
I'd like to say.
unlucky circumstances
Okay,
here.
thank you
There's a
very much,
question.
Professor.
Well,
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 are
we are
you
lucky. We
living
still
in
have
one
questions.
building,
Well, we
this
still have
smart
about
building
5 minutes.
there in
There's somebody
Arlington?
here would like to ask questions
Yes.
from
Mr. Johnny
Mr.
Aritona.
Johnny Aritonang. I'd
I
like to
see.
read the question. How to
Okay.
anticipate
Well,
the
during
development
during
of
this
IoT
pandemic era,
in
I
the
think
future,
this smart building
especially with
application
the
should be
existence of
very suitable,
humans,
appropriate for
which
this
will
our
certainly
this
be
this
replaced by
unlucky
robots. Oh, we're talking about
circumstances
robots.
here.
To replace humans here.
Well, we are lucky.
What
We
do you
still
think,
have question. Well,
Professor?
we still have about
I
5 minutes.
don't
There's somebody
believe
here would like
humans
to ask
will be
questions
replaced by robots. I
from
don't believe that.
Mr. Johnny
Mr.
If you look
Johnny
at you
Aritonang. I'd
people
like to
like
read
yourselves,
the
office
question.
workers,
How
you
to
can hire a robot doing your
anticipate
job.
the
Cannot. A
development
robot cannot teach
of
my class.
IoT
Cannot teach my class.
in the
I
future,
teach myself.
especially
Yes.
with the
In the
existence of
factories,
humans,
you
which
replace
will
some human
certainly
labor
be
with
replaced
robots.
by
But
robots. Oh, we're
robots have
talking
to be
about robots
managed,
to
they have to be
replace human
programmed,
beings.
they have to be
What
supervised.
do you think?
So I think the people will move away from busy work. That's probably true, and do more
you look at
intellectually
you
satisfying
people
work.
like yourselves,
So
workers.
even
You can
then,
have a robot do your
you
job.
can say, well,
Robot
robots don't
cannot
need
teach
air
my
conditioning,
class. Cannot teach my class.
right?
I
They're
teach
too
myself.
hot.
Yes.
But
The
you
factories,
need air conditioning to
replace
keep the
some human
parts in good
labor
shape.
with
If the
robot
building
robots.
is too
But
hot,
robots have to be
the
managed,
cables getting
have to be
stretched,
programmed,
and they
have
get
to be
problem
supervised.
in their
So I
operation.
think the
So
people will move
we need
away
ventilation
from
for keeping
busy
the
work. That's
air
for
quality
and do
at a
more
minimum level. So
intellectually
even
satisfying.
though you're not breathing as
So
much there,
even
but for
then,
the equipment you're
you can
using,
say, well,
it has to be
robots
dust
don't need air
free, for
conditioning.
example. It has to be
They're too hot.
under some level
But
of
you need air conditioning to keep the
temperature
parts in good
control
shape.
for
The
the
building is too
equipment you're
hot.
using. So
The
robots
cables
are not
getting
going to replace
stretched,
human beings
they
in
get
large
problem
quantities. No,
in their
we are
operation. So
we can do
ventilation for
more
keeping
things
the
than robot can do for
air
us.
quality
I see.
at a
You mean
minimum
to
level.
say that
So even
it
though you're not
happens or it
breathing as
applies
much
on the movie
there,
only?
but for the equipment you're using, it has to be
But
dust
not
free.
only, for
There
It
is
has
a
to be
possibility in the very far
under
future.
some
you can
level
talk
of
about driverless car, for example, driverless car.
temperature
Right? You
control
don't need a
for
driver.
the equipment you're using. So
I'm not sure
robots are not going to
I'll
replace
not be
human beings
comfortable sitting in a
large
car,
areas.
nobody's
So
driving the car.
we can do more things.
Okay, maybe that will be our last question,
You mean to say
Professor.
that
Thank you very much,
it
Mr. Johnny
happens or it
Aritona.
applies on
I
the
think
movie only?
we are coming to the end of this
not
togetherness
only,
with
but
Professor
there is a
Rahman.
possibility
Well,
in the
time
very
is
far
flying
future.
so fast, Professor.
we can talk
Well,
about
it is
driverless
easier
car.
to
For
say
example.
hello than to
Driverless
say
car.
goodbye.
You don't need a driver.
Professor Rahman, I
I'm
would
not
like
sure
to
we'll
thank
be.
you very
I'm
much
not
for
comfortable sitting in a car.
your
Nobody's driving
contribution,
the
for your
car.
presentation, for well,
Okay,
everything
maybe
is
that will
something what
be our
you
last
did for us in
question,
this
Professor.
presentation of
Thank you
virtual
very much,
conference. Thank you
Mr.
very
Johnny
much. We
Aritona.
thank
I
you very
think
much.
we are
Well,
coming to
audience,
the end of
we are
this
coming to the end of this
togetherness with
session.
Professor
Before saying
Rahman.
goodbye,
Well,
let's give
time is
a
flying
big
so fast,
applause to
Professor. Well, it
Professor
is easier to say hello
Rahman.
than to say goodbye.
Thank you very much.
Thank you so
Professor
much,
Rahman,
Thank
I'd
you,
like
Professor.
to
very
thank
much,
you
Good luck
very
for
much
your
for
election, sir.
your
And
contribution, for your
I
presentation, for
you
your
start for the election. I would
well,
like to
everything
give
is
some
something
kind
what
of concluding
you
remark to
did
the
for us
audience.
in this presentation of virtual conference.
No, I
Thank
think
you
I
very much.
enjoyed the
We thank
questions
you
that
very much.
were
Well,
raised. That
audience,
shows the interest
we
in
are
there.
coming to the end of this
But
session. Before saying
people
goodbye,
ask me the
let's
same
give a
question:
big
how many
applause
buildings in the
to
U.S. are smart?
Professor Rahman.
Thank you so much.
Thank you very much,
About
For
Professor
your
Rahman.
election, sir.
presentation.
And Udinus
If you got
wishing you good
waits
luck
the
for
U.S. to do
the
it for you, do it
election.
yourself.
I
Now
would
you know
like
the
to give
technology.
some kind of
You know
concluding remark to the audience.
you know the people who can do it for you.
No,
So
I think I enjoyed the
energize
questions
people.
that
Yeah, I'm a
were
professor.
raised.
My job is
Shows
to
the interest in
make
there.
people start
But
thinking. Keep
people
thinking.
ask me the same
What can
question: how many buildings
That's
in the
my
U.S. are
parting
smart?
remark for audience this morning.
Okay.
Wonderful,
Thank you
sir.
very much. You are a
Okay,
very
maybe
good, very real
thinking about
scientist
this
for the
in
world.
the
Thank you very
next
much, Professor.
presentation.
Well, thank you very much
You
again,
don't
and
wait for US
see
to
you.
do
I
it for
wishing
you. Do it
you
yourself.
safe
Now
and
you know the
sound during this
technology.
unlucky
You know the
circumstances. We hope to see you
the
again in
people
the
who
near
can do it for
future.
you. So
Goodbye.
energize.
Goodbye. Thank you very much.
Yeah, I'm a professor. My
Assalamualaikum.
job is to make
Waalaikumsalam
people
Well,
warahmatullahi
this is
thinking.
wabarakatuh.
all the
Keep thinking.
presentation.
Yes.
What can
Salam warahmatullahi wabarakatuh
That's
from
my
Professor
parting
Rahman,
remark
audience.
for
We
audience this
coming to
morning.
the
Thank you very
second
much. You are a
session
very
today.
good,
This is
very real
also a
scientist for the
very,
world. Thank you very much,
very
Professor. Well,
outstanding
thank you very
expert
much
with some
again, and
other
see you. I'm wishing
field
you
here.
safe
This
and
is
sound during this unlucky circumstances. We hope to see you
Dr.
again in the
Muhammad
near future.
Zajat Nazir.
Goodbye. Goodbye. Thank you very much.
Well, ladies and gentlemen,
Assalamualaikum.
I hope you start
Waalaikumsalam
staying
warahmatullahi
and
This is
very
all
alert
the
and also attentive to
presentation.
this seminar and to this
From
conference.
Professor Rahman,
Coming to
audience.
Dr.
We're
Muhammad
coming to the
Sajat Nasir, we'd like to say
second
something to
session
greet
today.
the
This
expert.
is also a
Hello, good
very,
morning, Dr.
very
Nasir. Are you there with
outstanding
us already?
expert with some other
Yes, good morning.
field here. This is
Now you
Good
look very
morning,
great
sir.
today. You ready
Dr.
to share share something to the world. Okay, we'd like to say something first, Dr.
Well, ladies and
Nazir
gentlemen,
is an
you start
expert in
staying and very
renewable
alert
energy.
and also attentive to this seminar,
Renewable
to this
energy. Energy
conference.
can be
Coming
renewed.
to
Well, this is
Dr.
really
Muhammad
something. Dr. Nazir is from Huayin
the
Institute
expert.
of Technology,
Hello,
China.
good morning, Dr.
Well,
Nazir.
Dr.
Are you there
Muhammad
with
Nazir
us
today
already?
is talking about the topic.
Yes,
Well,
good
this is
morning.
also
Now
another
you look
something.
very great
Renewable
today. You're ready
energy, challenges
to
and
share something to the
opportunities.
world.
So we
Okay,
have
I would like to
challenges
say
and
something first,
opportunities
Dr.
of
Nazir.
wind and
He's an
electric
expert in
vehicles
renewable
development.
energy.
Okay, before the presentation, Ms. Titin
Renewable
would like
energy.
to say
Energy can be renewed. Well, this is really
introduction
something.
about our
Dr. Nazir is from
Professor Nazir.
Huayin
Please,
Institute
Ms.
of
Titin.
Technology,
Okay, excuse me,
China.
Mr. Dr.
Well,
Muhammad
Dr.
Sazan
Muhammad
Nazir. I
Nazir
would
today
like
is
to read
talking about the
some brief
topic.
bio of
Well, this
yours.
is
First of
also
all, Dr.
another
Muhammad
something.
Sazat Nazir
Renewable energy,
received his
challenges and
master degree
opportunities. So we have
in
challenges and
electrical engineering
opportunities
from
of
Chongqing
wind
University,
and
China,
electric
and
vehicles
PhD degree
development.
power system and
Okay, before the
automation from
presentation,
South China
Ms. Titin would
University
like
of
to say
Technology, Guangzhou.
some
Currently,
introduction
he is an
about
associate professor in the Faculty of
Professor Nazir.
Automation with
Please,
Huayin
Ms. Titin.
Institute of Okay, Technology, excuse me, Huayan, Mr. Dr. Jiangsu, Muhammad China. Sazan Nazir. He is I would also like the to member read of Chinese some brief Society bio for of yours. Electrical and first of all, Dr. Muhammad Sazat Nazir received his master degree in electrical engineering from Chongqing University, China, and PhD degree power system and automation from South China University of Technology, Guangzhou. Currently, he is an associate professor in the Faculty of Automation with Huayin Institute of Technology, Huayan, Jiangsu, China. He is also the member of Chinese Society for Electrical Engineers, serving as a reviewer of reputed top-ranked SCI Index journal. He authored a book called Renewable Energy, published by Lab Lambert Publishing, Germany. Research interests Dr. Muhammad Sazat Nazir are renewable energy technologies, wind power, power system protection and control, power electronics design and its application in power systems, and environmental engineering. So it's all about energy, sir.
Wow. Wow, what a record. What a record, yeah. Something about this excuse us. Well, okay, Dr. Nazir, are you ready for the presentation? Well, okay, the slide is ready. Hello, Dr. Nazir. Okay, now
from
you are
the
on. Okay,
slides, that you will
Dr. Nazir,
enjoy
you
the
have
slide
please
show.
make it
So
convenient.
many
You have 40
renewable
minutes to
energy.
present your thoughts, your
Energy.
ideas about this renewable
Hello.
energy.
Hello.
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 Okay.
Yes. Can you hear me?
Okay,
Yes,
now
I can
Nazir.
hear you clearly, sir.
Okay,
Okay, this is
we can see a
something
slide,
here
but not
happening.
you.
Okay. Assalamualaikum.
Okay, wait a
And,
minute, audience.
thank you very much
Yeah.
for inviting me here.
From the
Okay, Dr. Nazir, you have please make it
you
convenient
will
for 40
enjoy
minutes for your
the
presentation.
slideshows of so
All right.
many
Okay.
renewable
Thank you very much.
energy.
Please.
What is it?
All right. Okay.
Energy.
Thank you. Thank you. First,
Hello.
I would like to
Hello.
say welcome to all the distinguished guests
Okay,
Yes,
now
and
I
it's
can
clear
hear you
now.
clearly,
honorable
sir.
Okay.
director of the university,
We can see
and
a slide, but
special
not
thanks
you.
to all the IEEE section, Indonesia, and also the Dr. Sandy, who was my colleague in
Okay.
Guangzhou.
Dr. Nasir, you have
And
please make it convenient for 40 minutes for your
so
presentation.
I would like to continue my presentation today
Thank you very much. Please.
as they have already introduced me. My name is Muhammad Shehzad Nazir, and I'm working as associate professor here in Huayin Institute of Technology in China, Jiangsu province. So today, I would like to discuss about renewable energy, which all of we know that is the very important these days. That I would like to give the reference of Professor Saifur Rahman as well, as he was as pushing us the communities that we would like would like to adopt the renewable energy. So today I would like to introduce some of the challenges and opportunities of the wind and the electric vehicle development. So regarding this
important
renewable
these
energy.
days that
I will cover some of the
I would like
topics
to give
that
the
we will
reference
discuss about the
Professor
brief
Saifur Rahman
introduction
as well
of
when he
the
was
wind,
as
solar, and the
pushing
smart
us
grid
the
and
communities that
application, or we can say its
we would like
objectives,
the join would like to adopt
and
renewable
the
energy.
rules
So today I
of
would
the
like to
energy
introduce
storage
some of the
system and
challenges
electric
and
vehicles in the smart
opportunities
grid.
of the wind and
As
electric
we know
vehicles
that the energy
development.
storage system is also very crucial
So regarding
because
this
when we talk about the renewable
renewable
energy,
energy, I will
we know
cover
that
some of the
the
topics
wind
that
and
we
the
will
solar,
discuss
they are
about the
intermittent,
brief
the nature of
introduction
the
of
energy
the wind,
sources. They're
solar,
not the
and the
stable
smart
one.
grid and
If we talk
its
about the wind,
application,
I mean,
or we can
wind
say its
maybe some of the
objectives,
places is in the not enough
and
speedy
the
that we can
rules
utilize it
of the
very
energy
well.
storage system
Or if we talk
and
about the
electric
solar
vehicles and the
energy,
smart grid.
it's also like not
As
available
we
in
know
the
that
whole
the
world,
energy
and
storage
sometimes
system is also very
we can
crucial
say that it's only
because
available in the
when we talk about
daytime.
the
I mean, night times,
renewable
evening after
energy,
evening, we can't use.
we know that the
So
wind
regarding this
and the
solar,
solar,
the
they are
renewable
intermittent,
energy
the
sources,
nature of
that's
the energy
energy storage is
sources.
also
They're not
very
the stable
important.
one. If we talk
And
about the
then
wind, I mean,
if we
wind
consider
maybe some of the
that
places is in the not enough
decarbonization or
speedy
the
that we can utilize
CO2
it
emission,
very well.
that the electric
Or if we
vehicles
talk about the
is
solar
crucial
energy,
these days.
it's
The whole
also
world,
like not available
especially where I
in
am
the whole
living in
world.
China,
And sometimes we
like
can
electric
say that
vehicles
it's
are
only
like
available in the
rapidly
daytime.
adopted by the
I mean,
people
night times,
of China
evening
and
after
I
evening,
think
we can't
almost the
use.
whole world.
So
Okay,
regarding this
to
solar,
mitigate
renewable energy sources,
the
that's
CO2
energy
emission
storage is also very
and
important.
utilize the less fuel. I mean, that's the
And
less
then
fossil fuel,
if we
which
consider
is that is not like the
decarbonization
beneficial
or
for the humans'
CO2
health and so
emission,
on.
that the electric
So
vehicles
the smart
is
grid,
crucial these
we all
days.
know
The
that's
whole world, especially
we
where I am
discussed
living
about
in
that
China,
smart grid as well.
like
We
electric
know the
vehicles
smart grid
are
like
like
to
rapidly
control
adopted
or
by
to
the people
utilize on the one
of
place to
China
control
and
of all
I think
the
almost
load
the
and
whole world.
then
Okay, to
the load
mitigate
and demand as well. So that's
CO2
the
emission
latest development we'll
and
also discuss
utilize the
of
less
the
fuel.
wind,
I mean,
solar,
it's
and
the
the
less
electric
fossil fuel.
vehicles and
It's
EVs
that is
and the
not
electric
like the
vehicle charging. When we
beneficial
talk
for
about the
the
electric
humans'
vehicles,
health and
of
so
course,
on.
surely it is about
So
the
the smart grid,
charging.
we all know just
So some of these days
we
we'll discuss
discussed
in
about the
details,
smart
like
grid
just
as
for
well.
here, like the electric
We know the
vehicles,
smart
we can
grid
say
like
something
to control or to
like
utilize
about
on the
4
one
to
place
6
to control of
hours
all
after the
the
charging
load
we
and
can utilize it. So we
then
also have to enhance or
the
we
load
have
and
to
demand as
increase
well. So
to
that's
utilize
the
some new
latest
materials
development we'll
for
also
the
discuss
charging
of the
purpose.
wind, solar,
So
and
then
the
it
electric
can
vehicles
more
and the
will be
EVs
confident
and the
of this
electric vehicle
technology
charging.
to
When we
replace
talk
the
about the
fossil fuel
electric
based
vehicles,
electric
of course,
the
surely it is
vehicles.
about the charging.
And then
So
next,
some of
like
these
we'll
days
discuss
we'll
about
discuss
the
in
impact
details. Like
of the
just for
wind
here,
and
like electric
electric
vehicles, we can
vehicles,
say
the
something
charging on the power
like
system
about 4 to 6
and
hours
planning
after the
and
charging we can
operation
utilize
as
it.
well.
So we also have to
And at
enhance
the
or
end,
we have to
I would
increase
like to conclude
to
like
utilize some
some
new
of the my
materials
suggestions.
for the charging
Okay, so
purpose.
let's see
So
here
then
like
it
the
can
what's happened in
more
the world
will
and
be
in the past.
confident
Like here we
of
can
this
say
technology to replace the
implications
fossil fuel
of the
based
blackouts.
and
Some examples affected
vehicles.
by the over 5 million
And
people
then
in the
next,
past.
like we'll discuss
So
about
that
the
was
impact
that we
of the
can say
wind
that
and
most of
electrical
the
vehicles,
fossil fuel
the
based
charging
the power system
on the
that we
power
can say
system
some of the examples
and
like
planning
from
and the
2003 we
operation
can
as
say,
well.
and Italy
And at the
the
end,
blackout
I would like to
55
conclude
million
like
people
some of
affected
the give
by
my
that.
suggestions. Okay,
And
so
then
let's
next
see
that we
here
have
like
that is the in
what's happening in the
2003 as
world
well.
and in the past.
That's
Like
North
here we can
American,
say
that's the Northeast blackout,
implications
and
of the
same the
blackouts,
55
some
million people
examples
also
affected
affected
by
in
the over
that
5
blackout
million
as well.
peoples in the past.
So
So
we
that
have
was
here
that we
back
can
this
say
one
that
2001,
most of
12.
the fossil fuel
Okay,
based
so in
the
this
power
one we can say
system
that
we
there
can
was
say
in
some of the
India that's
examples
a
like
blackout and
2003 we can say and
30
Italy
and
the blackout
620
that
and that's
55
million
million
peoples affected and respectively in that time.
And then next that we have that
And then next we in 2009 we can say that it was the Brazil and the Paraguay blackout that we have that 87 million people actually affected in that blackout.
Back this one,
So of course that all these blackouts,
so
it was not like the in the favor of the energy the users and then the humans. So then next that was we can say about 2005 as well. It was in Indonesia, yes, and in your country, like it was in the Java Valley, that's a blackout, and 100 million people that times also affected in that time.
Brazil,
You all might be the witness of that one, most of you. And then is the 2014, that's in the Bangladesh. Okay, that's blackout. There's 150 million people as well affected. And next, that we can say 2015, that's Turkey, that's in the blackout. And 70 million people affected in that blackout. And the same, like it is in my country, that's Pakistan, 2015, there was a blackout. And 114 million people was affected in that blackout as well. So that was some like the overview, like what happened in the past about this, because of the energy. So that was the preview, and here we have the energy technology trends in the future. We can see in the future, just as I said, like about that the vehicles we are utilizing, okay, and the other side energy storage, okay, and then these days we're also using the artificial intelligence, AI techniques, approach in the energy system, and we have IoT. Yes, Professor Saffron he already details in he said. And meanwhile, we also using the platforms and business models, okay, and the different ones we can say all of these ones they are also utilizing, and aggregators, the VPP, the vehicles and the blessings as well. So beside this one, we can say from here we have the electrification of the end use sector. Behind this one, we also have the massive expansion of the interconnection and creation of the regional markets. Okay, so here we can see that side we can say it is the system operation. Okay, in that side, and all these are based on the renewable technologies, we can say, and that we have the value of the complementaries and the renewable energy sources. On that side, we can say that is the market regulations. We also have some of market regulations that we still have to extend and enhance these market regulations. Because of the renewable energy technologies, integration of the renewable energy technologies. So we have the decentralized system through the distributed the generation as well. And the other side, we have all this. So in this way, we can say that in the future, we have the innovation trends for the future power system. So what will be that one? We can say that is the digitalization. We still have to extend. The second one is the decentralization. And then we also must have the flexible system, the future. And as well as we have the electrification, and that we have that of the end of the use as well. So here, as we said, the renewable energy. So we would like to say that the wind and the solar energy development. I would like to say like some of the data. I would like to show you over here that here we can say from 2010 to 18, we collected some of the data. We would like to share. That was about the wind, and here we have the annual capacity by the region. And as well as the 2010 to 18 data. And here, like different countries, we can say that here is like the Asia. Okay, and then we have next one, that is the Middle East. Over here, some countries, Africa and Middle East, and the Europe, we can say. And then is Latin America and also the North America as well, and the Pacific region as well. Here all of we have some data. So we can say the wind in 2018 that increased in the wind generation that was equal to the almost half of the global load demand. We are talking about the wind growth. And the new installations we have only in the China, okay, just like the countries, Africa and Middle East, only in the China, and the Europe, we have the 30 gigawatts, and then these are 30 gigawatts. And if we talk about the global, that was the 63 gigawatts. We can say the half of that one it is in China. In 2018, that's and the other side, if we talk about the solar, the photovoltaic generation, that's the capacity, the gigawatts, we can say all this one. we have these values from Japan, okay, and then we have Germany, the profit, then we have the US, Spain, Italy, and then China is also over here, and then the rest of the world as well. So many countries they are also like focusing on the on the renewable energies, including the wind and the solar. So the photovoltaic, the solar energy that from 2003 to 18, that's installed, that photovoltaic increased from 1.3 gigawatts to the 187 gigawatts. And the five countries, only the five countries, that they account for almost the 70%. Okay, that's including China, USA, Japan, Germany, and Italy. So only the five countries. So rest of the world is also like some countries those who have been blessed by this energy. So they are also utilizing, of course, in that way. And some key that's problems. We also have the problem for this one for adopting this renewable energy sources. So we can say that due to the large-scale renewable energy sources, that the integration, of course, there is some problems as well. I mean, some issues which are facing. Yes, we can say the temporal mismatch between the generation and the demand due to the system uncertainty. At in the beginning, as I said, because that's we already have the conventional system, so it is not easy to, of course, couple with them, to integrate together and integrate them and to use it, utilize it, and to use it together. So we can say that. So that is, and also the system demand and the generation, because this is also one of the issues that the fossil fuel based energy in this way, we can say it is good, like we can say the constant, or we can get the output. But here in the renewable energy sources, as we are talking about the wind and the solar, so we can't have that one as we discussed. The solar energy is not available after evening, and so we need to have some other approaches by the energy storage devices. And if we talk about the wind is also not constant speed, so we have the uncertainty of these both renewable energy sources. And we have a transmission, the congestion that's due to the increase that wind and the solar power as well. And we have the bidirectional, the power flow, and the distribution system due to the distributed generation as well, DGs. So that here we can say the use of smart grid, okay, the application of smart grid, we can say the intelligent electricity infrastructure that uses the technology that we can say, such as the sensors, communications, automations, and the computers to improve the flexibility and the reliability and the efficiency of the electricity system. So these days, the smart grid, it is very useful and very we can say applicable. It's very attractive these days. So we can say that overall we have here from the system we have provide the high quality power. One of these ones, okay. And the other side we can say that the consumers to participate in the operation of the grid. And both will be together. And the other side we can say is self-healing. Okay, also the self-healing, because this is when we call it smart or the intelligent one, so it can self-heal. It can like give us the advanced, like especially when we talk about the wind. Like on the solar, it can give us the advanced using the AI artificial intelligence. It can provide us the advanced that's wind speed, so we can say predict the advanced the wind speed, so we can use some other standby systems as well. So accommodate all the generations and the storage options. It can accommodate. I mean, we can say use the energy storage devices and so on. And next we have the enabling the intermittent power generation sources. Okay. So in this way we have also that it can enable all the energy resources. We can have storage, we have a smart meters and residential consumers as well over here. And then we have the electricity markets will flourish as well in this way. We utilize renewable energy in this way. So we have the operates the more efficient way, okay, by utilizing all this. We can have the utilize the more efficient way as well. So that here is the broad picture of that smart grid and the centralized grid. Here we can say from here we can see from the smart homes, okay, and then all the connected together and the one place. Okay, if we talk about this one, we can also say the factories and the industrial loads, and we have the nuclear power plants, and we have smart vehicles as well, and we have the solar and the wind and other biomass renewable energy source and so on. And electric vehicles, of course, that we have, and then we have the smart cities as well. Smart cities can also be interconnected and together, that we have the smart homes as well over here. So here we can say that if we say the smart grid realization with the full application of the PE and the ICTs, okay, that we can say power electronics, I mean, and we have the ICTs as well. So we have the long distance and the large scale, the power transformer, the transfer, we can say the grid. From here we can say the mixed generation sources. Okay, all of this one I'm trying to like that's so, about the focus on the renewable energy and the smart grid, or we can say microgrid, different intelligent, and we can give the name on the different way. Okay, that we have that is about the mixed generation sources that we have with the grids, okay, connected and in and out the information. And this one we can say this one the circle of that one is presenting the PE, the power electronics interface. Okay, we can say the conversion of the energies like we can say AC to DC or DC to AC and so on, inverter, converter, and the power electronics interface. And that one we are representing by the power flow as well. That here we have that information flow, because when we talk about the smart grid or this one macro grid, so we must have the information transformation. Information flow is very important in this case. So then we also have the information and the communication technologies, that ICs, information communication technologies. And this one is representing when we talk about the information flow. So we are talking in the information and the communication technologies, the application, and we can say IoTs and so on. And then on that side we can say HVDC or the MVDC. And that side here we have to utilize the FECT or the defect devices. Okay, the FECT devices we have to utilize that one. I mean the shunt and the parallel system for our transmission sides mostly. So in that slide we can see the flexible power flow control, that one, flexible AC transmission system. And then we have the demand responsive, that's a load, DRI. And that side, in the future, grids, we have the electrical vehicles, and then we also have the distributed generators as well. We can say the DGs, and based on this one, we can utilize from here directly. I mean that one is the renewable energy sources and the penetration. And we say that is the energy storage system, that ESS as well. We have so all these are the smart grid. We have the realization that we have the full application of the power electronics, and we have the information communication. So all these are together on the one place, and in this way we can say that is a smart grid. So the energy storage system, that is one of the main element, or we can say the component in that smart grid. So we have the smart grid as well. So we have the why we I mean that sometimes the people say that why we use to the energy storage system, energy storage devices. So that is very important and need to understand for the community, and awareness is also very important in this case. So we can say that it's intelligent integration of the renewable energies. Okay, we can say it's an internet. Okay, so we have the wind, and then we can say that we also have the services, and that we have been meeting the peak demand, of this one. And energy storage systems play the several roles in the different parts of your power system. So first that we can say is the generation side, okay, the energy storage on the generation side. On the generation side we have the time shifting, okay, the advantage we have the output smoothing. Based on the energy storage we can have this one, the time shifting as well. as well as we can have the output smoothing, and we also have the capacity forming as well. And if you talk about the grid side, after the generation, we have the grid, the power system, we already know that is. And then we can say the load leveling. Okay, the load leveling, that is very important as well. We have the frequency regulation, and we have the inertia accumulation as well. Then we have the voltage control. Okay. Then we have the load leveling over here, and we have the peak shaving over here as well. And then we have the inertia emulation, voltage control, low voltage right through LVRT. That's the students or the researchers, LVRT, electrical engineers, they already know this code. And then we have the operating reserves as well. And the transmission utilization efficiency is also one of the benefit of the, we can say, the grid side the system. Then we have the demand side. Okay, that is, we can say, supply and the demand side. The demand side management as well in this case, we can also regulate, or we can say that we can use in the better way of this the demand side control. Next, that we have the existing, the capacity of the energy storage system. Okay, the existing, we have some storage capacity, and then we also have to enhance this one, expand this one. So total energy capacity, we can say it is a little bit the old data. So we can be updated by this one, and we have almost like 140.976 gigawatt, 3.2% of the total generation. Okay, that's about 4,000 gigawatts. And we have the compressed air energy storage. Because we have the form of energy storage, we also have this one, different one. We have the batteries, we have the flywheels, and we have the air energy storage, and some other techniques as well. So we have the compressed air energy storage. It's about 440 megawatts, if we say. And we can also say the sodium sulfur batteries as well over here. And then we can say the lithium ion battery also over here, about, which is contributing about 100 megawatts. And then we have a lead acid batteries as well, that is contributing about 70 megawatts. And if you talk about the flywheels, we have the 25 megawatts, and including there's nickel cadmium batteries, that is about 27 megawatts, and redox flow batteries. Okay, you can be operated with the over here, and then we can present data, a little bit old data, so I'm sorry for that one, but still I can give you some of the ideas about this one, that how much the capacity is already the ES energy storage system. 70 megawatts. So overall, we have this one, that's the pump hydro, 40 gigawatts, about 10% of the total storage capacity. Batteries, that is the most of that. So we can say that it is insufficient to address the high variable and the uncertainty and the renewable generation, and a more cost-effective solution is needed as well. We cannot say it. These days, as we are talking about the very rapid growth of the technology, so we cannot stop on the one technology. We cannot say that that's enough. We need to continue and continue to find the better solution of our future for the humans, and for the better human life as well. So we can say that. So we have electric vehicles and energy storage systems. That over here we can say in the energy storage systems, that we can see in the lead acid batteries. Most of them. We have many of this one. We have a fuel cell and also other step approaches as well, other techniques. So, but here I would like to only give a little introduction about that one, that we have used in the electric vehicles. Most of this one, that is the high power density. These both approaches, the lithium batteries and the lead acid batteries. And we have the high power density and the high energy density as well, and the fast response over here. We can say the clearly the long lifetime and the probability as well. So we have different of this one. We can say the ratings density is based on this one. It might be like some other approaches and some other type of the batteries as well, on based of this research or based on the high power density group research, that we can see the ratings and the density. We have the response time, and we can say the efficiency and the self-discharging, and that is the per day and the lifetime per year. We can see in the years. So we have the cost at the end as well in the dollars. So on based on this one, we can included this data.
We can say the ratings
And type of energy
is
storage,
based on
we
this one.
discussed
It might be
that
like
we
some
have
other
the different
approaches
type
and
of
some other
energy
type of the
storage.
batteries as
We
well.
have
And based on this research or
this
based
we
on
have the
this
discharge
my
time at the
group
rated
research that we
power,
can see the
and we
ratings
have the
and the
system
density
power ratings
and
and the
the
module
response
size as
time,
well.
and
But
we
we can
can
say
say
the
the
reserve and the
efficiency and the
response services.
self-discharging
Based
that
on
we
this
can see
one,
the
we have the
quality and
high
the
energy
lifetime per year.
supercapacitors,
We
and
can
we have
see the
nickel,
years
cadmium,
and the cost
batteries or
as
energy
well, the
storage
dollars.
devices as well.
So on based on
If
this
we
one,
talk about the
we can
transmission and
include it,
distribution,
this data.
the grid support,
And type
that
of
we
energy
have
storage,
the flow
we discussed that we have the
batteries.
different type of
I
energy
mean, that
storage
we
too.
have the
We
sodium
have
sulfur battery as well. We have
this way we have
advanced
the
lead acid
discharge time
batteries
at
and the
the
lithium
rated
batteries
power,
and so
and
on.
we have the system
And
power
the main
ratings and
important
the
that is
module size as
we have
well.
the flywheels
We can say
and
the
the
reserve
high
and the
power
response services.
supercapacitors.
Based on this one,
And
we
then
have the
we also
high
have in
energy
this case the super,
supercapacitors,
that we have a
and we have
conductive,
nickel,
that's the
cadmium,
magnetic energy
that
storage
batteries
as
or
well.
energy storage devices
That we
as
have.
well.
And if we talk about the
transmission
bulk
and
power
distribution,
management, that we can say
grid
the pump,
support,
hydropower
that we have
storage,
we have the
and we
flow
can say the compressed air, the energy
batteries.
storage as
I
well,
mean, that we have the
and
sodium
then so
sulfur
on. We have
battery
all
as
this
well.
one.
We have
So
advanced
key,
lead
like the
acid
type of
batteries,
energy
lithium
storage we
batteries,
have,
and so
that's
on.
mostly
And the
it is
main
related
important that is
that we have
we
a
have the
different
flywheels
approaches,
and the
that we
high
have the
power
hydrogen
supercapacitor
related,
and the capacitors.
and we also have the
And we
mechanical
also have in
related,
this case the super
and
that
as
we
well
have a
as we have
conductive, that's the magnetic
electrochemicals, of
energy
course,
storage
that
as
is
well
related, and the
that we have.
electrical
And if we talk
surely,
about the bulk
and then we
power
also have the
management, that we
thermal
can say the
resources
pump,
as well. So on
hydropower
based on this
storage,
one, just we said
and
the
we can
lead
say the
and the
compressed air, the
acid
energy
batteries
storage
on
as
the
well.
electrical vehicles based on
And so
mostly
on.
on
We have
this
all
one,
this one.
these two
So
approaches.
key like the type of the energy storage.
So if you talk
we
about
have,
the
that's
motivations for the
mostly
electric
it is
vehicles
related
adoption,
that we have
that
a
we have the
different
transportation
approaches that we
sectors
have
that
the
accounts for the
hydrogen related,
27% of the
and we
energy
also have
used
the mechanical
worldwide.
related,
Worldwide, if
as
it is
well as we have
27%, maybe this time it will
electrochemicals
be
of
more
course
than
that
this
is
one.
related,
Okay,
and
as the
electrical
last previous,
surely,
like we can
and
say
then we
the
also have the
half decade,
thermal
this
resources
electric
as well. So
vehicles
on
is
based on this one,
rapidly
just we
increased,
said the
especially
lead
in
and the
the US,
acid
and we
batteries
can
on
say
the
also in
electrical
China
vehicles
and some
based
other
on
countries
mostly
as well.
this one, these two approaches.
So worldwide, we can say simply
So
that
if you talk
the
about the
world energy
motivations for
consumption
the
that
electric
we have in
vehicles
the
adoption,
US, that we
that we
can say
have the
it is the like
transportation
industrial is
sectors that accounts
52%
for the
and the commercial is
27% of the
8%
energy
and the
used
residential is
worldwide.
13%.
So
Okay, and the
worldwide, if
transportation
it
is
is
27%.
27%, maybe
Okay,
this time it
we
will be
have
more
just
than
one the
this
case
one.
study of
Okay,
one of
as
the country.
the
We
last
just gave
last previous like the we can say
data
the
that we have the
half decade,
transportation
this
energy
electric vehicles
consumptions,
is
okay,
rapidly
that we
increased,
have overall,
especially
we
in
can
the,
say the oils products.
US,
Okay.
and we can
So
say also
it
in
should be
China
like
and some
replaced.
other
It
countries
should be
as well.
replaced, reduced.
So worldwide,
Review
we can say
reduction
simply
is
that the world
somehow
energy
not
consumption that we have in the
possible.
US,
So it
we
will, it
can
is
say it
increased
is the like
actually. So
industrial
we
is
need to reduce
52%
that
and the
one.
commercial is
That's
8% and
red
the
side only
residential is
3% oil
13%.
products. It
Okay,
means
and the
like we
transportation
can
is
say the
27%.
fossil fuel based.
Okay, we have just one the
And
case
the
study
others
of
we
the
have
one
the
of the
like the
country we just
biofuels and the waste and the coal,
data that
and
we have
then
the
we also
transportation
have only
energy
the few one is the
consumptions,
natural gas
okay,
and
that we
3%.
have overall we can
So
say the oils
that's a
products.
global,
So
like we
it
could talk
should be
about
like
the
replaced.
emission,
Okay,
that
it
we
should
can
be
say
replaced,
CO2 emission
reduced
from
from
the fossil fuel, the global
reduction
carbon
is
projects.
somehow not
We can say from the
possible.
1990s
So it will
till
increase
today,
actually.
and like
So we need to reduce that
the previous
one.
year, we
That's
can say
that's
that
red side
mostly it is
23%
increased.
oil products. It
That's
means
good.
like we can say
Actually,
the
that's
fossil
a good
fuel
one.
based.
But we can say if it is in
And the others we
2013, it
have
was
the like
better
the biofuels and the
2.3%,
waste and the coal.
3%.
And
But
then
here we
we
can
also
say
have
that it
only
is
the few one is a
2.3%.
natural
It still
gas
need
3%.
it is
So
still need like
that's a global like we
some
can
more
talk about the emission that we can say CO2
addition, or we
emission
can say
from the
duration
fossil
of
fuel, the
this
global
one.
carbon
So
projects.
that one we can say from
We can
that
say
we have
from
the
the
trend of the
1990s
global
till
means
today,
that we have a
like
temperature
the
anomaly
previous
that we
year
have
we
the
can say
NASA data. It's
that
about 5 years mean, we can say that it's also increased from the 1990s to forward. So the outlook of the electric vehicles, the globally, that we can say the globally numbers of electric vehicles reached 1.52 million in the 2018. So this amount is 100 times greater than that in the 2012. So it is a good sign that for the electric vehicles, awareness and adoption, and the people confident on that one. So that is good sign towards the for the human's life, or to reduce the CO2 emission and so on. So that we have the global electric vehicles deployment until 2020 that we have it was like 20 millions. Okay, and it is a different countries data is available here, that we can say Netherlands, UK, US, Canada, France, Japan. Okay, and then some other countries as well, and we can say that China as well is over here. So we can say that mostly in the USA and the China mostly is on the like the electric vehicle sales in the market. Actually, adoption is also okay, but China is also producing a lot of that one, the electric vehicles. I mean, one of my group that is also working on the electric vehicles as well. We have some good publications on these electric vehicles as well. So that's the sales and the market share in the some of the leading countries, when we can say mostly the China, US, the Netherlands, Norway, UK, and Japan, and Germany, France, and Sweden as well, and some other countries as well. So that we can see the electric vehicles traveling range after the recharge. We can say some of this one, and like for the sedan, this is the one of the brand that we can say electric vehicles ranges only 160 kilometers to 200 kilometers. So this is also one of the reasons that the intercity usage is fine, but for the long range, the people have not much confidence about to utilize these vehicles. So this needs to be more research. This needs like more some hybrid electric vehicles. We have different companies that we have one on the some 300 kilometers or even more. And if we talk about the racing, that is 430 kilometers, and some taxi, okay, and that we have we have the 4 seats that is range about only 300 kilometers as well for a typical shift. And intercity, that's for the people utilization or adaptation of this electric vehicles is good, is a positive, but for the long range, of course, for the other cities traveling, that is not the feasible one. That we can also say that we have that for the buses, we also have that electric vehicles, that the buses that we can say that is KMB, single air conditions, that we have a number of passengers, 56, that it can travel 180 kilometers as well. So that we have the charging times of this one. So this is also one of the factor that we have from the sedan electric vehicles. We have the slow charging, 7 to 8 hours, and so this is the longest time. I mean, that is also one of the factors that the people can't adopt, actually, that can't not confident to utilize this one. So still much research is needed in this sector, and the semi-fast charging, that's 2 to 3 hours. It cannot be still acceptable. That's a quick charging, that is 30 minutes, still improving. So that's a good sign in this field. About electric vehicle charging time reduction is good. Then we have the for BYD e-taxi, that's a normal charging, that's 2 hours, and we have from the KMB e-bus that we have the normal charging is 3 hours. So still much research is on the way, that we can say that here we have the Tesla Motors, a successful electrical vehicles manufacturer. Tesla Motors, that we have the Tesla Motors is an American company that's founded in 2003, which designs and manufactures the electric vehicles and the battery products as well. So here we can see there are models over here. There's electric vehicles model, and the batteries and capacity that we have the average range. This one, then we have initial price, that one as well, and then we have a mass production, that's the start years. You can say. So we have the lithium ions that we have 53 kilowatts hour. We can say that one is the first road step. We have 390 kilometers. Of that one is the average range, and its initial price is over here in the dollars. And then that is the 2008. And then we have a Model S, X, and the Model 3 as well. So all these models, we have there's the battery range and the lithium-ion battery we utilize, and there are also lithium-ion batteries. Okay, that we have the lithium-ion batteries and so on. All these lithium-ion batteries actually are adopted over here. And average range, we can say that's 390 kilometers and the 420 kilometers. I mean, that is the average range. Okay, and then we can say the 410 kilometers for the X model, and then we have 346 kilometers for the for the Model 3. So we have that the Model S is world's best selling electric vehicles in 2015. And the Model 3 has more than, like we can say, 305, that one. So of the April 2016, in this case. So that was, and if we say the vehicles that we cannot say, the EVSE is required to act as the interface between the electric vehicles and the power grid. So that's all about electric vehicles and some of the introductions about all these electric vehicles and the equipped and the EVSE, so on. So that is, I think it is going to be over. So that one, all of that we have level 1, level 2, and the DC fast. We have the some of introduction over here. Electric vehicles charging, you can say that one. And electrical charging and the manufacturing and the different countries design the vehicles, different vehicles, so on. We have different models. Let me, I think time is almost over. So let me. So that one, all of that we have level 1, level 2, and DC fast. We have the some of induction over here. So electric vehicles charging, we can say that one. And electric vehicle charging and the manufacturing and the different countries design and their electric vehicles, different vehicles, okay, so on. We have different models. Let me, I think time is almost over. So let me. Okay, that's we have that's the integration. That's the integration of that one, of electric vehicles into the electric power grids. That we have the large-scale operation of electric vehicles will pose the new challenges and opportunities to the power system, and in the different levels. We have the uncontrolled and the integration of the electric vehicles, and then we have the uncontrolled electric vehicles. That we have the load profile change due to the uncontrolled electric vehicles. Here we have given the data for the challenges which are facing the electric vehicles. We have distribution, the equipment, and the overloading, that's the voltage drop. That we have the loss, that's the increase, and need for the investment in the different levels. We have the uncontrolled, we can say, and the transmission. If we talk about transmission, then that we have the load profile change, the uncontrolled, that's the congestion in the lines and need for the investment in the grid, and we have the generation as well. So we have the integration of the vehicles, wind into the electric power grid. I think my time is up almost. And need for the investment. Okay, let me. And we can say, and the transmission. Okay, like at the end, I would like to okay, that's just useful some data which we have published, and some of the good papers about environment impact, and that we have the pollution related challenges of the renewable wind energy paradigm that we have. It is that in the 2019 that we have in the Q1 journal, that's the sense of the total environment. We have the group publication that we have. The other one is the energy and environment. It's CI journals. We have the publication from our group that we have wind generators, and then we also have from my other group we have the potential environment. One of the group journal, that's the current opinion and the environmental sense and the health. Then some of these my publications you can check in from our group. So I would like to conclude my presentation over here as renewable energy usage. We can say that address the increasing the concerns about the energy security and the fuel and the diversity and the climate change. And then we also have from my other group we have the potential environment. We can say the electric vehicles, and that is the key current opinion in the environmental sense and the health. Then some of these my publications you can check in key component in the so I would like to conclude my presentation over here. That's renewable energy usage for the balancing the variations of the renewable concerns about the energy generation and the improvement and the flexibility of the system operation. And then we have the progress and the massive usage of the electric vehicles depends on that we have the advanced batteries, key component in the power grid for the balancing the variations of the renewable generation and the improvement, the flexibility of the system operation. And then we can also the massive usage of the electric vehicles depends on that we have the advanced batteries. So that's it. That was about the conclusion that we have. And then the progress is a massive usage of the electrical vehicles that depends on advanced battery technology. There's a longer travel distance, and then that we have also, and advanced battery technology that we have the higher power charging and technology that's a short charging time. That's it. That was we have the mass production, lower price of electrical vehicles, and the smart grid technologies such as V2G, vehicle to grid. And then that we have the low operational cost of electric vehicles, and as well as we have that about the improved system planning and operation support for the massive electric vehicle usage, power charging and smart grid key enables for the increase the usage of the renewable energies and to address the operational challenges that are faced by the power utilization due to the high variability and uncertainty in the renewable generations. So that's here I can conclude. And so at the end I would like to say that global trends of the wind and electric vehicles usage is reversible. And electric vehicle charging is important for the massive integration of the renewable energy in the operational challenges. So thank you for your patience and the listening. There might be some, I think, the problem in the beginning. I'm very sorry for that one. And okay, that's it for me. Thank you. And so at the end, I would like to say that global trends, the wind and electric vehicles usage is
Thank you very much for the presentation. Can you hear us? There is some technicality problem here. Can you hear us now? Yeah, your slide presentation is very clear. No worries. Yeah, so, but can you hear us now?
Thank you for your patience. Hello? Yes, I can hear. Oh, sorry for that.
Thank you very much. Thank you very much. We're still watching you, but not we are here having some technical problem. No, now it's settled now. Well, we have now still 15 minutes for QA.
Thank you very much for the presentation.
Okay, we have asked the audience to type something on the QA. Can you hear us now? After we call the name,
your slide presentation is very clear.
They can raise hand.
Can you hear us
okay,
now?
We have somebody, yeah?
Yes, I can
hear.
Thank you very much. Thank you very much.
Wow,
still watching you, but
participant. Right. We'd like to
we are here having some
read the question here. How do
now is settled now.
Maybe
Mr. raise hand. Okay,
we have now still 15 minutes for
Mr. Johnny Aritonang himself. Maybe raise hand.
We have
so we will give you the platform,
the QA, and then
we'll give you the floor.
After we call the name, we can they can raise hand. Okay, now we have somebody here.
Okay, we'd like to read. How
from Mr. Johnny Aritonang again.
Wow, WV compare in terms of advantages and disadvantages, especially in the terms of road safety. Will WV or WV battery
Mr. Johnny Aritonang himself
damage or
unused? We will give you the platform.
Is that clear?
We'll give you the floor.
Clear, Dr. Nasir? Yeah.
Yes, I can
Okay.
hear. Actually, like the electric vehicles, when you talk about the
We'd like to
electric
read. How
vehicles,
do
I would like to say that he mentioned
EV
that's a road
and
safety. Actually,
WV
there's
compare
no
in
problem
terms
for the
of
road safety.
advantages and
It is same like the
disadvantages,
other vehicles,
especially in the terms
same as
of
the other vehicles.
road safety?
Same
Will
we
the
use
EV or
the hybrid
WV
vehicles. We
battery
utilize
be
the
recycled
hybrid vehicles,
if it is damaged
and
or
we use
unused?
the other vehicles and the fossil
Is that
fuel
clear,
based vehicles.
Professor?
That's
Is
not
that
a
clear,
problem
Dr.
for the
Nasir?
electric
Yeah.
vehicles. But I'm not sure about what is WV. What does it mean? EV is electric vehicles, but what is WV? Sorry, I'm not clear about it.
Okay,
What is
maybe
WV?
Juni Aritonang can explain a little what EV
WV.
means.
EV is electric vehicles, but WV.
Not WV. WV. Okay, WV. What is
WV.
WV?
Mr. Johnny Aritona, what is WV in your mind?
Yes. Wind actually, yes, wind is not the vehicle. Wind we are using as an energy
Wind.
source.
Oh, I see. Talking about the
Yes,
wind.
wind.
Wind is
Okay,
not
maybe
vehicle. Yeah.
Juni Aritonang
Wind is not a vehicle
can
actually.
explain a little
Actually,
what
wind is not a vehicle. Wind we are
EV
using as
means.
energy resources, as an energy source.
Energy resources.
Not
Electric vehicles.
Yes,
WV.
energy resources.
WV.
I mean, the
Okay,
wind and the
WV. What
solar.
is
WV.
Wind
WV?
and the solar we can use as energy resources,
Mr. Johnny
and we
Aritona,
can
what is
energy storage.
WV in your mind?
We can store that energy. I mean, in the form of the batteries. Okay, and in the form of the energy storage devices, and that energy storage devices can be utilized in the
Wind.
form of a
Oh, I see.
battery.
Talking about
We
the
can
wind.
use
Wind is not
that
vehicle.
that's
Yeah.
batteries in our electric vehicles. Electric vehicles means is not the unmanned vehicles. It is like the
Energy
it's not the automatic
resources.
one. Okay,
Yeah.
it's not the unmanned one. Okay, we will just use the batteries. I mean, the same like the petrol and the other fossil fuel based vehicles. We just replace the fossil fuel with the renewable energy resource with the batteries. So less. I mean, we're going towards the carbon emission. I mean, decarbonization, because the fossil fuel is one of the harmful part to generate the carbon. Okay, that's not good for the health. So that's why we are saying that we can use the green energy, and we can say the renewable energy, wind and the solar. Okay, and this wind and the solar we can utilize as energy resource, and then that we can in the form of energy storage, and that energy storage can be the vehicle's batteries, and that batteries we can utilize in the electric vehicles. That was a concept. And the
I
other one
see.
is that he just recycles. He said the other part, will the electric vehicles battery be recycled if it is damaged or unused? Yes, of course. I mean, this is also in the good question that it will be reused. Okay, it will be recycled. Okay, that's why we can say it will be not the harmful for the humans. It will be, of course, it's not like the same as the wind or the solar, because we use some materials which are not good for the health as well. But still, research is underway that we can recycle it, we can utilize it. Okay, and the damage is not the much damage. We are already using the batteries. Okay? We are already using the batteries in our vehicles. We will just use as a fuel, as energy storage batteries.
Okay.
Mm.
The next questions.
Okay, maybe something to confirm from the wind resource. Does it need some kind of what is it requirement that there should be some flow of the wind, or a static wind also applies in this vehicle? Sometimes wind is blowing very fast, sometimes there is no wind. What do you think?
Yes. That's a problem actually. That's a challenge for the wind energy.
I see.
And also the solar energy. This is
Okay,
of course
maybe
a big problem for the
something to
issue of
confirm from
both
the
of the
wind
energy
resource.
resources. But
Does it
that's
need
why
some kind
we are
of
seeing that
what
we
is
can
it requirement
just
that
why my
there
focus
should
was on
be
the energy
some
storage as
flow
well.
of the wind,
I mean,
or
not only the
a
energy
static wind is
resources,
also
also the
applies in
energy
this
storage.
vehicle?
So energy storage means
Sometimes
when
wind
there
is
is a
blowing
maximum
very
wind. I
fast,
mean, when
sometimes there is no wind.
we have in the
What do you
term
think?
the MPP, maximum power point tracking. Okay, so that one we can when there's a maximum wind, we can extract and we can generate the energy by utilizing the wind power, wind turbines, and then we can store it in the DC form in the batteries. That one. And the same as for the solar, that we can have the energy storage. Okay, and then that energy storage we can utilize as a form of the batteries, or we can utilize it.
Well, okay, I hope it is clear for Mr. Johnny Archonang and for us. Thank you very much, Mr. Johnny Archonang, for the question. Now we're coming to somebody else. We have Ms. Florence Agnes. Okay, the question is, what is the shortage and advantage of such technologies? Maybe besides the damage or besides the, what is it, the low competency? Yes.
Yes, actually, that of course all the technologies we know that all the researchers, the scientists,
I hope it
the
is clear
students
for
already were studying
Mr.
about
Johnny
it.
Archonang and for
That's
us.
all the
Thank you very much,
technologies. They
Mr.
have
Johnny
some
Archonang, for the
shortcomings or
question. Now
the
we're coming to
disadvantages
somebody
as well.
else.
We also
Miss
have
Florence Agnes.
some
Okay, the question is, what is the shortage and advantage
surely we
of
have.
such
I mean,
technologies?
there's a
maybe besides the damage or besides
there are
the, what
many
is it,
like
the
many of
low
the
competency?
shortage
Yes.
as well. But the problem is this when we compare the efficiency actually, because when we adopt any technology, we can adopt it on the base of the efficiency, and we can compare with the previous technology as well, I mean the previous resources as well. So when we get these technologies, we can say the wind, solar, and we compare with the energy storage devices, electric vehicles. I mean, this was my keyword for my speech. So we compare with the conventional system, the conventional, the fossil fuel based system. So efficiency is somehow we can say it is better if we say about talk about the fossil fuel based, but the disadvantages of the fossil fuel, that is more than that the renewable energy technologies. So when we compare it, so we can say that is the better technologies, okay, especially when we talk about on the our root or the basis on the human life or the that's why humans like the betterment of the health. So that's why we can say that the new technologies such as the wind and the solar, they are actually this is from the nature as well. Okay, it's more easy than I think we can say from that one, from the fossil fuel based technologies. We can easily install and we can easily like anywhere. Okay, that's mostly like there's a place for the wind and the solar. We can install it and we can extract the energy from them, and in the form of the energy storage we can utilize it. So that's why we can say that there are shortcomings, but still the research is on the way. And electric vehicles in the same way, there are also, of course, as I told you, that one of the disadvantages is this one. That's a long charging time. That is one of the disadvantage. Okay, and we can also say that's less, we can say the distance of the traveling, we can say the 200 or 300 kilometers. Within cities is possible, but if we have a like long distance, then of course it's not possible. We still have to utilize it, the other source of energy. But still we can say these days, if we look around that in many countries, we have some others as well. That's we can say electric traction. Okay, that we are utilizing in the fast speed rail trains. We are utilizing these batteries.
Okay, Dr. Nazir, thank you very much. There is one very interesting question here. This is also due to some event about the flood. Can we drive and charge the electric vehicle even if we get caught in the flood? So what is our solution when we get caught in the flood and then the car or the vehicle is caught in the flood and then we are not going anywhere?
Rail trains, we are utilizing these batteries.
You mean the flood, right?
Okay, yes, Dr. Nazir. We are caught in the middle of the flood. There is one very
flood. I mean the river, right? The flood, water.
Yeah, the flood on the street event because of the flood. Can we drive and charge the electric vehicle even if we get caught in the
yes,
flood?
actually, like so all these technologies, they are in this sense because we are talking about the natural disaster, something like that. I mean, the flood is a disaster, kind of a disaster. So on the disaster, we have some safety measures for these electrical vehicles.
Right? Yes.
That
we are caught in the middle of
many of these we can utilize the new technologies, the covering for that one. I mean the electric vehicle is the same as other vehicles. I mean there's not such much difference. The difference is only is a better way that we can utilize the green the clean technology. Okay, only is that other is almost the same. I mean there's not such much difference in the flood. I mean the same like the other vehicles. What they will face the problem in the flood. So the same, the electric vehicles that it will face the problem as well. I think.
Okay, that's not the problem in it, Dr. Nazir. Not the problem happening due to this electric vehicle. Suppose there is a situation like this. A situation like this. Many people say electric vehicles will be used mass in the future to replace fossil fuel.
Not such much difference in the flood. I mean, the same like the other vehicles, what they will face the problem in the
We out.
Yes. So the same the electric
Yes,
vehicles.
I can hear. Okay. To replace the fossil fuels. Okay. Of course, the fossil fuels industries will be due to this electric vehicle. Disrupted. Suppose there is a situation like this. And then many people say electric vehicles will be used mass in the future to replace fossil fuel.
I can hear you. You can continue, please.
Okay, but the question is lost. Wait a minute, please. We out. Yeah.
Yes. Okay. Yes. I can hear.
Okay. To replace what will be happening if the petroleum industries are also disrupted and they cannot produce fossil fuels and then will be collapsing and will be disrupted. Everything is depending on the new energy. And you know that the petroleum industry is also massively used for any other business, any other enterprises for also making some other energy. What do you think?
Yeah. Yes, very right, and the interesting.
Okay, what will be happening if the petroleum industries are also disrupted and they cannot produce fossil fuels
and the fossil fuel-based the technologies?
Everything is depending on the new energy.
As a researcher, as a
and you know that the petroleum industries
energy
also
technologies,
massively used for any other business,
this is not like some big problem for the fossil fuel-based that one. We still have that one.
What do you think?
And they can utilize the new technologies. Yes, very right. I mean, the researchers who are doing the research in that field, if they can reduce the impact, the pollution impact or the environmental impact of that petroleum, like the fossil fuel-based energy, so of course, then it can be worked together. Okay, it can be still they are working together because it is not easy to replace the fossil fuel-based because it also have the many good advantages of the fossil fuel-based energy sources. So we are not like that they are just going to replace the 100%. Of course not. It is not possible actually, and actually practically. I mean, the answer is very it's not possible.
Yeah,
they can also adopt that technologies. I mean, the fossil fuel-based technologies, energy generation sector. They can also adopt some of the new approaches, new techniques to reduce the pollution, to reduce the environmental impact. So in that way, they can be like the friendly, like both can work together. So we are not like that. They are just.
So we are talking about composite shares, not the domination, not the dominance of particular energy, but we are contributing to the share, right? This is also probably also influenced by the world politics. For example, if the fuel dominates, I think the other resources also not very happy. If this new renewable energy dominates something, the former dominating energy is not very happy. There should be some kind of balance on the share or something. Shares, not the domination, not the dominance
actually,
of particular
as said,
energy,
it is right. I mean, some politics is also involved. Like
this
some
is
countries
also
like
probably
rich in
also influenced by the world
energy
politics.
sources.
For example,
which are rich in the energy resources. I mean, the fossil fuel-based energy resources.
Not
so
very
of course
happy.
they have something to do. I mean, they are maybe still doing something like they don't like to replace their energy, or they are not like thinking in that way, the way which the other side or the renewable energy the researchers are thinking. I mean, they have also they can do the. But as I said, actually the important point for both of the technologies is that because both are from the nature, and they can adopt the technologies. Okay, they can reduce I will be on the same point that they can reduce the impact of the polluted impact of the environmental impact actually. So then it can be balanced. It can be balanced. Politics is involved until it is the neutral way. If we think only about the humans of the human's life and the betterment of to the better way of the utilization of the energy sources, then of course there will be no conflict. But if some government or the politicians is involved, then of course then it will be a mess.
Yeah.
So that's yes.
Okay, Dr. Nasir. It seems that you are what is it, getting so many questioners here. But one more question to close this session. Well, you are very favorite here. Okay, we're talking about the electric vehicle. Okay, let's say electric car. Do you think they can overheat? And what will you do if overheating happens? Is it able to overheat the electric car? Practically and also scientifically. It seems that you are. What do you think? You are what is it? Getting
Actually,
so many questioners here. But one more
the thermal
question.
engineer, I mean
To
the
close
other
this session.
mechanical
Well, you
engineer,
are
he
very
can give the
favorite
better
here.
answer for this one.
Okay,
But
we're
according
talking
to
about
my
the
research,
electric
our
vehicles.
research,
Okay,
I would
let's
like
say
to say
electric
that
cars.
because our
Do you
focus is
think
only on
they
to
can
enhance
overheat?
or to increase
And what will you do if
the betterment
overheating
of
happens?
to adopt the renewable energy
Is
technologies.
it able
So
to
of course there
overheat
will be a
the
heat,
electric
we can say the
cars?
problem, overheating.
Practically
But
and
that's
also
much not will
scientifically.
be the that will be a
What do you think?
we can say that it will be a very difficult situation to handle it. We have
Oh, I see.
we can say the radiators, or we can say the like the in the we can utilize in the motors we can use the some kind of the materials which can reduce,
I
like
see.
same way we utilize in the transformer, like we can use from the oil tank to reduce to cool down of that one for the transformer the operation. Okay, in the same way we have some approaches or some techniques in the electric vehicles to reduce the heating
Oh, I see.
problem or something like that.
Maybe the electric cars is already rampant everywhere. Most people use the electric cars, and then overheating happens. So overheating will be some kind of new research on this kind of issue. You think so?
Might be. Yes, might be.
So this is your homework. What will happen if overheating happens in the future? Something like that.
Yes, it is something like that.
Okay, thank you very much, Dr.
Maybe
Nasir.
the electric cars
kind of
there is
very
already
great
rampant everywhere. Most people use the electric cars, and then
of the
overheating
audience
happens.
asking
So
questions, but
overheating
our time is
will
limited.
be some kind of
Well,
new
we
research on
appreciate your being here. We appreciate
this
your
kind of
thoughts
issue. You
shared
think
to
so?
us together to the world of the technology,
So this is
information
your
technology.
homework.
We would like to
What will
appreciate
happen
this
if
very much. We thank you
overheating
very much.
happens
We
in the
hope to
future?
see you
Something
again.
like that.
We hope to look forward to your
Okay.
well,
Thank
more
you very much,
researches in
Dr.
the
Nasir.
future.
There has been some
And
kind
coming
of
back
very
to
great presentation as well as
University.
discussions, and there are more.
Promise us.
Thank you.
Promise us.
The audience asking questions.
Sure.
but our time
Okay.
is
Inshallah.
well, we
Yes,
We will
appreciate
wait
your
for
being
you,
here. We
sir.
appreciate
Okay,
your
ladies and
thoughts
gentlemen.
to us
Yeah,
together.
still my
to the
email is
world
there.
of
I mean, if
the
some more questions, you
technology,
can send me by
information
email. I would like to be, I would be happy
we
that
would
to
like
answer
to
after all
appreciate
the
this very
questions.
much.
Well, thank you very
We
much.
hope to
Before
see
we
you
closing the
again.
session,
We hope
you
to
could
look
please give
forward
some
to
kind
your
of concluding remark,
more
concluding
researches in the
statement of
future,
your
and
expertise
coming
here.
back to
Sure.
Mantara
I would.
University.
I will share with yes.
Promise us.
Yes. Thank you.
Okay.
Like for this all
We are
this
waiting for
invitation,
you,
and that's
sir.
such a nice
Okay, ladies and gentlemen.
conference, and congratulations for this one. And hope to see you like meet you soon.
Okay, thank you very
Well,
much.
thank you very
Ladies
much.
and
Before we
gentlemen,
closing the session,
let's close this
some
session.
kind of
Give
concluding
him
remark,
a very
concluding
big
statement
hand.
of your expertise here.
Sure. I will share with yes.
Thank you very much. Well, this is half of the day of this conference, ladies and gentlemen. I hope you still staying to the end of this program. I hope you still attentive. Or you can drink something or have something at your own
Okay,
respective
thank you very
home.
much. Well,
Okay,
ladies
now
and
we're
gentlemen,
coming
let's close
to
this
the
session.
third presenter
Give
of
him
the
a
day
very big
in
hand.
this Isemantic. This is also, we are coming to a very noted professor.
Thank you very much.
From
well,
Indonesia.
This is half of the
from
day
Indonesia.
of this conference.
We would like to greet
I hope you still
first
staying to
Professor
the end of this program. I hope you still attentive.
Good morning, Professor. Are you here?
Drink
Yes, good
something,
morning.
have something
Yep,
at your
thank you.
own respective home.
Wow, thank you very much.
Now we coming
You look great
nearly
today. How are
to
you?
the third presenter
Fine,
of the
thanks.
day.
Alhamdulillah.
In this
How is Surabaya, Professor?
Isemantic.
It's quite hot right now.
This is also we're
Yeah.
coming to a very noted
Usually
professor
after the heat,
from
there will be the rain.
Indonesia. From
Yeah,
Indonesia.
yeah.
We
Thank
would
you very
like
much.
to
Thank you very
greet
much. Before your
first
presentation,
Professor
we would like to say
Gamantio
something. Professor
Hindratoro.
Gamantio Hindratoro
Good morning,
is an
Professor. Are you here
expert
with us today?
in wireless communication and radio wave propagation.
Thank you very much.
From
You look great
Institute
today. How are you?
Technology
Fine,
10
thanks.
November,
Okay. How is
Surabaya,
Professor?
Indonesia.
It's quite
Before the
hot right now.
presentation, we'd like to show you,
Usually
to present to you some introduction
heat,
about
there
our
will be the
Professor
rain.
Gamantio here.
Yeah,
Miss Titin, please.
Okay.
Thank you very much. Thank you
Professor
very much.
Insinyur
Before your
Gamantio
presentation, we would like to say
Hendrantoro,
something.
Master
Professor
Engineering and
Gamantio
PhD from
Hendrantoro
Institut Teknologi
is an
10
expert
November,
in
Surabaya.
wireless communication and
Received
radio
bachelor
wave
degree in
propagation
electric
from
engineering from Institut Teknologi 10 November, Surabaya.
10
Kemudian,
November,
and then Master of
Surabaya,
Engineering in
Indonesia.
Electrical Engineering
Before the
and PhD in
presentation, we'd
Carleton
like
University.
to show you,
Besides
to
being
present
lecturer
to you
at
some
Institut
introduction
Teknologi
about our
10 November,
Professor Gamantio
Surabaya,
here.
he has many
Miss Titin,
achievements,
please.
such as won the Young Scientist Award from the International Union of Radio Science in 2005. In the same year, he won the third Best Outstanding Lecturer at the national level from the Ministry of National Education. Currently, Mr. Gamantio is the IEEE Indonesia Section Vice Chairman.
Electrical
Engineering research interests are radio wave propagation, multi-antenna communication, and radar array processing.
He has many
Well,
achievements such as
that's
won the
another
Young
wow
Scientist Award from
achievement,
the
Professor
International
Gamantio.
Union
Well,
of Radio
we
Science
will
in
not be able to
2005.
be there.
In the same year, he won the
That is
third
very
Best
high.
Outstanding
Okay,
Lecturer
Professor
at the
Gamantio,
national level
now
from
coming
the
to your
Ministry of
presentation,
National
please
Education.
make it convenient
Currently,
for 40
Mr.
minutes.
Gamantio
3 minutes.
is the
Thank you very much.
IEEE
It will
Indonesia
start from
Section
now.
Vice Chairman.
Okay,
Please.
thank you. I would like to share
Research
my
interests
presentation.
are radio wave propagation, multi-antenna communication,
Okay,
and
can
radar
anyone
array
see it?
processing.
Yes.
Yes, sir, clearly.
Well,
Very clear.
Okay,
that's
thank you.
another wow achievement, Professor Gamantio. Well,
Okay,
we will
good
not
morning, good
be
evening.
able to be there.
Good
That is very
afternoon
high.
for everyone.
Okay,
Because
Professor
I don't know
Gamantio,
where
now
you
coming
come
to your
from. Yeah, so
presentation,
probably you
please
come
make
from
it convenient
probably all
for
over the
40
world.
minutes.
So I would like to start
Thank you
my
very much. It
presentation.
will start from now.
Earlier,
Please.
I think
Thank you. I would like to share my
we just talked a little bit
presentation.
about rain. Yeah, after the heat, we will have rain.
Okay, can
Now
anyone see it?
we would see if
Okay, thank you.
rain events. What I would like to call rain
Okay,
events in
good
Indonesia
morning, good
could
evening,
have an impact on
good afternoon
millimeter
for
wave
everyone,
propagation. Yeah.
because I don't
So
know where you come from. Yeah, so
my
probably you come
title
from
today
probably
for
all
my
over the
talk
world.
today
So I would like to start my presentation. Earlier, I think
studies on
we just
millimeter
talked
wave
a little bit
propagation
about
in the
rain. Yeah,
tropics
after the
and
heat,
current
we will
research
have rain.
potentials. So
Now
I prepared this talk
we would
just
see if
for
rain
the audience
events,
of the Isemantic.
what I would like to call rain events in Indonesia
Let me
could
change
have
the pointer.
an impact on
Yep.
millimeter
Okay.
wave propagation.
Continue.
Yeah. So my title today.
Okay, so I will
for
talk
my
about the
talk today
motivation of this talk, and then how the millimeter wave
studies
tropical
on millimeter wave
rain-induced
propagation
attenuation
in the
modeling
tropics
attempts have been
and
done
current
at
research
ITS
potentials. So
in my
I
university.
prepared this talk
And
just
then this will include
for
distribution of
the
rain rate and
audience of
millimeter
the
wave
Isemantic.
attenuation, space-time variation of rain attenuation. And then we will talk about how to mitigate
Okay.
the attenuation impact of the rain on millimeter wave radio
Okay, so I will talk
propagation.
about the
And that
motivation of
includes
this talk, and then
two families of
how the millimeter
methods. The
wave
first one is adaptive
tropical
transmission, and the other
rain-induced
one is
attenuation
joint
modeling attempts
optimization
have
of
been done at ITS in my
radio
university.
resources. And then after that,
this
we will arrive at the
will include
conclusions, and I
distribution
will
of rain
also
rate
give
and
some
millimeter wave
current issues that we still have to
space-time
solve.
variation of rain attenuation.
Okay, so
and then we will
as
talk about
the
how to
motivation,
mitigate
in the past,
attenuation impact
there were already
of
some
the
efforts,
rain on
such as
millimeter
the
wave
earlier version of
radio propagation, and that
802.16. So
includes
we know
two families of methods. The
802.16
first one is adaptive
by the name of
transmission, and the other one
WiMAX.
is joint
And
optimization of
actually at that time, WiMAX
radio resources.
was designed to use
and then after that we
frequencies
will
below
arrive at the
10
conclusions,
gigahertz, so
and I
there would be
will
no
also give some
impact,
current
no
issues that we
significant
still have
impact
to
by rain.
solve.
But in the
Okay,
earlier
so
version,
as
actually,
the motivation,
there were some
in the past,
proposals to use
there were
higher
already some
frequencies,
efforts,
more than
such as the earlier
10
version of
gigahertz. Also, in
in
the past, we have
2016. So
a
we
system
know
called YPAS from Japan, and also LMDS
by the
from
name of
Europe, and I think also
WiMAX,
from Canada,
and actually,
which
actually at that time
were
WiMAX
designed to use
was
millimeter
designed
wave
to
as
use
carriers for
frequencies
high
below
capacity
10
access
gigahertz,
links.
so there would be no
Right
impact,
now,
no
5G
significant
is under
impact by rain.
deployment in Indonesia,
But
and
in
millimeter
the
wave
earlier version,
is one
actually,
of the
there were
carrier
some
wave frequencies to be used
proposals to
for
use higher
high
frequencies, more
capacity
than
access
10
and backhaul
gigahertz.
links.
Also, in the past,
And
we have a system called
actually, millimeter
YPAS
waves are
from
expected to be
Japan, and
one of the
also
game changers,
LMDS
because
from
using
Europe, and I
millimeter
think
waves,
also from
we
Canada,
could have a very high capacity,
which
because there are there's
designed to
a
use millimeter
very
waves
large
as
bandwidth
carriers
available, yeah,
for high
in
capacity
that
access
band.
links.
So probably I haven't
Right now,
mentioned anywhere
5G
here.
is under
So
deployment
millimeter
in
wave
Indonesia,
is
and millimeter
usually
wave is one of
used. The term
carrier
is
wave
usually used
frequencies to be used
to
for
refer to the
high capacity
frequencies
access and
around
backhaul
20
links.
to
And
probably 40 gigahertz. Yeah.
actually,
So
millimeter waves are
those are the
expected to be one
frequencies
of the
that
game
are
changers,
commonly
because
referred
using
to.
millimeter
Although
waves,
lately
we could
people
have
are
very
also
high
looking at
capacity, because
60
there are
gigahertz
there's
and
a
80 gigahertz. Yeah.
very large
So
bandwidth
those
available,
are the
in that
millimeter waves
band.
that
So
we are going to talk
probably I
about,
haven't
especially
mentioned
around the
anywhere here.
30
So
gigahertz.
millimeter wave is
And then,
usually
while 5G
used.
is still under
The term is
deployment,
usually
people
used
are already
to
looking at
refer
6G,
to
yeah, sixth generation of
frequencies around
communications, and
20 to probably 40
6G is
gigahertz.
also
So
envisioned to use
that's those are
new
the
frequency
frequencies
carriers,
that
such
are
as
commonly referred to.
the visible
Although
light
lately
and a
people
terahertz
are also
wave,
looking
and
at 60
these are being
gigahertz
studied.
and 80 gigahertz.
On the other
So
hand,
those
if we are
are
looking at
the millimeter waves that we
the
are going to
climate,
talk
yeah,
about,
the climate in
especially around
Indonesia,
the
just
30 gigahertz.
as
And then,
has been mentioned
while 5G is still under
our
deployment,
moderator,
people are already
we
looking at
have of course we have
6G,
fog,
sixth
especially in the
generation of
mountains,
communications,
but
and
especially we have
6G
tropical
is
rain,
also
very heavy rain
envisioned to
sometimes, yeah,
use
and
new frequency carriers such
there
as
was already some
the visible light
experiment, yeah,
and a terahertz wave, and these
employing
are being studied.
28 gigahertz
On the other
radio
hand,
waves in
if we are
Surabaya
looking at
along a radio link of
the climate,
5.7
the
kilometer
climate in
length,
Indonesia,
and
just
the
as
attenuation could be as high as
has
80
been
dB
mentioned by
due to the rain only. Yeah,
our
due to
moderator,
the rain only. So
we have
it is
of course we
quite
have
a,
fog, especially in the
high
mountains, on the
value, yeah,
mountains,
for
but
attenuation,
especially we
and
have
which means
tropical
that
rain,
if
very
we
heavy
want
rain
to make
sometimes,
sure
yeah.
that the
And
the link,
there was
the
already some
communication link, the
experiment,
radio link could work well,
employing
that
28
means we have
gigahertz
to
radio waves
provide
in
very
Surabaya
large
along a radio link
transmit
of
power, for example, yeah,
5.7
very large
kilometer
power
length,
margin in the
and
link budget,
the attenuation
and
could
that
be
would
as high
be
as 80 dB
very
due to the
expensive.
rain
Yeah?
only. Yeah,
So
due to
that's
the rain
the
only. So
motivation.
it is quite a high
Here we
value,
would
yeah,
see
for
the impact of
attenuation,
tropical rain on
and
radio wave
which means
propagation
that
at
if we
millimeter
want
wave
to make
10
sure
and
that
beyond, and beyond means
the
even
link, the
higher
communication
frequencies.
link, the
That
radio
needs to
link
be
could
investigated,
work
and this
well.
includes
That
several
means we
things here.
have
The short-term
to
and yearly
provide
variations,
very
yeah,
large
mean that
transmit power,
rain
for
rate and
example,
attenuation
very
should be
large
well
power
modeled
margin
statistically,
in
yeah,
the link
because
budget,
rain
and that will be
is also varying with
very
time and also with
expensive.
space. Yeah. So there should
That's
be
the
some modeling,
motivation.
which probably later on can be used
Here
to
we will see
devise
the impact of
a technique,
tropical
yeah,
rain
to
on radio
mitigate
wave
any
propagation at millimeter wave
destructive
band and
impact
beyond.
of rain
And beyond
attenuation,
means even
especially
higher
in the tropical
frequencies.
regions. Yeah.
That needs to be investigated.
So this is
And this
just an
includes several
accompanying
things here. The
image,
short-term and
but I
yearly
would like to
variations,
show
yeah,
that
mean that
actually
rain rate
Indonesia,
and attenuation should be well modeled statistically, yeah,
especially the
because
Ministry of
rain
Communications and
is also
Informatics,
varying with
have
time and also
planned
with
to
space.
use
So there should be
26
some modeling,
gigahertz, yeah, for
which probably
a
later on can
carrier
be used to
frequency, yeah,
devise a technique, yeah,
in
to
the band that
mitigate
they
any
call high band, yeah, to provide
destructive
100
impact of rain
megabit per
attenuation.
second user
capture data rate
especially
with
in the tropical
very low
regions.
latency, only 1 millisecond.
So
And this is
just
called
an
super data layer.
accompanying
Yeah, so
image, but I
that
would like
means
to
we
show
really have
that
to look at the impact
actually
of rain
Indonesia,
on millimeter wave, because otherwise we don't know
especially
the
the
impact
Ministry
of
of
rain,
Communications and
and then
Informatics,
probably the
have
rain will
planned to
destroy
use 26 gigahertz
the performance, the
carrier
performance of the
frequency
radio link at
in the
26
band that
gigahertz
they
that will
call
be
high
used
band,
in
to
Indonesia.
provide 100
So this is
megabit per
a kind
second
of
user data
history
rate with
of research
very low
on
latency,
millimeter wave
only one
rain
millisecond.
attenuation that we
And
have
this
done
is
in
called super
ITS.
data layer. Yeah, so
About
that means we really have
30
to
years
look at
ago,
the
30
impact
years
of
ago,
rain
I was
on millimeter
still
wave, because
a student at
otherwise we
that
don't
time
know the impact of rain,
in ITS.
and then probably the rain
There
will
was a
destroy
simultaneous measurement of rain attenuation. At that time, it's
the performance, the
the
performance of the radio
frequency
link at
under
26 gigahertz that will be used in
observation is
Indonesia.
in the KU band,
So this
which
is
is
a
around
kind of
11 or
history
12
of
gigahertz,
research on
still
millimeter
way
wave
beyond
rain
sorry,
attenuation that
below
we have done in
the millimeter wave
ITS.
actually,
Yeah,
and also
about
measurement of rain rate
30
on
years ago.
satellite to
Yeah, 30
ground
years ago, I was still
channels. And
a student at that
this
time
was collaboration
in
between
ITS.
Eindhoven
There
University
was
of
a
Technology, ITS,
simultaneous
and
measurement
Intelsat,
of rain attenuation.
and
At that time,
I
it's
think one of the most relevant
the
results of this
frequency
research with the millimeter wave
observation
problem is
is
the 3
in
years measurement
KU
of
band,
rainfall rate.
which is around
So
11
in
or 12
that
gigahertz,
means we
still way
could have
beyond, below
quite
the millimeter wave
accurate
actually, and also
rainfall rate
measurement of
distribution,
rain rate
which can be
on
used
satellite
later
to
on
ground
modeling the
channels.
millimeter
And
wave
this was
attenuation.
collaboration between
In 1999,
Eindhoven University of
there was
Technology,
another
ITS, and
project,
Intelsat,
a measurement project
I
for
think
rain
one of the
attenuation at
most
30
relevant results of
gigahertz on a
this
terrestrial link,
research
which was
with
also a collaboration
millimeter
between
wave
ITS
problem is the
and
3 years measurement of
TU
rainfall
Eindhoven.
rate. So
But at that time,
that means
we
we
also
could
worked
have
together with Indosat, and then
quite
there was
accurate
an initial
rainfall
indication
rate
of
distribution,
the
which can
significance, the
be used
severity
later
of
on modeling the
rain attenuation
millimeter
at millimeter wave band that we
attenuation.
cannot ignore. Yeah.
In
And
1999,
later
there
on,
was another
around
project,
2006
a measurement project
2012,
for rain attenuation at
we also
30
did
gigahertz
some
on a
measurement and
terrestrial
modeling of
link,
space-time
which
variation
was
of
also
rain
a
attenuation
collaboration
at
between
30
ITS
gigahertz. Yeah?
and
From
TU
that
But at
project,
that time, we also
we
worked
obtained
together
some
with
rain
Indosat.
rate distribution. In
There was
addition
an
to
initial
the ones that we
indication
already
of
get from
the
1990s,
significance, the severity
and
of
then also temporal and
rain
spatial
attenuation at millimeter wave band
correlation,
that we
which can be
cannot
used
ignore.
later to
And later on,
devise a space-time model for
around 2006
rain
to
attenuation.
2012,
And right now we are
we also
planning
did some
to
measurement and
restart
modeling
again
of
some
space-time variation of rain attenuation at 30
investigation on
gigahertz.
the impact
And
of rain on millimeter wave
from that
propagation,
project,
especially with
we
the
obtained
deployment
some
of
rain rate
5G
distribution. So in addition
coming
to
probably
the ones
this and
that
the
we
coming
already
years.
get
Yeah.
from
So
1990s,
there would be some
and then
other things
also
that we should
temporal
do,
and
and we
spatial
will discuss that later.
correlation, which can be used later
In 1991,
devise a
1993, this
space-time
is the
model
first
for rain
collaboration
attenuation.
between
And
the
right now we
Eindhoven
are
ITS and
planning to restart
using
again some
a satellite from
investigation
owned by
on the
Intelsat.
impact of rain
We
on
have
millimeter wave propagation, especially
measurement
with
system over here
the
that
deployment
includes
of 5G
a beacon receiver from
coming probably this and the coming
to
years.
receive
Yeah?
signals
So
from the
there
beacon
would be
signals
some
from the
other things
Intelsat
that we should
satellite.
do,
And
and
we
we will
also have
discuss
a
that
radio
later.
meter to measure the
I think
noise,
in
the sky
1991,
noise,
1993, this is
and
the
then
first
rain meter
collaboration
to measure
between the
the
Eindhoven
rainfall rate.
ITS
And from that
using a satellite from
measurement,
owned by
we could
Intelsat.
see we could have 3 years measurement of
measurement
rain
system over here
rain rate,
that includes a beacon
which can be read
receiver
here.
from
So, for example, so the
to
3
receive
years
signals
are
from beacon signals from
of
the Intelsat satellite,
comprised of
and we also have a radio meter
1991,
to
1992,
measure
and
the noise,
1993. Yeah.
the
So
sky noise,
if
and then
we
rain meter
see a little bit
measure the rainfall rate.
in detail, yeah,
And
on
from
the
that
rain statistics, we could see that
measurement, we could see we could have
for
3
example,
years measurement of rain rate,
let's say in the third year, yeah,
which can be read here.
the
So
rain
for
rate
example,
could reach
so the 3
181
years are
millimeter per hour, and
constituted
which is
of,
very high, very heavy rain, yeah, very heavy rain. Although this could only happen
1993, yeah? So, if we
0.001%
see
probability in a year. So
in detail, yeah, on
the possibility of this
rain statistics, we
happening
could see that
is very low, but it could happen. And if it happens,
for example,
then the attenuation experienced by
let's
the
say in
millimeter
the
wave
third year, yeah,
could be very high,
the
and
rain rate
then
could reach
probably even the
181
connection could
millimeter
be
per hour,
broken.
which
Yeah?
is very
Even
high,
for a while,
very heavy rain,
it
very
can
heavy rain. Although
decrease
this
the
could only
level of
happen
surface. Yeah, the level of surface from the network operator. Yeah? So
the possibility
also
of
another
this happening is
result
very
from
low,
that
but it could happen.
measure
And
from
if it
these
happens,
measurements
then
is that the ITUR
experienced by the
recommendations
millimeter wave
of
could be very high, and then
rainfall rate distributions
probably even the connection
turn out to
could be
not
broken.
actually in
Even for a
line with
while,
what we have measured
it
in
can
Surabaya.
decrease the
So
level of surface.
the conclusion
The
of
level of
those
surface from
that
the
project is that the distribution of rain
network
rate in
operator.
any region given in the
So,
ITUR recommendation
also
is likely
another
not in agreement with the actual distribution
result
measured
from that
locally. And I would like to
these measurements is that the
to
ITUR
comment that this is actually from the old ITUR recommendation. The later
rainfall rate
recommendations
distributions
are
turn
to
out
not
to be
use
not
the
actually
regions
in
anymore,
line
but
with
they
what
use
we have measured in Surabaya. So
contour diagrams
conclusion
covering
of those that
the
project
whole
is that the distribution of rain
surface
rate
of
in any
the
region
earth,
given
and
in the
those contours
ITUR
give
recommendation
us
is
the
likely not in agreement
rain
with the actual
statistics to be
distribution
used in
measured
prediction
locally.
method
And
that they
I would like
provide. So, but
to comment that
the
this is
essence
actually
of
from
this
the old
finding is
ITUR
that
recommendation. The
what
later
the
recommendations
ITUR presents in the
do not
recommendation
use
is
the
not
regions
necessarily
anymore,
in
but they
line with
use
what actually happens in our own
contour
local
diagrams covering
region. For example, in
the whole
let's say around Surabaya or
surface of
in the
of the
northern
earth,
part
and
or
those contours
east
give us the
northeast part
rain
of,
statistics to
let's
be
say,
used in
of the
prediction
Java
method
island, for example.
that they
Yeah?
provide. Yeah.
So better
So,
statistical model should be developed
but
for each local regions, yeah, for use in millimeter
the
wave
essence of this
communication system
finding is
design. And
that
later on,
what
we
the
could also see
ITUR presents
that
in the
these
recommendation
statistics could be different
is not
from one
necessarily in line
region
with what
to another.
actually happens
Yeah, because
in
for example, okay,
our own local
Surabaya is quite
region,
hot,
for
but
example,
if it rains,
let's say around
it
Surabaya
pours.
or
Yeah, so
in the northern
we could
part
compare this,
or
for example,
east,
to the
northern
area
east,
of
northeast part
in
of,
Nusa Tenggara,
let's say,
perhaps, yeah,
of
in
the
Lombok,
Java
for
Island,
example,
for example. Yeah.
where
So
the
better
climate
statistical
is
model
more
should be
arid, yeah,
developed for
more
each local
dry.
regions, yeah, for
Yeah.
use in millimeter
So
wave
there,
communication system
there
design. And
in
later on,
Lombok, for example,
we could also see
the rain
that
statistic would
these
be different
statistics could be
from what we have
different
in
from one
Surabaya or
region
Jakarta or
to
Semarang.
another.
Yeah. Okay,
Because, for
so
example, okay,
the second project
Surabaya is
is
quite
also another
hot, but
collaboration
if
with
it rains,
Endofan, but now we also
it pours.
collaborated
Yeah?
with
So
Indosat,
we
and
could
the
compare this,
measurement
for
itself
example,
also
to the area of
happens in ITS,
in
and
Nusa
we
Tenggara,
actually
perhaps,
built
in
a
Lombok,
radio
for
link,
example,
28
where the
gigahertz radio
climate is
link
more arid,
between
yeah,
the
more
campus of
dry.
ITS
Yeah? So there,
with
there
the
in
office,
Lombok,
yeah,
for
and the
example,
rooftop of
the
the
rain
office
statistic
building
would be
of
different
Indosat in
from what we
Surabaya,
have in
and the
Surabaya
link
or
actually
Jakarta or
spans about
Semarang. Yeah?
5.9 kilometer.
Okay. So
And
the second project is
from
also
that
another
measurement, from the
collaboration with
measurement that
Endofan, but now we also
we
collaborated
obtained
with
at that
Indosat.
time,
And
the
the
highest
measurement itself
attenuation
also
that was
happens
measured
in ITS, and
could
we
reach up
actually
to
built
80
a
dB,
radio
which
link,
is a very
28
large number. Yeah.
gigahertz radio link between the campus
And
of
then
ITS
the next project is actually the
with
longer one, the longest one
the
probably.
office, yeah,
So
and the rooftop
we
of
would
the
like
office
to
building
see
of Indosat
a
in
small
Surabaya. And
the
the link
variation of the
actually
rain
spans about 5.9 kilometer.
attenuation induced
And
by rain in
from
a
that
smaller area,
measurement, from the
because we
measurement
know that in the
we
future, this is
we
from
obtained at that time,
2006 to
the
2012.
highest
So at that
attenuation
time,
that was
there
measured
was not yet
could reach up to
any
80 dB, which is a very large number. Yeah.
coordinated effort to develop 5G.
And then
Yeah,
the
but
next
at that
project
time,
is actually the
we
longer
already
one,
had a
the
vision
longest
that
one probably. So
in the future we would have
we would like
millimeter
to
wave
see the
communications
small
in
the
which
variation of the rain
the cell size,
attenuation induced by
the
rain
cell size, the
in a
network cell
smaller
size
area,
would be
because
very
we know
small.
that
Yeah?
in the future,
So here
this is
we
from
have
2006 to
installed
2012. So at that time,
a number of rain
there
gauges,
is not,
yeah,
there was not yet
in the campus of
any
ITS. Yeah. So we have a simultaneous
coordinated
measurement using
effort to
a
develop
distrometer,
5G.
which can be used
Yeah,
to
but at that time we already had a vision that
measure the
in the
rain
future
rate
we would have
using
millimeter wave communications
an apparatus that
in which
has a laser
the cell
transmitter and
size,
a detector. Yeah.
the
And
cell
then we
size, the
have
network cell
we
size
had a
would
set
be
of
very
rain
small. Yeah?
gauges, and
So
also
here
we had
we
a radio link,
installed
29 gigahertz radio link,
a number of rain
spanning
gauges
a distance of 1 kilometer.
in the
So this
campus
is
of
a
ITS. Yeah?
kind
So
of
we have
short
a
distance that that at that time we thought it could represent a small cell, a base station with only 1 kilometer
has a laser
kilometer coverage
transmitter
radius.
and a detector.
So
and then
we obtain
had a set
rainfall rate
of rain
distribution
gauges,
from this
and
measurement.
also we had
Rain attenuation
a
distribution,
radio link,
which
29
we obtained
gigahertz radio
using the
link
technique
spanning
called
a
synthetic
distance of
storm
1
technique,
kilometer. So
SST.
this is a
We could
kind of
also
short
obtain
distance
time
that at
space
that time
variation of rain rate and specific attenuation.
we
Specific
thought
attenuation here is
it
given
could represent
in
a small cell,
dB
a
per
base
kilometer.
station
dB per
with only
kilometer.
1
So
kilometer
it's like the attenuation
coverage,
over a unit
kilometer
of
coverage
distance.
radius.
In this case, 1 kilometer. And this is at
obtained
29
rainfall rate
gigahertz.
distribution from this
These
measurement,
results are
also
important
rain
for the
attenuation
purpose of
distribution,
evaluation
which
of
we obtained
various
using
proposals
the
of
technique
attenuation
called
mitigation
synthetic storm
schemes.
technique,
So
SST.
if we want to make sure that
We could
our
also
mitigation
obtain
scheme,
time-space
our
variation of
schemes
rain rate and
that we
specific
propose
attenuation.
to mitigate the
Specific
effect of
attenuation here is
rain
given
attenuation
in
on millimeter wave, then we have to
per
also
kilometer,
have
dB per kilometer. So it's
a method
like
to simulate
attenuation
the mitigation
over a unit of
schemes
distance. In this
under
case, 1 kilometer.
computer
And this is
generated
at
rain
29
events,
gigahertz.
which
These
should
results
be
are important for the
varying
purpose
not
of
just
evaluation of
with
various
time but also
proposals
with
of
space, with
attenuation
locations.
mitigation schemes. So if we
So
want to
this
make
is the
sure
map.
that
We
our
put
mitigation scheme,
the
our
stars here
schemes
represent
that we propose
the
to
locations of
mitigate
the
the
rain
effect
gauge,
of
and then
rain attenuation
the
on
dashed line
millimeter
here
wave, then
represent
we
the radio
have
link.
to also have
Okay, so the measurement
a
results,
method to
we could see
simulate
that
the
there are two
mitigation
main
schemes,
results. Actually, the rain in
under
Surabaya, just like in Singapore,
computer-generated
tends to
rain
have more
events,
large
which
raindrops,
should
more
be
large
varying
raindrops. So
not
the
just
diameter of
with
the
time, but
raindrops,
also with space, with
tend to
locations.
be
So
larger,
this is the map.
than the
We put
model
the
proposed,
stars here
an old model,
represent
proposed by
the
Marshall and
locations of the
Palmer,
rain gauge, and then
based on their
the
measurements
dashed
in
line here
North America.
represent the
Now we
radio
have
link.
to be careful here because North America
Okay, so the measurement results, we could see that there are two main
different characteristics
results.
of
The rain
rain,
in Surabaya,
because
just like in Singapore,
okay, so North
tends
America
to have
is
more
quite far from the
large
tropical
raindrops,
region,
more
right?
large
It's
raindrops. So the
even
diameter
probably
of
closer to
the
the pole, to
raindrops,
the North Pole, So
tend to be
the rain statistics
larger,
would be
than the
would be lighter,
proposed,
than
an old
what we
model,
have in
proposed by
Indonesia,
Marshall and Palmer,
in tropical
based on their
regions,
measurements in North
So
America.
this means
Now
that
we have to be careful here because North
the
America
model, the rain model, the rain statistics that are
different
actually the
characteristics of
process,
rain,
the method
because
to predict the
okay,
rain
so North America is
rate
quite far
and
from the
attenuation
tropical
used
region, right?
or
It's
proposed for
even
applications
probably
in North
closer
America
to
could
the
be
pole, to the
different
North Pole,
from the
So,
one that should be used in
the
Indonesia,
rain
for example.
statistics
So
would
rain
be,
events in Surabaya
less, would
also
be
show
lighter,
greater
than
temporal
what we have
correlation
in
than those reported
Indonesia,
from
in tropical,
Barcelona, from
regions,
Europe. So here we also see
so this means that
another thing, another important thing that
the rain model, rain
states
statistic
that
that are actually the process, the method to
the time
predict the
varying
rain
rain could have
rate and
in Indonesia
attenuation
could have
used
higher
or
correlation
proposed for
from one
applications in
time
North America
to,
could be
let's say,
different
1 second
from
or
the
1
one that
minute
should be
after,
used in Indonesia, for example.
compared
So
to
rain events in
the
Surabaya also show
rain that
greater
happens
temporal
in
correlation
Europe,
than those
in Barcelona,
reported
for
from
example.
Barcelona,
So
from
these
Europe.
two are
So here we
two
also
different
see
characteristics that we have
another thing, another
for
important
rain,
thing that,
in tropical
states
regions.
that
So more findings. Log normal distribution, which is usually commonly used
in
to model
Indonesia
non-tropical
could have higher
rain attenuation. The
correlation,
highlight here is the
from
non-tropical,
one time to, let's
because
say,
this
1
is
second
proposed
or
by
1 minute after,
researchers in Europe, North
compared
America,
to,
or probably Japan,
the rain that happens
Korea,
in
and so on.
Europe, in
And
Barcelona,
this
for example.
distribution is not suitable for tropical rain
These two are
attenuation.
two different
And later on,
characteristics that we have
actually, this should read
for rain
ARMA, ARMA, and
tropical regions,
ARIMA. There are
So
two
more
models that we
findings,
propose
log normal distribution, which is
to
usually
generate time series
commonly
of
used to model
rain
non-tropical
attenuation on a
rain
short link,
attenuation. The
or
highlight here is
actually
the
on
non-tropical,
multiple short links.
because this is proposed by
And
researchers
I
in
give you
Europe,
some
North America, or
references
probably
here.
Japan,
If you want to
Korea, and
ask
so
more
on.
about this, you can
And
ask me
this
later.
distribution is not
So
suitable for
here
tropical rain
we could see
attenuation.
that even
And later on,
the orientation
actually,
of the
this
links
should read
could
ARMA,
result in
ARMA, and
different distribution of attenuation. Yeah, so it's amazing. The result is
to generate time series of rain attenuation on a short link, or actually
enlightening.
on
Yeah,
multiple
so
short links.
it gives us more knowledge about the characteristics of rain that happens in Indonesia, which could impact the millimeter wave links when those links are going to be built in
even
Indonesia.
the
So the
orientation
mitigation
of the links
schemes that we propose comprises
result in
of
different
two
distribution
families
of
of techniques.
attenuation.
The first one involves
amazing. The
radio
result
access
is
techniques,
so
which include adaptive transmission,
enlightening.
or actually adaptive. Yeah, we call adaptive transmission because not just the power but also the modulation scheme
which could
is also
the
adaptive.
millimeter wave
And then
links,
cell site diversity and cell
when
area
those links
segmentation.
are going to be
And
built in
another
Indonesia.
family of
So the
schemes
mitigation
is
schemes that
joint
we propose
optimization of radio resources. So this is what we
families
propose.
of
Yeah.
techniques.
So
The first one
earlier studies
involves the radio
on cellular
access
configurations with a square cell.
which
So here
include,
we have
adaptive
actually we have
transmission,
4 base station.
or
Yeah.
actually the adaptive,
Each base station is
we call
positioned
adaptive
in the
transmission
corner
because
of
not
this
just the
square.
power
Yeah.
but also the
So
modulation scheme
this
is also
subsquare,
adaptive. And then
the
cell site
smaller
diversity and
square
cell
here
area segmentation.
is
And
normally
another family
belonging
of
to
schemes
this
is
base
joint
station.
optimization
This
of radio resources.
small square
So
here
this is what we
is
propose.
normally
So earlier studies
belonging
on
or
cellular
belonging in the
configurations
coverage
with
area of
square
this
cells.
base
So
station
here
and so on.
we
Yeah.
have
So the
4
problem
base
is that
station,
for example,
each base
if
station is
there is
positioned in the corner
there is
of
a
this
user
square.
here, a user here. Let's say a fixed
This
user, user residing in a
smaller
home,
square here
and that he
is,
has an
normally
equipment
belonging
for
to this
communicating with the base stations.
This
So if there is
small square here
a user here, and
is
then
normally
he will be
belonging or
served
belonging
by
in the
this base
coverage
station.
area of this
But then
base
there
station, and
is
so
rain
on.
here. Yeah.
So
Rain
the
is
problem
happening
is
here.
that
Then what should
if,
we do?
okay,
Yeah?
there
What
is,
should we do with this user?
there
Because
is
this
a
user
here, a
is
user here.
having
Let's say a fixed
a risk
user,
of
user
losing the connection. Yeah?
residing in a
So
home, and that he has
so
an equipment
we studied
for
on how to
communicating with
serve
the base
that user
stations. Yeah?
properly. Yeah?
So
So
if there is
the targeted
a
users
user
here are
and then
those located near
normally
the cell
he will
edge. So
be
the people
served
residing here,
by
the
this
users
base station, but then
residing
there
here,
is rain here.
are having
Yeah?
the greatest
Rain is
risk
happening
of
here.
losing the connection
Then
when there is rain.
should
Yeah? So
we
the
do?
targeted
What should we do
performance
with
is
this
the
user?
achievement
Because
of an
this user,
availability. Yeah,
is,
where availability
having
means
a risk of
actually the
losing
percentage
connection.
of time
So,
where the connection is working properly. Yeah, not
we studied
disconnected.
on how to
Yeah.
search that
So
user properly.
the achievement of an availability
targeted
value
users here are
pre-specified
those located
for
near
a
the cell
given
edge.
maximum
So
probability of bit
people
error.
residing
So,
here, the
so
users
the quality, the
residing
quality of
here
the connection
are having the greatest risk of losing
becomes
connection when there is rain.
the
Yeah?
performance
So the targeted
indicator.
performance is
The
the achievement of
becomes
an availability.
the definition or the
where
threshold
availability
for
means
the availability.
actually the
Yeah?
percentage of
If
time
the
where
probability
the
of
connection
bit
is working
error
properly.
is too high, then we say that
So
the channel
the
is
achievement of
or
an
the link
availability
actually
value
is not available, yeah,
pre-specified
because
for a given maximum
there
probability of
are
bit
too
error.
many errors. Yeah,
So the quality of the connection
experienced by this user. So there are
becomes,
several possible methods that can be used.
performance indicator.
That is by
becomes
adaptively
the
adjusting transmit power,
definition
modulation
or the threshold,
level,
for the availability.
or if you want to get
If,
more
the probability of
sophisticated,
bit error
okay, we can
is,
use a channel
too high,
coding scheme
then
that
we
is
say
also
that,
adaptive, or
the
selecting
channel
signal
is,
with the
or
best
the
quality
link
out of the
actually
two hubs,
is not
or even
available,
combination of
because
them. Yeah, combination of
there
these
are, too
four
many
schemes.
errors,
Yeah. So this is
experienced by this user. So there are
the table shows
several possible methods that can
an
be used.
example of how to achieve
that
that.
is
Yeah.
by
So
adaptively
the further
adjusting
effort
transmit
that
power, modulation
we did
level,
already at
or if you
we
want to
proposed
get
already is
more,
to try to
sophisticated,
segment
okay,
the square
we can
area
use
of
a channel coding scheme that is
base
also
station
adaptive,
coverage area,
or
and apply
selecting signal with the
different
best quality
adaptive
out of the
techniques
two
in
hubs,
different segments.
or even
So
combination
we know
of them,
that
combination of
the
these
people who
four
will
schemes, yeah?
have the greatest risk of losing connection is
so
the
this
ones near
table
the
shows,
borders, the cell borders. That
an
means we will
example of
give
how to
the
achieve
most
that, yeah?
sophisticated
the further
scheme
effort
to
that-
those
that,
people, yeah,
we
over
did
there, yeah.
already
So
at-
that
we
why?
proposed
Because
already
they have the
is to
greatest
try
risk.
to
So we
segment
should prioritize them more than the one that is closer to the base station, because the closer a user to the base station, then the rain attenuation that they experience would be not as high as those near the cell borders. Yeah? So here we arrange a table, yeah? And then this is for adaptive modulation. Yeah? Actually, not just the modulation, but also the codes. Yeah, because here we have some channel codes integrated to the transmission system. So if the SNR, the signal to noise power ratio, is too small, then okay, there's no transmission. So in this case, no transmissions means the link is not available. Which is actually bad, yeah. Which is a bad thing, yeah. So that's why we put the signal to noise ratio, the threshold, yeah, the threshold, quite low, yeah, only 1.18 decibel, yeah. Otherwise, the link should be able to be served, yeah. The link should be served by the base station. In order to be served, we apply adaptive modulation here. So for the SNR just above the no transmission situation, so that's why we should use a lower level modulation, for example, and much powerful coding schemes, yeah, for example, and so on. Yeah, so the larger the signal to noise power ratio experienced by the user, we could in order to be served, increase the modulation level. Yeah, for example, here 64 QAM, even probably 256 QAM that are currently also used by the OFDM waveform in 5G. Actually. So this is the scheme in general. And then the area segmentation. Yeah, I already said before that another additional strategy is to divide the coverage area into segments. Yeah? So people, users, in segment number 2 here, in the middle, should be given more sophisticated 5G transmission schemes. Yeah? That includes, for example, in this case, the area segmentation. Yeah, I already said before. Let's say fixed. Additional strategy is to we should go back here. That includes, for example, segments, yeah? This one, so yeah, 16 QM with Rich Solomon codes and combined with convolutional codes and so on. Yeah, but for the sophisticated the people closer to here. Okay, so for example, segment 1 here doesn't need. Segment 1 here is for users closer to the base station. Yeah. So for those in the range of, let's say, 1 kilometer from the base station, what they need is just a fixed 64 QM. Yeah. But for users in the region number 2 here in the middle, they should use adaptive modulation. Yeah, so this one, so here, only the first segment 1 here doesn't need segment 1 here is rows, yeah, in this table. Users closer to the base station. The second family of the technique is by doing a joint optimization of radio resources, and this includes, for example, here in this case, joint subcarrier and power allocation. So with the 5G region number 2 here schemes that are being deployed now, we could actually make use of the subcarrier aggregation table. Feature, yeah, that they have to do this actually. Yeah. So joint optimization can be done, yeah, on both subcarrier and power. So these optimizations are done simultaneously, considering 2 parameters. Yeah? Schemes being deployed. Actually, my student at that time simulated this. Yeah. He started with single cell, radius 2 kilometer with 8,000 subcarriers, only for users for now. And the rain attenuation on each link is generated by synthetic storm technique using the rain rate distribution that we have measured before. These optimizations are done simultaneously. for example, here the cell is pictured here as a circular cell. Yeah, there are four users separated in the angular domain, by some angles. So different angles means probably different rain attenuation, because there is space, the variation in space, of the rain attenuation. The results are these. So several approaches were evaluated. Of course, we have JSPA, joint subcarrier power before, but we also have joint frequency power allocation. The difference is that in JFPA we are playing with or we are playing at the level of subcarriers at the same frequency band, but in JFPA we are playing with different frequency bands, and we compared these two proposed methods with dynamic subcarrier allocation and adaptive power allocation that actually only, let's say, only optimize one parameter. So unlike these last two, which optimize two parameters jointly. The finding is that the JSPA and JFPA are here, showing higher probabilities of high utilization, which also means high availability, compared to the FSA and the SA. So this could be done. I think even in 5G, this also could be applied. So the conclusions of that study is that knowledge of distribution and space-time variation of rain rate and attenuation is very important in developing mitigation schemes of the impact of attenuation on millimeter wave propagation. And there are two different families of methods to mitigate the impact of tropical rain attenuation. And these are adaptive transmission with area segmentation and joint optimization of radio resources. These schemes are potentially realizable with the subcarrier aggregation scheme and also with the software-defined network technology currently used in 5G networks. They should reach 5G networks.
And there are two different families.
I arrived at the probably closing slides. And the current issues. We now have 5G deployment process in Indonesia. Different regions. We know already that different regions have different rainfall rate and attenuation distribution. That means also different power budgets for different regions if we want to deploy 5G networks in those regions. And we also know variations among regions in Indonesia, just as I said before. For example, in rainy Bogor, for example, and other areas with heavy rain rates, they have heavy rain rates, but on the other hand, in Nusa Tenggara Islands, we have arid areas with lighter rain rates. And aside from those two, we also have mountainous areas with orographic type of rain. So this is, I think, another type of rain that comes that happens in mountainous areas, where the cloud is going up to the peak of the mountain and then becomes falling as falling rain, fall as a falling rain. And the statistics could be different. So local rainfall rate distributions are potentially available from local weather offices. So I will have to check this, because
another type of rain
as far as I know, some local weather offices are still using cumulative rain meters, not the rain meters that can measure short time, for example, 1 minute rain rate, for example. So if these are available, then that would be a good opportunity for us to actually prepare some knowledge, and give it to the industries, to the telco industries, to provide them with the correct or the proper power budgets, yeah, for 5G deployment in various areas in Indonesia. Also, space-time time series, yeah, of space-time series, yeah, of rain attenuation can adopt the ARMA or ARIMA, the ARMA and the ARIMA models, or generated using the synthetic storm method that we have already used before. This is probably the last two slides. Yeah, in ITS now we have the 5G Experience Center, which was launched just 2 days ago, yeah, which is a collaboration between ITS, Nokia Indonesia, and Indosat. Yeah, and this is also funded by the industries and as well as the Direka program from the Ministry of Education. And the most important thing is that we already plan to do some experiments, yeah, with millimeter wave transmission for 5G services as a part of this program. Yeah? So this would be a very good opportunity to learn more about the range characteristics with regards to the 5G deployment. Also, beyond 5G, this is also important because, for example, 6G is already looking at visible light communication and terahertz communication. Actually, in fact, we already looked at free space optics and we tried to test, yeah, to evaluate the use of cell site diversity, yeah, to improve the performance of free space optics. Yeah, and this is already from 2012, yeah, so it's quite long ago. So the bottom line, I guess, here is that Indonesian researchers should work together to develop technologies and strategies in mitigating the tropical rain impact on this new carrier wave, so that in the future we could actually maximally use the availability or the presence of millimeter wave radio links that can provide us with a very high capacity for broadband communication. So that's, I think, the last slide. So thank you, terima kasih. Please, moderator and Bu moderator, to continue. Thank you very much.
Okay, thank you very much, Professor Kamantia. Well, mitigating rain impact. This is really mind-intriguing. Something, well, this is something different, mitigating rain impact. Yeah. With the waves, considering the radio waves. So, well, this is something and very, very interesting. We're coming to the session. We still have 15 minutes, Professor. We have somebody here. This is, well, we translate into English from Mr. Noval Raditya. We are talking about the use of 5G rain impact. This is really mind-intriguing. High consumption of battery. This is something different. Is there something the lesson between the use of considering 5G and high battery something and very, very interesting.
Okay, battery lifetime.
We're coming to the session. We still have 15 minutes, Professor. We have somebody here.
Yeah. If you're talking about the user terminals, handphone, for example, with
the use of 5G,
a battery with a limited lifetime, really limited power consumption
of battery,
power
is there something
supply, for example,
relation between
then
the use of
yes,
5G and
if,
that
for example, there is rain and the user terminal is working at millimeter wave, or actually at the time are using millimeter wave link to be able to obtain high capacity
handphone, for example,
information, from let's say from the network, then yes, there will be dilemmas here because okay, for the base station, probably there is no limitation on the power.
For example, there is rain
also,
and
actually,
the user terminal is working at millimeter wave,
limit
or actually at the time are using
power consumption at the base station site.
To be able to
that's why now they are using, for example,
high capacity
multi antenna technologies
information,
in millimeter wave band, for example, in 30 gigahertz, for example, the wavelength is just 1 centimeter, so that the size of an antenna at millimeter wave at 30 gigahertz, for example, is approximately just 1 centimeter, so that they can build an array, an antenna array, with many elements, many elements, but still maintaining a very small size, because the size of the antenna, each antenna element is still very small. With these many elements, they can increase the gain of the antenna, so that they do not need to increase the transmitted power itself. That's from the base station point of view. But now, if we are talking about handphone, for example, or other small terminals, then the power consumption is limited, and we could not put there is a limited space to put antennas with higher gain.
With these many elements, they can increase the gain of the antenna.
We are using laptop. It's probably a little bit different story, but handphone is very small and so on.
But now, if
we could probably put, let's say, probably 10 elements of 10 elements of antennas over there,
then
and that could only increase the power by let's say
we could not
several times,
there is a limited
considering
space
other
to put antennas with higher
things that could
gain,
reduce the efficiency of the transmission.
If probably we are using
that could be done,
it's
but
probably a little bit
if the rain
different
is very heavy,
story, but
sometimes it is
handphone
very
is very small and so on. We could probably
destructive.
put, let's say, probably 10 elements of,
and even if
10
using
elements of antennas over there, and
the
that
higher
could only
gain of
increase the
antenna
power
at the
by,
handphone,
let's say,
we could not overcome the impact of
several
rain
times,
attenuation. Yes, so I think in this case,
things that
the
could reduce the
uplink,
efficiency
the one
of the transmission.
from the handphone to the base station, should use lower band,
but
probably.
if the rain
But
is
we still
very
have to learn more about
sometimes it is very
about this. Probably we could find a strategy, a technique, that has
and
not
even
been
if
thought of
using
before. That could
higher
improve the
gain
situation.
of antenna at the handphone.
So I guess that's
not
my question.
overcome
My answer.
the impact of
So
rain
there is some
yes,
significance.
so I think
and then
in this case,
we were talking about the 5G
the
support.
uplink, the one
Is
from
it really
from the
significant
handphone
to
to the base
the
station should use
network
lower band,
performance,
probably.
especially for the
But we still
for
have to
the
learn more
gamers?
about
For the gamers, they need
this,
they need support by
find a
5G
strategy, a
for
technique,
the networking
that
performance.
has not been
Is
thought
the
of
support
before,
by 5G significant?
improve the situation.
Okay, so we are talking about
So
gamers,
I guess that's
gaming,
my question.
Yeah.
Am I
Okay.
So there is some
I think
significance. And
gaming
we're
will
talking about
benefit
the
from the use of
5G
5G
support.
because
Is it really significant
especially
to
online
the,
gaming, of course, because
network
in gaming,
performance, especially for
the
the
response
gamers,
given by a
for the
player
gamers,
at
they
a
need
location
support by
should
5G
be
for the networking
observed
performance
immediately by another
Is the
player in
support
another
by
location.
5G
But
significant?
in this case, I think the most
so we are talking about gamers,
relevant
gaming,
or the most important
okay,
feature of 5G that
I think,
takes the
gaming
most
will benefit
decisive
from the use of
role
5G,
in this case. It's not the millimeter wave, but
especially online gaming, of course,
the low latency
because in gaming
feature, the low latency feature.
The
So
response given
we
by
know that
a
there
player
are three
at a location,
let's say three
be,
types of applications
observed
offered by 5G,
by
and one of them
player
is
in
the
another location.
ultra reliable
But in
low
this
latency
case,
communication.
I think,
So the low latency, the low delay,
relevant or the most
the low
important
time delay
feature of 5G
is the one that will be
takes
more important for applications like gaming, and
most
also for
decisive role in this
applications
case
like
is not the millimeter wave, but
autonomous
the,
vehicle, for
the
example,
low latency
because the information
feature,
should
the low
be
latency
sent
feature. So
immediately.
we know that there are three
And the
let's say
electric
three
vehicles should also
types of applications,
respond. The autonomous vehicle should
5G,
also
and one of them
respond
is the
immediately.
ultra-reliable low
The response
latency
should be
communication.
immediately
So the low latency, the low delay,
received
the
by
low,
the
time
other
delay,
party, for example.
is the
So in
one
this
that will
case,
be more
those
important
are
for applications
the
like gaming,
features
and also for
that
applications
are
like
important for
autonomous vehicle,
the autonomous vehicle, and also for
the
the
information
gamers.
should be sent immediately.
Thank you very much. Thank you,
and the
Mr. Noval
electric
Raditya Tama,
vehicle
for the
should
question. Now
also
we coming to somebody
respond
else.
the autonomous vehicle should also
again Johnny
respond
Aritonang from the
immediately.
study of
The
millimeter
response
wave
should be
propagation in the
immediately
topics by the speaker.
received
What theories
by
are the
the
references?
other party.
Can these
Yeah,
waves
so in this
predict
case,
rain in a
those
tropical
are
area?
the
What
features
about non-tropical areas?
that
Thank you.
are important
Okay, so
for
okay, thank you, Pak.
the autonomous vehicle and also for
Okay, so the purpose
gamers.
of the study of course is not
Thank
to
you very much.
predict
Thank you,
if
Mr. Novel
rain would happen.
Radidiatama for
No,
the
yeah,
question. Now we're
no.
coming to somebody else.
But what we
This
would
is
like to do is
again
actually
Johnny
to
Aritonang from the
mitigate
study
if
of
the rain
millimeter wave
has
propagation
already
in the
been
topics
happening
by
now.
the
It's
speaker.
happening now. Yeah,
What theories
we would
are the
like to
references? Can this
propose a
wave
mitigation
predict
technique.
rain in a
Yeah,
tropical
to
area?
propose a
What
technique to
about
mitigate
non-tropical
or
areas?
actually to
Thank you.
reduce the
Okay,
impact
so
of
okay, thank you,
the
Pak.
attenuation. Yeah,
Okay, so the purpose of
induced
the study
or
of
created
course is not to
by the
predict
rain. Yeah,
if
so
rain would
we are
happen.
not
No,
going
yeah,
to
no.
predict rain or something
But what
like
we would
that.
like
Yeah,
to do
and
is actually
you're
to
asking about the theories.
mitigate
Okay,
if
actually,
the rain
this the study
has
itself.
already been happening. Now it's
There are
happening now.
several
Yeah,
studies
we would
that
like to
I actually had done in the
propose a
past.
mitigation technique.
For
Yeah,
example,
to propose a technique to
you could
mitigate or
look at my papers, perhaps. Although I didn't list it in as list my papers
induced or,
as
created
references
by
here. There is one paper talking about how, actually two papers perhaps, yeah, talking about how the raindrops, the falling raindrops, could affect the electromagnetic wave that comes into the space, the 3D volume, the volume space, yeah, that have falling raindrops in it, yeah. So there are some mathematical derivation using computational electromagnetics, actually not done by me but by my colleagues, yeah, that says that like if the electromagnetic wave at the very high frequencies with wavelength in the order of the size of the raindrops, then there would be some energies that will be scattered, yeah. Some are scattered to another direction, for example, but there will also be some energy that is scattered on the same direction, yeah. And this scattered wave on the same direction, we should call it forward scattering, will be received with lower power by a receiver, for example, yeah. So probably you're also asking about non-tropical areas. In fact, I also did my doctoral study studying about the millimeter wave attenuation in North America. So I already did that, and you might expect that the significance of rain attenuation there is not as high as what we will have here in Indonesia. So I think that's my answer and my comment.
Okay, thank you very much, Professor. Now we have something else about myth or fact.
Oh, okay.
This is about myth or fact. Is it true that the 5G network is not optimal to penetrate barriers such as buildings, walls, concrete, trees, and other barriers? It is true. Is it true or not, Professor?
Okay, so the question is 5G in general. If the question is 5G in general, then we could have different answers for different frequency bands. Yeah. If you're talking about earlier, I show you a diagram showing the possible frequencies that will be used for 5G in Indonesia, issued by the Ministry of Kominfo. Yeah. Of course, if you're using, let's say, 700 megahertz, then it's really can go anywhere, even indoors. Yeah, of course. But of course, the waves that we receive indoors will come from different propagation paths, come from different routes. For example, there will be one path that is reflection path from the wall of our neighbor's home, for example, and then there is another path coming from another neighbor's home from the other side, perhaps. Yeah. So everything will come inside and mixed up, yeah, into a signal that could be probably could be having a high level, or sometimes if the signals coming from different paths have a phase, yeah, an opposite phases, yeah, then those waves could distract one another, so that the level of the signal that we receive could be low. Yeah, but for 700 megahertz, there should be no significant problem. Yeah, but for the other band is the one that we call sub 6, which is around 2 or 3 gigahertz. We already have experience with 2 or 3 gigahertz. For example, now for our Wi-Fi, yeah, our Wi-Fi now, the access point for our Wi-Fi works at 2.4 gigahertz. So the behavior of the radio waves would be the same, yeah, as the one used in 5G for around 2 or 3 gigahertz. Yeah, the new thing that we will experience is the millimeter wave. Yeah, the 26 gigahertz. The 26 gigahertz cannot, I would say almost certainly, yeah, cannot penetrate the wall. Yeah, cannot penetrate the wall. The diffraction loss is very high. Yeah, so if you are really in a room, yeah, with walls, yeah, brick walls, for example, then what you have is a millimeter wave access point outside. Then there is a high probability that the millimeter wave could not reach you inside the room. Yeah. So because it cannot penetrate the brick wall, for example. Yeah. Okay.
Thank you, Professor. So we are talking about the other means, the other tool, the other apparatus. Now the questions coming are about the 5G and fiber optics.
Yeah.
Is 5G really better than fiber optics, or if not, is there any theory to make them equal?
We are talking about
5G and fiber optics.
That's because I think the answer, yeah, the answer does not only depend on the nature of the radio waves used in 5G and the optical waves used in fiber optics. Yeah, as I said before, the low latency of 5G happens not because of the use of the millimeter wave, but it's the result of the use of the edge computing technology. Yeah, so that's why the surface the users could get the surface that he or she wants more immediately. Yeah, when compared to, for example, the previous technology that doesn't make use of the edge computing technology. So it's not about the wave the wave frequency that are used, yeah, but more about how the technology is used in the network. Yeah, in this case, the edge computing. That's my answer, perhaps.
Yeah. Well, thank you very much for the explanation, Professor, and thank you very much for the question, Mr. Kemas Amando Ayub. Well, I think time is flying, Professor. Well, this is already 1 hour, and you have given us very mind intriguing, I think, mind intriguing material of presentation, and this is something new, and also this is also part of the development of our beloved country, Indonesia, I think, and your contribution is something. Well, ladies and gentlemen, the audience, before we close this session, let's give a big hand to Professor Gamantio. Thank you very much. Thank you very much. Thank you very much. Bye-bye, to see you again next time.
See you again.
Hope to see you. Bye-bye, Professor. Assalamualaikum warahmatullahi wabarakatuh. Yes.
The last one, sir.
Well, time has flown very fast now, ladies and gentlemen. I hope you're still staying to the end of the session. You still alert and attentive to this presentation. Now we're coming to the last but not least presenter from our home university, from our beloved Dian Nuswantara University. We are coming to Dr. Heru Agus Santoso. We'd like to make some greeting to the gentleman. Hello.
Hello.
Hello, Dr.
Sound is good. Hello.
Hello. Oh, you look great. You look great, but
okay, thank you.
Yeah. Okay.
This sound is good, right?
Smiling face doctor. Wow, that's very good. Yeah. Okay, Dr. Heru Agus Santoso. Before your presentation, I'd like to say something. That this is audience. This is Dr. Heru Agus Santoso. Yes, very young professional. Yeah, and very potential from our country, from Universitas Dian Nuswantara. He is an expert in something connecting to robots. We are talking about robots today. He is presenting to us a topic with the title Ontological Knowledge Representation for Smart Robot. So KR here is very noted in the world, and he is talking about this KR ontologically for the smart robot. Before that, we're going to show you to present to you some introduction about our expert. Please, Ms. Titin.
Okay, good morning, Mr. Heru Agus Santoso. I would like to read some brief bio of yours. Received PhD degree in Multimedia University, Malaysia. Mr. Heru Agus Santoso, also an active writer and peer reviewer of the International Journal of Knowledge-Based System, Elsevier, which has impact factor of 5. Current position, Dean Faculty of Engineering at Dian Nuswantara University. Being able to get several research achievement and academic position, he developed research environment between student and lecturer in IoT and chatbot lab. Dinus Automatic System of Hydroponic-based IoT, DASI, one of his research to fulfill Industry 4.0 in Indonesia, has anticipating failure in planting technique using water or hydroponics. Through this application, farmers can monitor their crops on various sites, such as humidity, room temperature, water pH content, water density, and even being able to automatically add water if the water in the reservoir is reduced or below a predetermined limit. And research interest of Mr. Heru Agus is ontology, semantic web, information retrieval, and text mining.
Wow, it makes me speechless. Yeah, Ms. Titin. Well, okay, Dr. Heru Agus Santoso. Now it's time for you to present your thoughts, so ideas about this robot, this KR, knowledge representation. Please make it convenient for 40 minutes. 40 minutes, please. And it will start from now. Thank you.
Okay, thank you for the nice introduction, Prof. Yu and Putitin. I'm going to share my presentation on the house of participants. Can we share my presentation?
Yes.
I want to share my presentation, but cannot. Sharing. Maybe the
okay. Please wait a minute. Yeah, maybe there is some technical problem here. Okay, just wait a minute. Maybe would like to sing something, make a poem.
Yes. Actually, before this time, I tried to.
Yeah. Permission is already granted. Okay.
Really?
Does it work?
Only host. I am not the host actually. How come I cannot share my presentation?
Okay, please wait a minute.
Maybe I can. Okay, wait.
Okay, while waiting for the technical problems, I'd like maybe you want to say something about what you are going to present today.
Yes, actually, this is part of my study, and this Isemantic 2021 team is quite connected to us since in this pandemic period, we can really grab a lot of opportunity, especially the government funding for our faculty. So the team is nice, very nice, and connected to ours. And what we are going to present is actually part of my research funded by the government. We got for about 2.1 million.
Wow.
And but only small chunk of the money going to the robot. Actually, we have several research funded by government. How come I cannot share the?
Not yet, sir. We're still working on it. Yeah. Okay. We're talking about the ontology, especially about the robot itself. Are you also interested in the future talking about the methods and also the significance of the robots in the future?
Yes, of course. Maybe someone already know that for about 5 months ago, I moved to faculty engineering, and we have to really shoot with the situation, especially for the research topic in faculty engineering. Before that, I was at faculty of computer science, and we can really apply the method, the approach in the computer science field to really fit the research in the computer and engineering, including robot. That's what we think, and I think I'm blessed because we can join the new field, but still really connected to my research interest. And robot become my next project because there are so many opportunities, especially in this pandemic period, since, for instance, the government need several services because of the spreading of viruses. And then robot become the solution.
I see. Yeah. Okay. Dr. Heru, could you please try to share again the material?
Maybe I share with someone.
Okay.
And then.
No. You try again.
Cannot. I don't know why.
Still not operable.
Yes. All who can share, only host, all participants. Yes, I can share the. I don't know why. This morning I tried, and then it really worked.
But we are still working on it. Yeah.
I don't know. So I will share to one of you, and then you can.
Maybe it will take time. Maybe you can present by what is it? Telling in
already worked
about the presentation. Yeah.
Okay, already worked.
Okay. Alhamdulillah. Finally, yeah.
Yes.
Yeah, it is something of a test for you.
Yes.
For us.
Okay.
Yeah, it's very interesting picture. Okay.
This is the robot we developed. We are developing right now for the Semarang city government, and the last is for the industry in the Klaten, for the government industry. And what we are going to cover in this presentation is what is knowledge representation and ontology is, and the standard from IEEE for ontology and for robot and automation. And we are going to discuss related work and discuss about our project. And then before we go to the how to represent the ontology for robotic, and then we have to make it clear what is actually the knowledge, right? So let's try. Maybe someone already presented to someone else and then explained what is knowledge, but we have to make it clear right now what is actually the knowledge. As you can see in the slide, we have set of truth, set of belief, and intersection between truth and belief. That is true belief.
Suara saya sudah nggak kedengeran kan?
What is out there in the world are the so-called set of the truth, right? The set of the properties that according with fact is the truth. But not all the truth we know, right? And then we come up with the belief. Belief is what we think in our head and what we think that is true. And among belief and truth, we have true belief. And everything we can call true belief actually not really become knowledge unless we justify it, right? So knowledge is justified through belief. So using the formal definition, we can say that someone knows that Q is part of the knowledge if and only if Q is true, as believe that Q is true, and as is justified in believing that Q is true, right? And then to represent the knowledge in the formal language, we need ontology. What makes formal important? What makes formal language become very important for representing the knowledge within in the robot domain is how can knowledge become understandable for machine and for human. As we realize that robot currently can communicate with a lot of devices like IoT, for instance, and then communicate with different type of robot, for instance. Moreover, currently robot can communicate with human and robot interaction. So formal language become very crucial in this situation. Okay, let me get closer. What is actually the knowledge representation is? In our previous slide, we just explained that knowledge is justified subset of all true belief, and knowledge representation is a way of explicitly represent knowledge for specific domain. And since AI become more influence in our daily activity, knowledge representation can ambiguously capture the semantic of domain represented by set of concept, properties, and relationship, right? Maybe someone still confused about concept, properties, and relationship. If we see it in the object-oriented paradigm, so concept closely related to the class, and properties how to characterize the class and the concept itself. Actually, just like attribute, maybe data type, something like that. And then relationship is how concept can relate to another concept. Example of concept, for instance, like fruit, right? Fruit is concept. And then man is concept. And instantiation of the concept is, for instance, you can say nanas, pineapple is an instantiation of the concept. So by using knowledge representation, machine hopefully cannot only able to read, but can understand the meaning of the knowledge itself. As we can see in the daily activity, computer can read HTML document, but actually computer cannot understand the meaning of the HTML document itself. That's why knowledge representation using formal language will explain the meaning of the knowledge. And we need a formal language. In our project, we use web ontology language standardized by triple WC. This is an example of ontology. We get closer to the definition of the ontology. For example, given the information, the price of Apple has increased 25% during COVID-19 pandemic. In our mind, we can easily understand the meaning of the sentence, but for computer, still not easily understand. What is actually Apple? Is that fruit? Or maybe is that smartphone? Or maybe laptop? That's why in the figure, we can see the structure of knowledge we can represent using ontology, and also we can really precise understand the meaning of the term in the sentence. For instance, we can understand the apple here is discussing about fruit, but we need to really focus on the specific domain we are talking about. That is about fruit and related physical object, for instance, vegetable and so forth. And this is actually the meaning of the ontology: explicit and formal specification of shared conceptualization. Let's discuss each term explicit in the definition. A conceptualization is an abstract model. We need the specific domain to identify relevant concept and their relation. And explicit mean the semantic, the meaning of the concept must be explicitly defined using formal language, right? And then formal need mathematical logic language so that machine can understand, can interpret the meaning correctly, not ambiguously. And then share, we have to share consensus about the terminology in the ontology, and the main task when we develop ontology is try to reuse the existing ontology in the related domain. So we can reuse instead of creating or maybe developing from the scratch by ourselves. And then we can save our time also, and then we share consensus about the ontology itself. So this is a simple definition about the ontology. Ontology is defined as a 7 tuple CRL, and AX, and so forth. You can define ontology by your own need and your own domain, but for the common definition, the ontology must be contain concept, relationship, and also axiom, because 3 main part of the ontology is concept, relationship, and axiom. And as you can see in here, once we knowledge represented using ontology, we can also say that kind of representation as a knowledge base, right? Knowledge base consists of 2 parts. They are TBOC. TBOC is terminological knowledge, like we discussed about in the database designing. we can say that this is the database schema, or maybe the structure of the terminological knowledge. And then in the right side, in the blue color, we can say assertional knowledge, or A-box. That is instantiation of the class. For instance, carbon dioxide is a instance from the class, and you can see in here carbon dioxide is a greenhouse gas. Based on this knowledge base, so we can identify the membership of the class within the knowledge base. And the reason why we use ontology for our research is because of IEEE standard for robotic and automation already established. And we can see in here IEEE STD 1872 trademark 2015 provide standard ontology for robotic and automation. This ontology taken actually from the sumo, the most common concept in the ontology, and then IEEE standard for robotic and automation provide the most general concept, relation, and axiom for robotic and automation development models. And this standard included reference for knowledge, representation, and reasoning in this field as a formal vocabulary for communicating among robot, among devices, and also human and robot interaction. So this is the IEEE STD 1872 trademark, consists of 4 sub-ontology: core ontology for robotic and automation, and then extension of the corrects, position, and air part. And we can use those ontology as the most common term used in our project. And actually IEEE STD 1872 is taken from suggested upper merge ontology, or SUMO. So this is we talk about our current project. As we have discussed before, we have explained it before. We developed a robot for the government of Semarang and for industry in Klaten, and the robot can interact via voice command. If time is available, we can demonstrate how the robot work using simulation, and then the speed of a robot should the speed of the applicant walking speed. So once the people work very slowly and robot just follow suit the speed of the applicant, and this robot will be applied in the mall pelayanan terpadu. The mall pelayanan terpadu is the mall for integrated services in the government of Semarang City. How the robot is work? Actually, firstly, they need to greet the applicant, and then try to assist which which services they need to solve in the government services mall. Firstly, the applicant takes the number of the queue, and then followed by the activation of the robot by taking RFID card. Once the RFID card taken by the applicant, and then robot will be activated. And then robot greet the applicant by saying selamat datang di mall layanan terpadu and so forth. And then after the applicant answer the question from the robot working toward, followed by the applicant to the counter of the services. And the speed of robot depend on the speed of the applicant while walking toward to the counter. So this is the related work, quite new actually in this field. As we can see in here, the most similar to our work is number 8, RP, Ontology-Based Knowledge Model for Human-Robot Interactive Services to 2020, actually still quite new, the research. And also we can see in here, Sabot also closely related to our project, high-level smart decision-making of robot based on an ontology in search and rescue scenario, number 5, and so forth. In their work, there are several tools used in the project. For instance, NoRob using OWL web ontology language standardized by WWC, and also using SWI Prolog. And then you can see in here, there are some different tools also. In the Sabot, they use OWL SWRL, Semantic Web Rule Language, Sabot here. We plan to use the Semantic Web Rule Language for our project, and also Sparkle. Sparkle is query for graph database. So we can integrate data from different resources. This is our schema of our proposed schema of the project. As you can see here in the screen, there are knowledge base consists of TBOK and ABOK. TBOK consists of schema of the knowledge base. We can organize to identify all of aspect of the robot activities, robot environment, and robot task or assignment. And then ABOK is the instance of classes exist in the knowledge base. By knowledge base, we can also extract the rule using semantic web rule language. And once the robot need to perform the task, and then the parser and reasoner proceed the task, and planner management using ROS, robotic operating system, will manage and then execute. And this is our approach. Ontology editor, we use Prodigy from Prodigy Stanford.edu. Language, we use Resource Description Framework Schema, RDFS, and OWL. Actually, RDFS is subset of OWL, Web Ontology Language, since the expressivity of the RDFS is part of the expressivity of OWL. And then query, we use semantic web rule language to integrate references rule into ontology. In our project, there are 3 sub-ontology we develop, we model. They are structure, environment, and assignment ontology. And as you can see in here, the structure ontology consists of three main subclasses relation. They are robot type, hardware, and software. Each of the class has to describe the properties, the characteristic of the classes, and then we can relate to the instance can be member of the class. For instance, for robot type, we have three type actually: service robot, transportation robot, and the last one is actually what we are discussing right now. That is accompanying robot. Accompanying robot means the applicant accompanied by a robot to get appropriate service. And then hardware perception devices like camera, line sensor, and then also we identify navigation devices like rotary encoder, accelerometer, gyroscope, and so forth. And also we have to identify the base devices like motor, wheel, and battery. Okay, so by developing model for robotic domain for smart robot, actually we can in detail describe where is the capability of the robot will be relate to the need of the government. For instance, in here we extract the knowledge from the ontology by stating several axioms. In here, for instance, location point is an environment. The axiom number one states that location point is an environment. And the second axiom in here, robot disjoint with obstacle. This is the expression of disjointness. And then in the last two axiom in here, robotic is environment. Environment is robotic environment. In the last two axiom, we actually state the equivalencies, the sameness of the entity among robotic environment and environment. So we use the same function about robotic environment and environment, because this is the two axiom state there are the equivalencies among those class. And also we identify aspect for better utilizing of the knowledge base by providing hierarchical structure to represent assignment by providing sub-ontology, for instance, monitoring task, mapping, chart assignment, and accompany. And today, actually, we discuss on this specific part, that is accompany, how to make knowledge base provide the accompany aspect while can be utilized by the robot. And for assignment modeling, for instance, in here we define as a 5 tuple, right? For instance, assignment modeling is a company. A company is assignment modeling for the robot. The company is method actually consists of several atomic activity We model with 5 tuple consists of name, parameter, entity, set of entities, and also the status, whether done, still on, or maybe postponed, or maybe need to be continued. And then example of the atomic assignment extracted from the company, we can have atomic assignment. For instance, in the greeting interaction is part of the assignment modeling, and also ready, sound, voice recognition, and so on. So based on the company activity, we can extract several atomic action, like we just explained it before: greeting interaction, keep distance, navigation, arrive interaction, and so forth. So that is actually the whole design of our company robot. And after developing the model, the knowledge base, we need to validate the inconsistency and several checking. For instance, validation of TPOC and EPOC after knowledge-based development, because we intend to develop the feature of the robot not in the fixed model, but after the need is after the need is need to be applied in the robot, and then we can extend our functionality. So once we extend the knowledge base, we need to validate the knowledge base using validation and inconsistency checking. And then also TPOC and EPOC consistency checking. The tool we use is reasoner like Hermi and Pele. We can check the incoherency in the TPOC. For instance, we provide example of definition. Given T as the T-box of ontology, T is incoherent if there is exists an unsatisfiable concept in the TPOC. So maybe it will make the TPOC is inconsistency, because this is there is unsatisfiable concept in our knowledge base because of the development of new features of the robot, or maybe the modification of the existing knowledge base for robot improvement. So I think enough for all the explanation from my side. And just for information, this study consists of several lecturer and student. My name is Heru, and Pak Pulung, Pak Ari, Pak Zainal Arifin, Pak Aris Jihan, Pak Helmi, Pak Arga, and Pak Alfir is part of our member. So enough from my side. Pak Yumanto, Bu Titin.
Yes.
Thank you.
Okay, thank you very much, Professor Heru. You're talking about the KR and robots. Yeah, there has been some kind of excitement and pride, but also there has been some fear. Some fear, yeah. Fear. This is a question from Ari Wibowo for the first. Somebody is talking about, if robots becomes the solution to support work in a company, does it reduce the employment in Indonesia? And what is the solution? This is a big question.
Yes.
Please.
We have to go forward with the research, right? And it must be consequence because of the developing of the robot, for instance, reducing the employee, right? And our solution is actually this is a condition that we cannot avoid. We cannot avoid for the situation. For instance, because of we need to improve the quality of the production, right? And to make efficient production. So robot becomes solution. On the other hand, it will sacrifice the employee, right? And then our solution is you need to I mean to
balance.
Yeah, to balance with the situation, because we can also equip ourselves with new capability, new competency, so we can apply for another job or something. So this is quite difficult for the government, especially because it will reduce I mean it will reduce the unemployment.
I see. Thank you for the wise response. Yeah. Thank you very much for the question, Mr. Ari Wibowo. And we're coming to somebody else. Well, we're talking about the use of robot to give command. What if the command given by the applicant to a robot is wrong? Then the repeat command over and over again, and the robot experiencing the error and not responding. So what should we do?
Question from Mr. Calvin.
Question from Mr. Calvin.
Yes, since we developed specifically the task of the robot, how the robot will work in the specific domain, right?
Yes.
So we can narrow the opportunity to make mistake by providing the knowledge base. This is actually our solution.
I see.
Maybe we can demonstrate a bit of how the robot work, and there are actually still some mistake, but we will improve. Yeah, for instance, how to capture the voice from the applicant. For instance, I will share the hopefully. I don't know. I cannot share anymore. Maybe from my side.
It's stuck again?
No. Okay. Can.
Yeah, it's working.
Just wait. Because I borrow the laptop from my wife. My laptop is Apple, cannot use the visual background. I don't know. Maybe quite old Apple, maybe.
Yeah. Well.
Okay.
Okay. At least, what do you think? From your expertise knowledge.
Yes. Pardon?
Okay. Maybe the illustration will be better, but maybe takes time. Now we're coming to somebody else, Bintang Nuswantoro, Mr. Bintang Nuswantoro, surely from Indonesia. Yeah. Although robotic advances are growing, there are certain skills that humans will do better. Yeah. Is it possible to combine the machines and the humans for the best performance?
In my opinion, it is very possible. It is possible to combine the expertise of human and take advantage of the expertise of the robot developed by the human. For instance, in terms of consistency, right? People less consistent with robot, but in understanding, people can better understand about the task. So we can combine both of the expertise to produce human and computer interaction for better achievement uh, for better job accomplishment, something like that.
Okay. Well, okay. Thank you very much. It's also another wise answer. Now, from
the question is
Mr. Wareh Adi Kusuma. Well, we need to be very careful because we're talking about robots, and Mr. Heru, you just very well. Is there a possibility that the robot will not or refuse to carry out the commands given?
Yes,
or is there something to do with the lack of the KR?
Yes, of course. Modeling is part of the is an effort to reduce the error, but still possibility to make a mistake for the one who haven't checked the consistency, for instance. That's why we propose to checking the consistency of the knowledge base after development, and the possibility of extracting rule from the knowledge base become wrong also. For instance, if we produce the new classes and then the class is not related to the current knowledge base, and then the rule extracted from the knowledge base become wrong also. So we'll produce wrong action, wrong task. I think this is very common actually in the research work before we really share, because we before we really can give to the customer, we have to really focus on the testing and focus on the improvement of the knowledge base.
Okay, thank you very much, Professor Heru. Well, it seems that there is a difference between toys and robots. Yeah, toys usually are for children, and robots are made especially for a special purpose. There is a question from Aditya, Mr. Aditya Tristianto. Do you think that robots are the solution to the needs of the old people?
Yes, I think so.
How about the younger people?
Young people more closer to the game. Yeah. Last night we have quite intense discussion with my wife. Actually, my wife is from nursing department, and her research focus is caring elder people, and the need for a robot companion is quite a lot. For instance, the robot can give message to the elder people when to take medication, right?
I see.
When to pray, and then maybe a companion robot can give some advices, or maybe can share the story, and then become a close friend to elder people. I think this is quite interesting. Maybe it will be next project to us.
Okay.
Okay, and well, from your humble presentation, I think maybe you will develop some kind of robot which is cooperative to human being, especially for nurses, right? Not robot which distract the humanity. I think very good, Professor Heru Agus. Well, there is another question here from Mr. Safik Muhammad. Do you believe that people are able to use robots well? We know that people in this country, maybe in some country, not only Indonesia, often perform actions, vandalism, whatever, often cause damage to the public facilities provided by the government. What do you think? If robots are everywhere in our country, and then vandalism is also everywhere in the country, well, the public facilities will be easily damaged. What do you think?
Yeah, actually, this is not a technical aspect of the robot actually. So we have we have difficulty.
That's why this
to
is called
answer.
the fear. This is called the fear, sir.
We have difficulty to answer that such question.
Yes.
We cannot easily answer the question because we have to stand for many aspects, especially for the government rule, to help us to keep the services available and work. I think we need government, we need regulation, and also the behavior improvement of the society, I think.
Okay, well, thank you very much. Thank you very much, Dr. Heru. Well, only that in the beginning, we are talking about the robots will have two impacts, positive and negative. That's we are talking about it. And I think we need to be thinking about it very wisely in the future. But we need to keep the passion of the researchers grow up, right? And it's just what you said in the beginning. Well, I think we are running out of time, Dr. Heru Agus Santosa. So, well, it is easier to say hello than to say goodbye. But you've been, presenting something updated, something robotic, and something of, I think, highly interesting for the humanity. Yeah. Thank you very much. Well, ladies and gentlemen, the audience, please give a big hand to Dr. Heru Agus Santosa.
Sorry, waiting for so long time is quite tiring. Maybe some of thing in my head already gone.
Still, next time you're in the first, hopefully. Thank you very much.
Yes,
thank you very much. Maybe you have some concluding statement for the audience.
Okay, thank you. Actually, what we are present today is still in the very beginning of our study. That's why we are still focused on modeling of the robot. So we need to really focus on this part because this is become the foundation of the whole robot dimension, and also will produce solid robot, become solid robot research. I think it's enough for my side.
Thank you very much. Thank you very much again. Thank you very much again. Bye-bye. See you again next time.
Yeah, thank you.
Dr. Heru. Yeah.
Thank you so much. Hopefully I can explain well.
Well, it's been quite a long day. What a long day. I believe that you are staying to the end of this program. Before we are saying goodbye, I'd like to say something. These 4 topics are interesting. Hopefully, you've been enriched with these knowledges and also the skills presented by the experts from the world. Well, ladies and gentlemen, it is so sad that we have come to the end of this plenary session. We have willy-nilly to say goodbye. We thank you very much that you are still staying to the end of this meeting. We hope that you have enjoyed your virtual time with us, and that you have learned something today, or probably lots of things. Titin.
As Prof. Jumanto said earlier, it is easier to say hello than to say goodbye. But sadly, we have to part and say goodbye now.
On behalf of the committee, we would like to submit our apology for everything that we have done wrong, or any shortcomings during the virtual plenary meeting today. Titin.
Okay, please stay safe and sound, and we hope to see you again in the 2022, maybe, on Isemantic, to come at our university, the Nusantara University.
Well, I have something last to say. East or west, home is rest. Isemantic is best, don't leave us. Gadis cantik suka merayu, Isemantic selalu kurindu. Goodbye, everybody. See you next year. Wassalamualaikum warahmatullahi wabarakatuh.
Okay. Goodbye. We would like to bring it back to the MC.
Yeah.
Okay, ladies and gentlemen, before we close with the seminar, we would like to announce an information regarding the parallel session. Reminder for all authors that the parallel session will be held 2 times. The first parallel session will be held at September 18 at 1 p.m. and the second parallel session will be held at September 19 at 9 p.m. Honorable ladies and gentlemen, it has been a great moment and experience to be a part of this international seminar. Our deepest gratitude to Allah Subhanahu wa Ta'ala and also to all the keynote speakers for mind-sparking discussion, to all the guests, moderators, and all authors and participants of Isemantic 2021. Our sincere apologies for all the inconvenience and thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.